In today's video, I'm going to be showing you how to make an efficient tower defense game. Now, the first thing you may notice is that this tower defense game does not send any data or receive any data from the server and client. So if we look at the server side, we can see that we cannot see no NPCs or towers, but this does not mean we're relying on the client for any information. The server runs the game in scripts without showing what it's running to the clients, totally independent from the clients. So even though we're going to be creating a tower defense game, this video is going to be covering many topics. So even if you're not making a tower defense game, there's many topics in this video that may come in handy for creating your own games. For instance, we're going to be using single script architecture. We're going to be creating our own task scheduler. We're going to be using linked lists and creating our own event system. So there's a lot of topics that's going to be covered in this video. Another thing we're going to do is create a deterministic game. This means that the outcome of the game is predetermined. This allows the clients and server to run the game independent from one another and all having the same outcome. Now here it says there is no randomness, but we are going to have pseudo randomness, meaning that we're going to use seeds to generate random numbers on each client and the server, and all of them are going to generate the same random number. So the way our game's going to work is we're going to have an array of C frames. So each one of these green dots is a C frame, and we're also going to have our own custom game loop. So on the first game loop, our NPC is going to start on the first C frame, and then one game loop later, it's going to move to the next C frame. One game loop after that, it's going to move to the next C frame, and one step after that, it's going to move to this third C frame, and the client's going to do the same thing. So on the first game loop, the NPC is going to start here. One game loop later, it's going to move it to this C frame. One game loop later, can move here, and one game loop after that is going to move here. So after 3 game loops, both the client and server have the NPC at the exact same C frame. And the way towers are going to work is, let's imagine that we have a tower over here, and let's imagine that the range of this tower is something like this. Then what we're going to do is we're going to find the closest C frames to when the character enters and exits the tower. So let's say that this C frame over here is when the character enters the tower, And this C frame here is when the NPC leaves the tower. So as every game tick, this NPC is going to continue to step to the next waypoint, the next C frame, and to the next C frame. Now when the NPC reaches a C frame, it's going to fire a event, and when the tower receives this event, it's going to add this NPC to a list of NPCs that are within range. So once this NPC touches this C frame, reaches this C frame, it's going to tell the tower that I have now entered within range. So now, depending on the tower's attack speed, so this tower may attack every tick, or every 10 ticks, or every 100 ticks, depending on how quickly we want the tower to attack. But let's assume that this tower attacks every tick. So it's going to attack, then the NPC is going to step to the next C frame, it's going to attack, the NPC is going to step again, it's going to attack, and so on until either the NPC dies or the NPC gets to this C frame. When the NPC gets to this C frame, it's going to fire another event, which is going to tell the tower to remove this NPC from its attack list. And once the NPC has been removed from the attack list, this tower is no longer going to attack that NPC every tick. And every tick, the NPC is going to continue to walk from one C frame to the next, and once it reaches the last C frame, the NPC gets destroyed. And the way the server is going to replicate this tower to all the clients is it's going to send a remote event telling the client the C frame of the tower and the name of the tower of what one's going to be spawned. And it's also going to say the enter and exit waypoints. So it's going to say add a enter waypoint over here and add a exit waypoint over here. And another thing it's going to say is which tick this tower needs to be built on. So currently this client is on tick 3, and the server may say to build this tower on tick 10. And the reason for that is if one client has a high ping and the remote event takes longer to get to them, instead of all clients building on as soon as they get the remote event, which could be on different ticks from one client to the next, if the server tells all clients to build the tower on tick 10, that should give enough time for the remote event to get to all clients and allow all clients to build the tower on tick 10 so that they all stay in sync. And the server will also build the tower on tick 10, so the server will also stay in sync with all the clients. Okay, so now I've created a base plate project, and the first thing I want to do is create a module loader. So the way I'm going to organize this project is I'm going to have a single script, and the job of that script is to simply load all the modules. And then I'm going to have all the game logic within modules. Now I first want to start with the client side, and then once we've completed the client side, I'm going to move on to the server side. So to have our module loader on the client side, we have a few options. For instance, inside of starter player scripts, we could create a local script and have this script load all the modules. Or another way would be to have a script placed in replicated storage. So let's create a script. And then when we select the script, we want to set the run context to client. And this is going to allow this script to run inside of replicated storage. And what I'm going to do now is rename this script to be called modules, and any modules we place within this script is going to be automatically loaded by this script. So to do this, what I'm going to say is for index descendant in script get descendants do, and then I'm going to say if descendant.className is equal to module script, then I'm going to require that module and save it into the shared table using the module's name. Then once we've required all the modules, I'm going to loop through the modules once again, and if they have a function called initialize, I'm going to call that function. So over here, I'm going to say for index module in shared do, and I'm going to say if module.initialize is a function type, then call the initialize function. Then once we've called the initialize function for all the modules, then I'm going to loop through the modules once again, but this time I'm going to call the start function. So first we require the modules, then we loop through again and call the initialize function, and finally we loop through again and call the start function. But you may have noticed that over here we call the initialize function directly, where over here we use task defer to call the start function. And the reason for that is if we have a wait or a asynchronous function within this initialize function, it's going to prevent this module loader from continuing until all the initialize functions have returned. And then we can ensure that the start function is only called once all the initialize functions have completed. Okay, so our module loader has now been completed. Let's create 3 folders within the module loader so we can split our modules into 3 groups. So I'm going to create a folder, another folder, and another folder, and I'm going to name this first folder classes, data, and finally objects. Okay, let's now make a template class module so we can use that every time we want to create a new class. So inside of here, I'm going to create a module script, and I'm going to name this module script class. And I'm going to rename module to be called class. And then I'm going to say class.__index equals class. And then I'm going to say function class.new, and I'm going to create a new object within the new function. And then I'm going to return the object. Okay, this is our template class module. So we've now completed this. Let's now create a template object module. So I'm going to create a new module script, and I'm going to name this object. Now inside of this module script, I'm going to rename module to be called self, like so. And all I'm going to do in here is connect a function to initialize and start. So over here, I'm going to say function self.initialize, and over here, I'm going to say function self start. So when the module loads these modules, it's going to find this initialize function and call it, and it's going to find this start function and call it over here. So let me try to explain what the difference is between an object and a class. The job of a class is to create objects. So if we need many objects of a specific type, we can create a class where we can continually call the new function to keep constructing new objects. But if we don't need many objects and we only want one object, a single object, then there's no point having a class to continue to create new objects. We only need one object, and that's what this object module is over here. This is a single object, and we cannot create more of them. We can only have one of them in our entire game. And if you want more information on this subject, you can search for singleton pattern, and we can see it says the singleton pattern is a creational design pattern that ensures a class has only one instance and provides a global access point to this instance. It is often used when exactly one object is needed. So what I want to do now is create a custom task scheduler. It's because we're going to have our own game loop. So what I'm going to do is, because we only want one object, one task scheduler, we don't want many, so I'm going to make it a single object. So I'm going to duplicate this object and I'm going to name it task. And inside of here, what I'm going to do is create 2 new functions for this task object. The first function is going to be called start. Now let's not confuse this with this start. This is going to have a capital S, where this start only has a lowercase s. So the module loader is going to find the lowercase s start, and this start has a uppercase, We're also going to use a colon here. That way, when we call this function, we must call it with self with a colon, not a dot. And after this function, I also want another function called stop. So this is going to start the task scheduler, and this is going to stop the task scheduler. The next thing I'm going to do is add another function, and it's going to be called loop. And what we're going to do is when we call the start function, we're going to connect the heartbeat event to this loop. And when we call the stop function, we're going to disconnect the heartbeat event from this loop. Another thing you may notice is that the start and stop functions are stored within self. This makes this a public function, meaning that any other module can access these functions. But this function over here is not placed within self. It's a private function, meaning it cannot be accessed outside of this module. I'm now going to create a private variable called connection, and it's going to be equal to nil. Then inside of this start function, I'm going to check the connection, and if it's not equal to nil, I'm going to say return false. That means we unsuccessfully started the task scheduler. And if connection is equal to nil, then I'm going to create a new connection. So I'm going to say connection equals game get service, run service, heartbeat, and I'm going to connect the loop function. And then I'm going to return true, saying that we successfully started the task scheduler. Now inside of the stop function, I'm going to do another check saying if connection is equal to nil, then return false. That means the connection does not exist. So we can't stop the scheduler because it has not been started. And then I'm going to disconnect the connection if the connection does exist. And then I'm going to set connection to nil. And finally, I'm going to return true, saying that this stop function was successful. Okay, so we now have a loop function that will loop every heartbeat, but the problem is this loop will run at different rates for different clients. Some clients may run this loop faster and some clients may run this loop slower. Now, normally we would normalize this discrepancy between clients by using delta time and then simply multiplying whatever we're doing by this delta time to normalize the loop. But for our deterministic game, using delta time is not going to be good enough to keep all clients and the server perfectly in sync. So I'm going to remove delta time, and what I'm going to do at the very top, I'm going to create a new local variable, and I'm going to call it ticks per second. And for now, I'm just going to set it to 1. And then when we call the start function, I want to save a time describing when this scheduler started. So over here, I'm going to say start time. And then I'm going to save the start time into self, the task object. Now, by saving it into self, it makes it a public variable versus these variables up here are private variables, meaning that these variables cannot be accessed outside of the module, while this start time variable can be accessed outside of this module. And finally, I'm going to use the ticks per second and start time with workspace get server time now to calculate the current tick inside of the loop. So I'm going to say local current tick equals, and to work out the current tick, we're going to get the delta between the start time and server time. Then once we've worked out the delta, we're going to multiply it by ticks per second. And finally, we're going to round the value to calculate the current tick. Now I'm going to print current tick like so. And now, so that we can see this printing, let's start the scheduler. So over here, when the module loader calls the start function, let's call this start function. So I'm going to say self start. And for the start time, I'm just going to pass the current server's current time like so. And I'm going to press play. And we should see that it keeps printing every heartbeat, and once every second, the value, the current tick, increases. So this current tick value is telling us which tick we should be on, but we currently don't know what tick we're currently at. So what I'm going to do is inside of initialize, I'm going to create a new public variable inside of the task object, and I'm going to say self.tick equals 0. Now, when we stop the scheduler, I want to reset the tick back to 0. So over here, I'm going to say self.tick equals 0. And then what I'm going to do is over here, after we get the current tick value, I'm going to check to see if our tick value is less than this tick value. So I'm going to say if self.tick is more or equal to current tick, that means we're currently up to date, we can just return and do nothing. But if we're not more than or equal to current tick, then we need to increment our tick to catch up to current tick. So over here, I'm going to say while self.tick is less than current tick, and inside of this loop, I'm going to add 1 to tick. And what I'm going to do is move this print inside of here, and I'm going to print the tick that we're on. And if we now play the game, we should see that unlike before, it doesn't print every heartbeat event, it only prints every tick. So we only get one value every second. Now, because we have this while loop here, this means that it's possible for there to be multiple ticks in a single heartbeat event. So a client is able to do multiple ticks in order to catch up to the current tick if they're falling behind. Now, to demonstrate this, what I'm going to do is say ticks per second, and I'm going to change this to 120 ticks every second. And then over here, I'm going to say local counter equals 0. And then I'm going to say counter plus equals 1. I'm going to comment out this print. Now, printing is quite an expensive operation, so I don't want to do this every heartbeat because it's not going to allow me to reach 120 frames every second. So what I'm going to do is say if math.random is less than 0.1, then print counter. End. And if I now play the game, we should see that on average it prints 2. And if I go into game settings, and here we can see that my frame rate is set to 60. But if I change it to 120 frames a second, we could see that now it prints predominantly the value of 1 because it's able to keep up with the ticks per second. But if I change this back down to 60, now we can see it does 2 ticks every heartbeat in order to catch up with the 120 ticks per second. Okay, let's now remove everything we've added. So let's remove the print counter. Let's remove this counter plus 1 and this counter equals 0. And let's change ticks per second back to 1. So what we need now is an event system so that every time the task scheduler ticks to the next tick, it fires the event, and any other module that connects to this event is able to detect when we get to the next tick. So let's now create our event object. But we don't just want one event object, we want many event objects. So we're going to create an event class, not an object. So I'm going to duplicate this class and I'm going to name it event. Now, before we start making our event class, I want to say that using dictionaries in deterministic games is almost never safe. So what that means is when we iterate through a dictionary, the order that we iterate through the dictionary is undefined. So what that means is if we use a dictionary to store our connections in our event class, and we fire an event and iterate through the connections to fire the functions, if we are using a dictionary, the order that these functions are going to get called is going to be different from one client to the next client. And this is going to cause the clients to go out of sync. So I'm going to be using a linked list so that the connections fire in the same order for all clients. Now, if you're not too sure what a linked list is, it's highly recommended that you watch my linked list video before continuing on this video. Now, we're going to actually create two separate classes, one called event and one called connection, because when we connect to an event, it's going to return a connection object. Now, we could create two separate modules, for one for the event and one for the connection, but I'm going to merge both classes into a single module script because these classes are kind of small, so it's not really worth having two module scripts for these two small classes. So to do this, instead of having class equals table, what I'm going to do is say local event class connection class equals table. So it's the same as this, but we can have two separate classes. And then, just like we did here, we're going to set the underscore index for these two tables. So I'm going to say event class dot underscore index connection class underscore index equals event class connection class. And now we can delete this. And over here, I want to return the event class. And for the new function, we're going to have it on the event class. Event objects are going to have two functions, connect and fire, and connection objects are going to have one function called disconnect. So let's now create these functions. So over here, I'm going to say event class, and I'm going to create a connect function. And this is going to receive a function. It's also going to receive a perimeter, and I'm going to explain why in the future, but for now, let's just skip this. And the next function is the fire function. So let's create a fire function. And now, not for the event class, but for the connection class, we want to create the disconnect function. So connection class, disconnect. Okay, so now we want to make our linked list. But to do this, I'm just going to simply copy the code from my linked list module. So let's go to Toolbox, and under models, I'm going to search for Soupy. And I'm going to find my linked list module, which has my name, 5UPHI. I'm going to click, press OK. Then I'm going to move this module into classes, and I'm going to rename it list. Okay, so now we have a few ways we can go about doing this. If I open my list module, and we can see it has a new function to create a new list. And because we placed this list module inside of our module loader is going to place this module into shared. So we could create a list simply by saying self.connections equals shared.list.new. And when we call this new function, it's calling this function over here, which is going to create a list and set it to this connections value. But I'm not actually going to do this. I'm going to just simply copy the code from our list module into our event module. So I'm going to copy these two lines and paste them over here like so. So now this event class object that's created becomes a list. And for the connect function, I'm just going to copy the insert back function. So I'm going to copy and paste this into the connect function. Now over here, we have a link, which is normally passed in, but the link is going to be the connection. So I'm going to say local connection equals table. Then I'm going to say connection.next equals self, connection.previous equals self previous. And over here, I'm going to change the link to connection. Over here, I'm going to change this to connection. I'm going to change this to connection. And over here, instead of link class, I'm going to set it to connection class. And I also want to store the function and perimeter inside of the connection. So over here, I'm going to say connection.function equals func. And then I'm going to say connection.perimeter equals perimeter. I'm going to use a uppercase P over here. Okay, so now inside of this fire event, I want to iterate through the connections and call the function for each connection. but I want to iterate through the connection in reverse order from back to front, because if we connect a new connection during the fire, I don't want that new connection to get fired in this fire event, but to get fired in the next fire event. Now, if that's kind of confusing to you, then you need to go and watch the linked list video, because I cover that in that video. But to do this, first I'm going to say local connection equals self.previous. So self.previous is going to link to the last connection in the list. And then I'm going to say while connection is not equal to self, and then I'm going to say connection is equal to connection dot previous, not next, because we're going to go back. So we need to go back to the previous connection. Now you might be wondering is why are we checking if connection is not equal to self here? Should it not be connection not equal to nil? And because this is a circular doubly linked list, and the event is going to be at the head of the list. So what that means is here we can see our linked list, and here we can see the event class, the event object, and here we can see the green dots are connection objects. So the way it works is this event object is going to have a previous and next, and its next is going to point forward to the next connection, and its previous is going to point backwards to its previous connection. And these connections are also going to have a previous and next, so it's going to point back to the event object and point forward to the connection object. And this is going to point forward, and it's going to go next, 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 next. And this last object is going to have a next that points back to the event object. So it's a circular doubly linked list. And this event object is going to be inside of the linked list. So over here, when we get to the end and we go to the previous, so when this object we get its previous, which points to the event object, we can say if you're not the event object, continue to loop backwards, but once you become the event object, stop looping backwards. Okay, so what we want to do now is over here, while iterating through the connections, I want to call the function. But to do this, I'm going to do thread recycling. Now, if you're not too sure what thread recycling is, that means you haven't watched my linked list video. So if you go back and watch my linked list video, it's going to describe what thread recycling is and how it works. But if you haven't, you're not going to understand this next part of the video. So the first thing we're going to need is an array of threads. And then we're going to need two functions, one called thread, one called call. And over here, we're going to either recycle a thread or we're going to create a new thread. So to do that, I'm going to say task.spawn table remove threads or create a new thread using the threads function. And we're going to pass the function that we stored inside of the connection. And then we're going to pass the parameter that was passed into the function. And finally, all these parameters that were passed into the fire function are going to get passed over here, and it's going to get called over here. Okay, let's now finally finish the disconnect function, and I'm just going to copy that from the linked list module. So I'm going to go down to the remove function, and I'm going to copy and paste this into disconnect. Okay, we've now completed our event class. So let's now close the list class and event class. And I'm also going to delete the benchmarks and example script from inside of the list class. But I'm not going to delete the list class because we're going to use it in other areas in our game. So let's just keep that there for now. Okay, let's now create our events for our task object. So over here, when we initialize the object, after we set ticks to 0, I'm going to create a new event and I'm going to call it onTick. And I'm going to use shared event.new to call the new function over here. And then I'm going to create another event and I'm going to call this one post ticks. And I'm going to create a new event like this. Okay, so now over here, when we increment tick by 1, I'm going to fire the onTick event. So I'm going to say self onTick fire, and I'm going to pass the tick number into this function. And then once we've gone through all the ticks, at the very bottom, I'm going to fire post ticks. Now, you may be wondering is why do we have two events, one called onTick and one called post ticks? Now, if we remember from before, this while loop can happen multiple times if the heartbeat event is running slower than the ticks per second. So this onTick event can fire multiple times in a single heartbeat event, where this post tick event can only fire once. And so let's imagine that we have an array of C frames, and the NPC is going to move every tick from one C frame to the next. So the NPC starts here, one tick later, the NPC moves here, one tick after that, the NPC moves here. Now, if the client is running slow, it's possible that if an NPC was here, it could have two ticks in a single heartbeat event. Now, when a NPC moves from here to here, there's no point updating the NPC's C frame to go here, because it's only just going to move to here within the same heartbeat. So that allows us to update the NPC's C frame in post ticks, so we can be more efficient and only update the NPC's C frame index when inside of the tick event, and update the NPC's C frame on the post ticks. Okay, let's now test to make sure that these events actually work. So what I'm going to do is, instead of testing them inside of the task object, I'm going to create a brand new object. So I'm going to duplicate object, and I'm going to call this new object game. Now I'm going to open the new game object, and I'm going to put this to the side like so. And what I'm going to do is, instead of starting the task scheduler over here, I'm going to start the task scheduler from the game object. So I'm going to cut and paste this over here. Now we don't need this start function anymore, so we can just remove it and not have it anymore. And over here where it says self start, well, that's not correct because this game object doesn't have a start function. We need to call this start function inside of the task module. So to do that, we can say shared.task start, and that's going to call this function over here. And now we want to connect to this onTick event. So over here, I'm going to create a new function. I'm going to call it onTick. Now, this is going to receive two parameters. For the first parameter, I'm just going to call it P1. And the second parameter is going to be this tick value that we passed into the fire function. So over here, I'm going to say current tick. And inside this function, all I'm going to do is print current tick. And now I'm going to connect to the onTick event. So over here, before we start the scheduler, well, it doesn't really matter. We could connect to it after or before. It's not going to have much effect, but I'm just going to do it before. I'm going to say shared.task.onTick connect. Now, if we look at our event class, remember when we connect, we pass in a function and a perimeter. And remember that this perimeter is going to be passed back to the function as the first value. So that's what this P1 is, if you forgot what it was. When we connect, we're going to pass in the onTick function. And then if we want to, it's not mandatory, we can pass in any value here, and this value is going to get passed over here. Or if we just keep it as nothing, then this value is going to be nil. Now this is kind of confusing, but this does have a use case further on in the video. So let's just ignore it for now, but in the future, this is going to come in handy for some things that we're going to be doing. Okay, so hopefully that's not too confusing. So we have a task object, and when this object is initialized, it creates a onTick event and postTick event, which is called over here. And then we have a start and stop function that starts and stops the scheduler. Then we have a game object, and when this game object's start function is called, we connect to the onTick event. Now we remember that initialize gets called before the start function. So this part of the code has completed by the time this start function gets called. So that's why we can be certain that this onTick event exists here. Then we connect to it, we connect this function, and we're simply printing the tick value that is passed over here. So let's now play the game. And we should see it prints the tick values, which is from over here. And if we change the ticks per second to 10 ticks per second, and we press play, we should see that it prints a lot quicker. And we should also see that if I change this back down to 1 tick per second, and if I set the start time to be the current time -10 and play the game again, we should see a burst of ticks at the start. So you see we've got 10 ticks as soon as the game started, and then from there on it ticked 1 second at a time. And that is because the start time was from the past. So in order to catch up to the current tick, it had to quickly tick through many ticks in one go. Okay, let's now remove this -10. And I want to add 2 more functions to our task object. And the first function is going to be called wait. And the second function is going to be called delay. So this task wait and task delay function are going to work just like Roblox's task wait and task delay functions, but unlike Roblox's task wait and delay functions, instead of taking in seconds, it's going to take ticks. So if we tell the scheduler to wait for 2 ticks, it's going to yield the current thread for 2 ticks before resuming, and delay is going to wait for a certain amount of ticks before calling a function. So the first thing I'm going to do now is at the top of our script, I'm going to create a new dictionary called task lists. And this is going to store lists of tasks that need to be resumed when we tick through the ticks. So over here, when we call the wait function, I'm going to calculate the tick that this task will need to resume on. So to do that, I'm going to say local scheduled tick equals the current tick value plus the amount that we pass into the wait function. Now, if we pass a value that is lower than 1, I want to clamp the amount to go up to 1 so that we don't have a negative or 0 value for amount. And then what I want to do is get the list from the task list dictionary using this scheduled tick number. So over here, I'm going to say local task list equals task lists, and I'm going to use the scheduled tick as the key. Then what I'm going to do is say if task list is equal to 0, that means there were no tasks added for this tick. I'm going to create a new task list and I'm going to add it into the task lists dictionary. So to do this, I'm going to say if task list equals 0, then create a new task list, and we're going to use the list module. We're going to call this new function to create a new task list, and then I'm going to store this list inside of the task lists dictionary using the scheduled tick as the key. And now that we have a task list, let's insert a task to the back of this list. So over here, I'm going to say task list, insert back. Now, if we look inside of list, we can see there is a insert back function. So we're going to call this function and we're going to pass in a table. And in this table, we're going to store the thread of whoever called this wait function. And then finally, we're going to do return quarantine yield. So it's going to yield here until we resume this thread. And once we resume it, it's going to return whichever values we passed into this resume back to whoever called the wait function. So now, after we call the onTick event, I'm going to try to get the task list from the task lists dictionary. So to do this, I'm going to say local task list equals task list, and I'm going to use the tick as the key to find the task list. And then I'm going to check to make sure that there are any tasks. There is a list here. So I'm going to say if task list equals 0, then just continue and skip this loop. But if there is a task list, what we're going to do is get the first task in the list. So to do this, I'm going to say local scheduled task equals task list dot next. Then we're going to loop through this task list. So to do this, we're going to say while scheduled task is not equal to task list. So this is essentially the same way we loop through the list over here. And then what I'm going to do is say scheduled task equals scheduled task dot next to get to the next scheduled task. And then I want to remove this task list from this dictionary, because if we don't remove it, we're going to get a memory leak. So over here, I'm going to say task lists using the tick as a key equals nil. Okay, so now when we loop through the tasks, I want to resume this thread that we stored in this table inside of this scheduled task. So to do that, over here, I'm going to say task.spawn scheduled task.thread, which is the same key as this over here, which is going to give us the thread that was yielded. And I'm also going to pass the current tick value back from this yield to whoever called this wait function so they can get the tick value. Okay, let's now make our delay function. So this delay function is going to work almost identically to the wait function. So we can pretty much copy and paste most of this code. So first we're going to get the scheduled tick. And then we're going to get the task list. And then if the task list does not exist, we're going to create the task list and add it to the dictionary. So let's just copy and paste this over here. And now this part is slightly different. So we're going to insert the task into the back of the list, but we're not going to store the thread because we're not going to yield the thread. We're just going to store the function and the parameters that we passed into this delay function. And then we're going to return this thread back to whoever called this delay function so that they can cancel it if they want to stop it from resuming. So over here, I'm going to say return task list, insert back, and we're going to create a new task, just like we did over here. But instead of storing the thread, we're going to store the function, and then we're going to store the parameters in a table. So we're going to wrap these three dots in these brackets to convert it to a table. But now over here, instead of resuming the thread, sometimes some tasks are going to have threads in them and some tasks are going to have functions in them. So over here, we need to do a check. I'm going to say if scheduled task.thread, then we're going to spawn that thread. Else, we're going to call this function. But when we call this function, I want to create a new thread, but I want to recycle threads the same way we did inside of this event class. Now, one way to do this would be to have a separate list of cached threads in our task object, but a better option would be to have a global list of cached threads. So what I'm going to do is I'm going to create a brand new object called threads, and it's going to do essentially the same thing that we've done here and allow any other module to call a function inside of this threads object. So let's duplicate object, and I'm going to name this threads. And now what I'm going to do is open this new object, and this new object is not going to have an initialize or start function, so we can just remove this altogether. And then I'm going to cut the threads array from the event class, and I'm also going to remove these two functions and place them in this new threads object. And inside this threads object, I'm going to create two new functions. So I'm going to say function self spawn, and it's going to receive a function and parameters like this, and it's going to do the same thing that we did here. So I'm going to cut and paste this over here, but we're going to simply pass in the function and the parameters like so. And I'm going to do another one of these functions, and I'm going to call this one defer, and it's going to do the same thing but just defer instead. Okay, so now that we have our new threads object, let's update the events class to use this threads object. So over here, what I want to do is say shared.threads spawn, and I'm going to pass in the function that was stored inside the connection, then the perimeter that was stored inside of the connection, and finally the parameters that were passed into the fire function at the end over here. And now our event class works the exact same like it did before, but the only difference is instead of having the threads stored inside of this class, we have split it out into its own separate object, and that's going to allow us to also call these functions inside of our task object. So let's now go back to the task object, and over here, so if the scheduled task has a thread, we spawn that thread, but if they have a function, then we're going to use this spawn function over here and recycle a thread to call this function. So to do this, I'm going to say shared.threads spawn, and I'm going to pass the scheduled tasks function that we saved over here. And then this array of parameters that we stored in this parameters value over here, we're going to unpack the table into a tulip and pass all them parameters into the spawn function. Okay, so we've now completed our task object. So let's close these other scripts and let's open the game object. And inside of this game object, we're going to test the wait and delay functions to make sure that they're working correctly. So I'm going to comment out the onTick connection. I'm also going to comment out this function over here. Now, before we start the task scheduler, I'm going to add a delay. So I'm going to say shared.task delay. Now we first need to pass in the amount we want to wait. So I'm going to wait 8 ticks. And then we need to pass in a function to be called. So I'm going to make a new function and I'm going to call it on delay. And I'm going to get all the parameters that this function returns, and I'm going to print delay and all the parameters that were passed into this function. So let's pass the onDelay function into the delay function over here. And over here, I'm going to create a while true do loop. And then at the top of this loop, I'm going to use the wait function. So I'm going to say shared.task, and I'm going to call the wait function. And I'm going to wait for 5 ticks. And then I'm going to print wait. And I'm also going to place this wait inside of here. So whatever gets returned from this wait also gets printed. So I've now run the game. Now, because we only have 1 tick every second, it should take 8 seconds to get the delay, which worked correctly. And we can see that nothing else was passed into here. And then we have the wait that prints every 5 ticks. So we can see 13, 18, 23. Next one should be 28. Next one should be 33. And if I wanted to, I could create another delay. And let's give this one a value of 20. And let's press play again. So what we should see is on the 8th tick, this delay gets printed. Here we can see the first tick that will happen on the 8th tick. Then after 5 ticks, there's a wait on 13, because 8 plus 5 is 13. Then we have another tick at 18. Then we have this delay that happened on the 20th tick. So we should see now we have two separate waits loops happening. The ones that end with 3 and 8 are from this delay, and the ones that end in 0 or 5 are from this delay. And it's also possible to cancel delayed functions. So if we remember, our list has a remove function over here. And so over here, when we call the delay function, we return the inserted task back to whoever called the delay function. So let's copy and paste this. Now in this function, I'm going to pass in A, and in this one, I'm going to pass in B. But over here, I'm going to save this value that gets returned back. So I'm going to say local scheduled task equals, and then over here, I'm going to cancel this scheduled task, and to cancel it, we just call the remove function like this. And that's going to cancel this delay from ever taking place. So let's now play the game again. And we should see this delay fire first. And once we get to tick 20, we should see the A one get printed, but not the B one. Here we can see delay A got printed, but delay B never got printed. So let's now do the same, but this time let's comment out this remove and press play. And we can see that delay A and B both get printed because we never removed it from the scheduler. Now, there's one last thing I forgot to add to the task scheduler, and that is when we stop the scheduler, I want to clear this dictionary of any tasks remaining before we set tick back to 0. So over here, I'm going to say table clear task list. Okay, let's now work on our path. So I'm going to close the task object, and inside of workspace, I'm going to create a brand new model, and I'm going to name this model path. And for this model, I'm going to set the streaming mode to persistent. Now persistent works just like atomic, but it's going to stream in as soon as the player enters the game, even if they spawn very far away from this model, and it's never going to stream out. And because it's going to be atomic, that means any children of this model are going to stream in at the same time that the model streams in. So let's now create a part inside of this model. And what I'm going to do in this part, for this part, is I'm going to set it to a green color. I'm going to set transparency to 0.5. I'm going to set cast shadows to false. I'm going to set the size to 222. I'm going to set can collide, can query, can touch to false, and anchored to true. And I'm also going to set the shape to a ball. And now what I'm going to do is place this ball slightly forward and to the left. And I'm also going to make sure that this ball is perfectly aligned with the floor so that the NPCs don't hover. So for position on the y-axis, I'm going to set it to 0, and that way it's going to be perfectly in line with the floor. And then I'm going to duplicate this part and move this one to the center up. And I'm going to duplicate another part and move this one over here. And now I'm going to give these parts unique names so we can describe which parts the NPCs need to walk from to the next. So the order that they're going to be walked in. So first we're going to start at this part. So I'm going to give this a name of 0, 1. And this part we have a name of 0, 2. And this part I have a name of 0, 3. Okay, because we're only going to have one path per place, there's no need to make a class of paths. We can just have a single object path. So I'm going to duplicate object and I'm going to name it path. Now inside of this new path object, we don't need the start function, so I'm going to remove that. And inside of initialize, what I'm going to do is I'm going to wait for this path model to streaming, and then I'm going to get all its children. So what I'm going to do is say self.parts equals workspace, wait for child, path, and I'm going to get all its children. And then I'm going to sort the parts based on their name. So to do that, I'm going to say table sort self.parts, and I'm going to sort based on their name, like so. The next thing I want to do is save all these parts positions in an array. So first thing I'm going to do is create a new table, a new array, and I'm going to set the size of this array to be the same size of how many parts we have. And then I'm going to loop through every part in the parts array and save its position. So to do that, I'm going to say for index part in self.parts, table insert, positions, and I'm going to save the parts position. Okay, let's now create an array of C-frames that goes from position 1 to position 2, and then finally up to position 3. So the first thing I'm going to do is create a variable called step, and this is going to describe how far in studs it's going to be between each C-frame. Then I'm going to create the first C-frame, and that's going to be a C-frame at position 1 that points towards position 2. So to do that, I'm going to say local C-frame equals C-frame.lookAt, and I'm going to pass in position 1 from the positions array, and it's going to look towards position 2. The next thing I want to do is create our C-frames array, and I'm going to add this first C-frame into the array. So to do that, I'm going to say self.cframes. I'm going to create a new array, and this first C-frame is going to be added at the first index. Then the next thing I want to do is loop through the positions of this positions array, but I want to start at the second position, not the first. So to do that, I'm going to say for index equals 2 up to the length of the positions that we have, which should be 3 in this case. And then I'm going to use this index to get the position. So I'm going to say local target position equals self.positions index. And now I'm going to get the direction from this target position from the current position that the C-frame's at. So I'm going to say local direction equals target position negative C-frame.position. So currently we're at this position, this C-frame, and we want to get to this target position, and this is telling us the direction, the vector 3, from our current position to this new target position. Now what I want to do now is keep looping and making this C-frame get closer and closer to this target position, and once we get to this target position, I want to break out of the loop and then move on to the next position. So over here, I'm going to say while direction.magnitude is greater than step, which is set to 2. Then I'm going to say, I'm going to update this C-frame. So I'm going to say C-frame equals C-frame.lookalong, and I'm going to be at the C-frame's position plus the direction united multiplied by the step, which is 2. And we want to look along the direction. And then I'm going to insert this C-frame into this C-frames array. So to do that, I'm going to say table.insert self.cframes, C-frame. And then I want to update this direction. like so. Direction equals target position, negative the new C-frames position. And finally, so that we can visualize all these C-frames that we've placed in this C-frames array, what I'm going to do is down here is I'm going to loop through every C-frame in the C-frames array, and I'm going to create a part. I'm going to set can collide, can query, can touch to false, anchored to true, and I'm going to set the C-frame to the C-frame that we generated. And I'm also going to set size to 1 and shape to ball, and I'm going to parent this part to workspace. And if we now play the game, we should see the paths parts that we first created in green. And now we should see a whole load of parts that go from part 1 to part 2, and then from part 2 to part 3. Okay, let's now work on our NPC model that's going to step from one C-frame to the next C-frame to the next C-frame to the next. So inside of Workspace, I'm going to go to the Avatar tab, and I'm going to press Rig Builder, and I'm going to create a R6, and I'm going to create a block avatar. Okay, I'm now going to simplify this NPC model. So I'm going to delete body colors. I'm going to delete the humanoid. I'm going to keep running animation. So I'm going to move that into the model and delete the animation script. And inside of head, I'm going to delete all these attachments and the image and the mesh. And inside of here, I'm going to delete the attachment, but I'm going to keep the joint, the motor 6D. I'm going to delete these attachments. I'm going to delete this attachment, these attachments over here, this attachment over here. I'm going to delete all these attachments plus the Roblox decal. I'm going to keep the motor 6Ds, and then I'm going to create a animation controller. And inside of this animation controller, I'm going to create a animator, and I'm going to move this run animation into the animation controller, and I'm going to rename it to animation. And what I'm going to do now is select the head. I'm going to change the size to 111. I'm going to set the color to this color over here. And I'm also going to set can collide, can query, can touch to false. And over here for surface, I'm going to set the surface to smooth. And for the humanoid root part, what I want to do is move this humanoid root part so that it's perfectly aligned with its feet. So I'm going to drag it down so it's perfectly in line with the feet. Okay, the next thing I want to do is select the left and right arm, and I'm going to change the color to this color over here. I'm also going to set the surface to be smooth, and I'm also going to set can query, can touch to false for the arms. And let's do the same for the legs. So the left and right leg, I'm going to set it to a brownish kind of color. And I'm also going to set can query, can touch to false. I'm also going to set the top surface to smooth. And then I'm going to select the torso and do the same again. So let's set the color to a blue color. And I'm going to set can collide, can query, can touch to false. I'm going to set the surface to be smooth. And I also want to set the humanoid root parts, can query and can touch to false. And I also want the humanoid root part to be the primary part. So I'm going to select the model, and we should see that the primary part is set to the head, but I'm going to change this to be the humanoid root part. And I'm also going to make sure that none of the parts are anchored apart from the humanoid root part should be anchored. Okay, so what I've done is created 5 characters. Now you're free to create characters any way you want, and you don't have to use blocks. You could use meshes and you can animate them with your own animations. But I've just made block characters that were created by the rig builder just to keep things simple. And all I've done was I've set the primary part to the humanoid root part. I've moved the humanoid root part to be aligned with the feet. So we can see this humanoid root part is perfectly aligned with the feet. If we look at a different character, we can see that this humanoid root part is also aligned with the feet. We can see that I've set can collide, can query, can touch, false for all the parts. And all the parts are not anchored except for the humanoid root part. And other than that, they have an animation controller inside of them. They have an animator and one single animation. I'm using this animation over here, but you're free to use any animation you like. Okay, so what I'm going to do now is inside of replicated storage, I'm going to create a new folder and I'm going to name this folder characters. And I'm going to move all these characters that I've created into the characters folder. Okay, so let's now create our character class. Because we're going to have multiple characters, we're not going to create a character object, but a character class. So I'm going to duplicate class, and I'm going to rename this to character. Now inside of this new class, I'm going to create some new functions. The first function is going to be called destroy. Then I'm going to create some local functions. And this local function is going to be called step. So every tick, the character is going to step. And then finally, we're going to have a bulk move function. And this is going to fire every post ticks. So remember from our tasks objects, we have a post ticks event. So when this event fires, we're going to call the bulk move function to update the C frame of all the characters. Okay, so now when we create a new character, I want to pass in the name so we know which character to select from the characters folder. So over here, I'm going to pass in a name, and then I'm going to get the model using this name. So over here, I'm going to say local model equals game.replicated storage characters with the name. The next thing I want to do is have each character have a separate speed. So some characters are going to step 1 C frame at a time, and some characters may step multiple C frames at a time. So I'm going to select all my character models, and over here for attributes, I'm going to add a attribute called speed, which is going to be a number. I'm going to press save, and I'm going to set all the characters to have a speed of 1. And now I want to get all the attributes from this model, and I'm going to store it inside of self. An easy way to do that is to simply replace this table over here with model get attributes. So now all the attributes inside of this model is going to be placed into self automatically. Okay, so now for the character object, I want to store which C frame that we created over here the character is at. So over here, I'm going to say self.cFrameIndex equals 1 because they're going to start at the first C frame index. And then I want to get a reference to the C frame from the paths object. So I'm going to say self.cFrame equals shared.path.cFrames, and I'm going to use the cFrame index to extract the C frame from the C frames array. And now I want to use this model to clone the model and store it inside of the character object. So I'm going to say self.model equals model.clone. And then I'm going to set the model's primary part which we set to the humanoid root part, C-frame to this C-frame over here. So I'm going to say self.model.primaryPart.cFrame equals self.cFrame. Now, the next thing I want to do is parent this model. We could parent it directly into Workspace, but I'm going to make another folder to organize our characters into a separate folder. So at the top over here, I'm going to say instance.new folder, and we're going to parent this folder into Workspace, and we're going to name this folder characters. And now we can parent this model into this characters folder. So over here, I'm going to say self.model.parent equals Workspace characters. And then I'm going to get the animation track. I'm going to load the animation onto the animator. So to do this, I'm going to say self.animation equals self.model.animationController animator, load animation, and I'm going to point to this animation over here. So what I want to do now is play this animation track, but I want to adjust the speed of each model's animation track. So some models may need the animation to play slowly, while some other models might need the animation to play faster than the other. So what I'm going to do is I'm going to select all my models, and I'm going to add a new attribute, and I'm going to name it animation speed, and I'm going to set it to a number and press save. And I'm going to set this value to 0.08. And now I'm going to play this animation track, and I'm going to multiply the speed by the animation speed to work out the speed that we want to play this animation track at. So over here, I'm going to say self.animation play, and for these first two values, I'm going to set 0, and then for the third parameter, I'm going to set the speed multiplied by animation speed. Okay, so let's now test to make sure our character is working up to this point. So inside of game, what I'm going to do is I'm going to add a new function called spawn character. And what I'm going to do is over here, I'm going to say shared.character.new, and I'm going to pass in character1, so it spawns character1. And actually what I'm going to do is I'm going to receive the name over here and pass this name over here, and now I'm going to delete this delay, and what I'm going to do is delete this, and I'm going to have a delay of 4 ticks and another delay of 12 ticks, and we're going to call the spawn character function. And for the fourth tick, I'm going to spawn character1, and for the 12th tick, I'm going to spawn character2. We can delete this over here, but if we wanted to, we don't technically need to have this function over here. We could just pass the new function directly into the delay function, like so. And now we can get rid of this, and let's play the game. So we should see that on the 4th tick, a character got spawned in, and on the 12th tick, another character should get spawned in. Okay, so let's now connect to the onTick event and pass in this step function to be called. So over here, I'm going to say self.tickConnection equals shared.task.onTick connect, and I'm going to connect the step function. And if we remember from our event class, we can pass in a perimeter, and now we can see why this perimeter is being used. So here you can see I'm passing in self as the perimeter so that I can get self over here from this function. So this tells me which character to step. So what I'm going to do now is I'm going to increment the C-frame index based on the character's speed. So we can see we set the character speed to 1. So over here, I'm going to say self.cframe index plus equals speed. And then I'm going to get the C-frame from the paths C-frames array. So I'm going to say self.cframe equals shared path C-frames, self.cframe index. And then I'm going to check to see if C-frame equals nil. If C-frame equals nil, that means we've gone out of the array. So I'm going to call this destroy function. So over here, I'm going to say if self.cframe equals nil, then self destroy. Okay, so inside of our destroy function, the first thing I want to do is disconnect this tick connection. So if you remember from our connection class, we have this disconnect function. So I want to call this function. So over here, I'm going to say self.tickConnection disconnect, and that's going to call this function over here. And then I want to destroy this model. So I'm going to say self.model destroy. Okay, let's now set up the bulk move function. So the first thing I need to do is when this class starts, I want to connect the bulk move function to the post ticks event. So just like the game object, we can use this start function. So I'm going to copy and paste this into the character class. So even though we've been using the start function for objects, this module loader doesn't really care if it's an object or a class. It will call the start function no matter what. So even if we have a start function inside of a class, it should call it, but we can't call it self.start. We have to call it class.start so that the module loader can find the start function. And inside of this function, all I'm going to do is connect to the post ticks event and connect this bulk move function down here. So I'm going to say share.task.post ticks connect bulk move. Okay, so for our bulk move function to work, it's going to require 3 arrays. So let's create our 3 arrays. The first array is going to be called characters. The second array is going to be called parts. And the third array is going to be called C-frames. And now inside of the bulk move function, I'm going to loop through the array characters array, and I'm going to set the C-frame that we stored inside of the character into the C-frames array. So let's do that. So to do that, I'm going to say for index character in characters do, and I'm going to say C-frames, which is this array up here, dot index equals character.cframe, which is this C-frame over here. And then I'm going to use workspace bulk move. And this bulk move function is going to take in an array of parts and an array of C-frames. And we're also going to set the bulk move mode, and fire C-frame change is the fastest mode of the 2 modes. Okay, so now when we create a new character, I want to place this character into these 3 arrays. So the first thing I'm going to work out is what index do we need to place this character into. To work out the index, I'm going to say local index equals characters plus 1. So this is the length of the characters array, and we're going to add 1. So it's going to start at an index of 1. Then I'm going to save this index inside of the character object. So over here, I'm going to say self.index equals index. So whatever index we placed the character into, we're going to be able to know what index it's in by checking this property over here. And now at the bottom of the function, I'm going to add this self object into characters using the index. So I'm going to say characters index equals self. And then I'm going to add the model's primary part as the into the parts array. So I'm going to say parts index equals self.model.primary part. And finally, I'm going to add the primary part C frame into the C frames array. So over here, I'm going to say C frames index equals self model primary part C frame. Let me now try to explain how we're going to handle removing a character from these arrays. So here we can see a list of indexes from 1 to 9. So this is our array of characters. And let's say that we want to remove character 5 from the array. Now, if we use table remove, what that's going to do is going to shift character 6 into index 5, character 7 into index 6, character 8 into index 7, and character 9 into index 8. And that's going to make us have to update the index for each character after the character we've removed. But that's not very efficient. So what we're going to do is we're going to only remove the last character, and we're going to move the last character into the index that the character is going to get removed in. So we're only going to update the index of the last character to be change it from an index of 9 to an index of 5. And this is going to allow us to efficiently remove a character from the array. So inside of our destroy function, I want to first get the last character and remove it from the characters array. So to do that, I'm going to say local last character equals table remove characters. And then I want to check to see if self is equal to last character, because if self, the character we're trying to remove, destroy, is this character at the end, then we don't need to shift it into a new index. We just need to remove it from the array and nothing else. So over here, I'm going to say if self equals last character, then all we need to do is just remove the last part and last C frame. So to do that, I'm going to say table remove parts, table remove C frames. Else, if it's not the last character, then we need to move the last character into the index of self. So to do that, I'm going to say characters self.index equals last character. And then we're going to do the same for parts and C frame. I'm going to say parts self.index equals table remove. I'm going to remove the last part and place it into the index of self. And the same for C frames. And finally, we want to update the last character's index to no longer point to the index it used to point to, but to point to the index that we've placed it into. So over here, I'm going to say last character.index equals self.index. Okay, so now that we've completed our bulk move, let's now play the game and see what happens. So we can see every tick, the character moves to the next C frame. And once they get to the end, they should get destroyed. And if I select character 2, which was the second character with the red torso, and change the speed from 1 to 2 and play the game again, we should see that this character moves 2 C frames every tick, which allows it to catch up to the blue character and overtake it. And if I go into my task object and change ticks per second to 10 and press play again, we should see it runs a lot quicker. And if I go into path and reduce the step amount from 2 down to 0.5 and press play again, we can now see they run quicker and the step distance is smaller than before. Finally, if I change the ticks per second to 48, and if I change the step distance to 0.02 and press play again, we can now see it looks very smooth. So when selecting a ticks per second value, you want the lowest possible value, but just high enough so that your game feels smooth. Now for a tower defense style game, I feel that 48 is the sweet spot, but you should be okay with a range from 30 ticks per second all the way up to 60 ticks per second. If you go any higher than 60 ticks per second and a client does not run their heartbeat event higher than 60 ticks per second, then it's going to cause that client to run multiple ticks per heartbeat, which is kind of a waste of performance. So anything between 30 and 60 is fine, but I think that 48 is the sweet spot for a tower defense game. So let's just keep it at 48 ticks per second. And when selecting a step value, the higher the value, the less C-frames are going to be stored in the C-frames array, but the faster the characters are going to move. So if I change this to 0.1 and press play, we can see that the slowest that this blue character can move, because this blue character has a speed of 1, it cannot go any slower. So this is the slowest speed at this distance. But if we changed the step amount to be 1, now we can see that the slowest speed a NPC can go is very fast, and they already finished the game. So we want to pick a step distance based on how slow you want a NPC to move. So I think that a value of 0.02 is the slowest I want a NPC to walk. So here we can see the slowest NPC speed available at this step distance and ticks per second. Okay, so let's now update the character's speed so they're not walking too slow. So I'm going to change the speed value to 3. And for character 2, I'm going to change the speed value to 4. So now, even with this small step distance, if we press play, they still walk reasonably fast and they still have room to be slowed down. And if we go back to game, and here we can see we have a delay with 4 ticks and 12 ticks. If we set this to 48, that means it's going to spawn after 1 second because we have 48 ticks per second. And if we set this to 48 multiplied by 5, it's going to be 5 seconds. So if we now play the game again, the blue character should spawn after 1 second, and the red character should spawn after 5 seconds. Okay, let's now add waypoints to our path. So a waypoint is going to be a class because we can have many waypoints, not just one waypoint. So I'm going to duplicate class and I'm going to rename this to waypoint. Now inside of this waypoint object, all we're going to do for now is simply create an event. So I'm going to call the new function for the class event. So to do that, I'm going to say self.characterAdded shared event.new. So when a character is added to this waypoint, we're going to call this event stored within the waypoint. Now I'm going to add a function for this waypoint, and this function is going to be called addCharacter, and we're going to pass in a character object, and when we add a character, we're going to fire this event. So over here, I'm going to say self.characterAdded fire, and we're going to pass the character that was added to this waypoint. Okay, so now that we have our basic waypoint object, let's add them to the path. Now, currently we have a C-frame every 0.02 studs, but we don't really need waypoints in that short of a distance. So it would be better to have our waypoints at a longer distance between each one and our C-frames at a shorter distance. So in order to do that, I'm going to replace this step value And I'm going to create some new values at the top here. The first one I'm going to have is called steps stud. So this means that every waypoint is going to have 2 studs of distance between one another. Then I'm going to have another value called sub steps. That means there's going to be 100 C frames between each waypoint step. And then I'm going to have another value called sub step studs. And to work that out, all we have to do is divide the 2 by the 100. So 2 divided by 100 is 0.02. So there's going to be a waypoint every 2 studs, and there's going to be a C frame every 0.02 studs. Now I'm going to create a new array called Waypoints. And then when we insert a C frame into the C frames array, I'm going to check to see if we should insert a waypoint. And to do that, what I'm going to do is get the length of C frames, and I'm going to use the modulus operator with the substeps. So here we can see substeps is equal to 100. And if this is equal to 0, then I'm going to insert a new waypoint into the waypoints array. And finally, I want to replace this steps, which we used over here, with substep studs. So I'm going to copy this. I'm going to remove this comment, and I'm going to replace steps with self.substep studs, and the same over here. And now we should have a waypoint every 100 C frames. And so that we can visualize all these waypoints, what I'm going to do is copy and paste this loop. But instead of looping through the C frames, I'm going to loop through the waypoints, and I'm going to call this waypoint. And in order to calculate the C frame of this waypoint, what we need to do is multiply the waypoint's index by the substeps amount. So over here, I'm going to say C frame equals self.cframes index multiplied by substeps. And some other things I'm going to do is I'm going to reduce the size of C frames by 0.5. And I'm also going to set this part's transparency to 0.5, and also set this part's color to a red color, like so. And if we now play the game, we should see that we have a waypoint every 2 studs, and we have 100 C frames between each waypoint. Now if I stop the game and go back to path and set substeps to 3 and play the game again, we can see that there are 3 C frames, then a waypoint, 1, 2, 3 C frames, waypoint, 1, 2, 3 C frames, waypoint, 1, 2, 3 C frames, and a waypoint. So we have 3 C frames for every waypoint. Okay, so let's now update our character object to call the add character function of a waypoint when it gets to a waypoint. So inside of our character object, our character class, at the top over here above C frame index, I'm going to add a new value called waypoint index, and it's also going to be equal to 1. Then over here, just like we did for the C frame, I'm going to get the first waypoint and save it inside of the character object. So I'm going to say self.waypoint equals shared path waypoints, and I'm going to pass in the waypoint index, which is 1. So now this character waypoint is going to be equal to the first waypoint. And then over here at the very bottom, I'm going to call the add character function for this waypoint. So over here, I'm going to say self.waypoint add character. Okay, so what I want to do now is when we update the C frame index, I want to also update the waypoint index. Now we could write this directly over here, but another way would be to add a new function into our path object. So over here, I'm going to create a new function called getWaypointIndex, and we're going to pass in a substep index, so a C frame index, this one of these index over here, and we're going to convert it into a waypoint index. Now to do that, it's pretty simple. All we need to do is the opposite of what we did here, because here we're going from a waypoint index to a C-frame index, where now we want to go from a C-frame index to a waypoint index. So instead of multiplying, we only divide. So over here, I'm going to say return, and I'm going to round substep, which is the value that we pass into the function, divided by substeps, where over here we multiplied and over here we divide. But the only difference is we have to round the value because there's not as many waypoints as C-frames. So we need to get the closest waypoint to this C-frame. Now, another thing I want to do is clamp this value so it stays within the bounds of the waypoint array. So over here, I'm going to say math.clamp, and I'm going to clamp the value between 1 and the amount of waypoints we have, like so. And now we can use this function over here to get which waypoint we need to get to. Okay, so let's now create a variable called waypoint index and get the index using the new function we created within path. So I'm going to say waypoint index equals shared.path get waypoint index, and I'm going to pass in the C-frame index to get the waypoint index. Now what I'm going to do now is I'm going to make a while loop and say while self.waypoint index is not equal to this waypoint index, then what I'm going to do is add 1 to the waypoint index, like so. And then I'm going to set the waypoint variable based on this new waypoint index. So I'm going to say self.waypoint equals share.path.waypoints. I'm going to pass in the waypoint index. And then I'm going to call the character added function for that waypoint, like so. One thing you may be wondering is, why do we use a while loop here and increment the waypoint index by 1 instead of just setting the waypoint index directly to this value over here without looping? And the reason for that is, if the speed of the character is too high, it will jump over a waypoint and fail to call the character added event for that waypoint. But we don't want that. So if a tower is listening for when a character reaches a waypoint, instead of the character jumping over the waypoint if its speed is too high, we want to loop through the waypoints up to that waypoint and call the character added event for all the waypoints along the way. So this will only happen for very fast NPCs, because normally we have 100 substeps. So that means a character would need to have a speed of 200 to skip a waypoint. But because characters only have a speed of around 3 and 4 and so on, they're not really going to be stepping over a waypoint. So this is kind of redundant, but it's just there just in case we decide to have a very high speed value for a character. Another thing to take note is, if the speed value is a negative number to make the character walk backwards through the C-frames, this is not going to work because we're only adding 1 for the waypoint index. So in order to support negative numbers for speed, what we'd need to do is we need to say math.sign, and we want to get the delta between the target waypoint and the current waypoint. So if we replace 1 with this, now we'll be able to walk backwards through the waypoints. But because I'm not going to support walking backwards, my speed value is never going to be less than 0. So I'm just going to have a 1 here. But if you wanted to support walking backwards, you would use this instead. We also have a very small edge case here where a problem can arise. Let's say that a character has a very high speed and is walking through multiple waypoints in a single step. And let's say that when this character added event is fired over here on the waypoint, that whoever's connected to this waypoint destroys the character. Now, when they destroy the character, this loop will continue after the character has been destroyed, causing the next waypoints to also fire and this check down here to take place. But we don't need to do this. So what we need to do is when a character is destroyed, we want to break out of this loop and not continue the step after we've added the character. So what I'm going to do is over here is I'm going to create a new property for the character. And I'm going to call it destroyed, and I'm going to set it to false. So the character is not destroyed when it's created. And then over here, when we call the destroy function, I'm going to check this value and say if destroyed is equal to true, then just return and don't bother destroying the character twice. And then over here, after I've destroyed the model, I'm going to set destroyed to true. So I'm going to say self.destroyed equals true, and that's going to prevent this destroy function from being called again. And then over here, once we call the character added event, I'm going to check to see if the character was destroyed. If it was, I'm going to return out of this step function and not continue. So I'm going to say if self-destroyed equals true, then return. Okay, so let's now test to make sure that these waypoint events are working. So to do this, I'm going to go back into path. I'm going to set substeps to 3. I'm going to go into the task and I'm going to change this to 1 tick per second, like so. And then I'm going to go into game. I'm going to comment out the second NPC, and I'm going to make this NPC spawn after 5 seconds. And then I'm going to connect to the path's waypoint. So to do that, over here, I'm going to say shared.path.waypoints, and I'm going to get the third waypoint, and then I'm going to connect to the character added event. So I'm going to say dot character added, and I'm going to call the connect function, and I'm going to create a new function called character added, and this function is going to receive parameter 1 and then the character. So let's connect this function, and then let's over here just simply print the character, and we should see once we get to this C frame over here, it should print. Okay, we saw it print, but because the character is walking multiple C frames per step, let's change the character speed to 1 and play the game again. We should see once it reaches this C frame here, it should print. See it printed? So we can see it printed before it got to the waypoint C frame, and that is because we're rounding to the closest waypoint. So this C frame here, the closest waypoint to this C frame is this waypoint over here. So if the character touches this, or this C frame, it all counts as being this waypoint over here. And if we comment out this print and go to the waypoint object, and when the character added event is fired, let's print character added. And let's now play the game again. And we should see that the character added print only fires once every 3 ticks. So not every tick, but once every 3 ticks. So we can see the character moves 3 times before I print. And if we now go back and change everything to how it was, so let's change this back to 48 ticks per second, and let's go to path and change the substeps to 100, and let's go back to the character 1 and make it step 3 C frames, 3 substeps every tick. And let's now play the game again, and let's see how often it prints. So we can see that even though the character is moving very often, 48 times every second, the print amount is not that high. So events are not going to be fired constantly for each character. And if we go back to the path and change the distance between each waypoint from 2 studs to 4 studs, and also double the amount of sub-steps from 100 to 200, and if we now play the game again, we should see that it prints less often because we have less waypoints along a path. So you can adjust this value depending on how much resolution you want your waypoints to have, but I feel that a value of 2 is good here, and 100 is a good amount of sub-steps. So these are the values that I'm going to be using. Another thing I want to do is, because we have so many C-frames, I'm just going to comment out this loop and only show the waypoint parts. And another thing I'm going to do is I'm going to go into waypoints and I'm going to remove this print now. And then I'm going to go into the game and I'm going to delete this function. I'm going to no longer test the waypoint because I know it's working correctly. And I'm going to bring back these 2 characters and I'm going to make this one spawn after 1 second. Okay, so let's now work on our towers. So the first thing we need to know is how we're going to make the tower detect which waypoints it needs to connect to in order to detect when a character enters within range and exits out of range. So what we're going to do is, let's say we create a tower over here. And let's say the tower has a range of something like this. Okay, so the first thing we're going to do is we're going to start at position 1 and we're going to shoot a ray towards position 2. And when we shoot that ray, it's going to detect this part. We're going to use a part to indicate the range of a tower. So when we shoot a ray, the ray is going to collide with the part over here. So this position is where the character needs to enter the tower. So we're going to connect to this waypoint. So in order to get the waypoint, we're going to use the distance of this ray. Now, once we've detected this first enter waypoint, so let's add a waypoint circle here. So here's our entry waypoint. Now we need to detect the exit waypoint. So what we're going to do now is start shooting rays in the opposite direction. So from position 2 back to position 1. So we're going to shoot a ray from position 2 back to position 1. And when we shoot a ray back, it's going to collide with the part over here. So now we know we're going to use the distance from 1 to 2 negative the distance of this ray, this small ray we just done now. And that's going to tell us the distance of this exit waypoint. So let's add this exit waypoint. So here's our exit waypoint. Then we're going to start shooting a ray forward from position 2 to find our entry waypoint again. So we're going to shoot a ray from position 2 to position 3, and it's going to collide with this purple part. And we've now found our entry waypoint. So we're going to add the distance from 1 to 2 plus the distance of this ray to get this entry waypoint over here. And then now we have a entry waypoint, we're going to start shooting rays in the opposite direction. So we're going to shoot a ray from part 3 back to part 2, and it's going to collide over here with the part. And then we're going to add a exit waypoint over here. So now we have 2 entry waypoints and 2 exit waypoints. Okay, so let's now create our tower model. So inside of Workspace, I'm going to create a new model. And inside of this model, I'm going to create a part. Now this part is only here for decoration. You don't need to have a part here. You could use a mesh, you could use multiple parts. I'm just going to have a single part for my tower, just to keep it simple. And I'm going to set the size to 262. And then I'm going to move this part up. And I'm going to set this part as the model's primary part. This is not mandatory, but I feel like I want to do this. So I'm going to set the primary part of this model to this part. And then I'm going to go to model. I'm going to say edit pivot. And I'm going to move the pivot down so it's in line with the bottom of the tower. So I'm going to enable snap and then move this down until it goes in line with the floor. The next thing I'm going to do is I'm going to anchor this part. So over here, I'm going to set anchor to true. Okay, and now let's work on the important part of the tower, and that is the ranged part. And this is the part that we're going to detect when we raycast. So this can be a normal part, and I'm going to name it range. Now this part, I want the transparency to be, I think I'm going to leave it at 0, but I'm going to set this to force field. And I'm also going to turn shadows off. And I'm going to set the size to something like 32, 32, 32. And I'm going to position it to be in the same position as this tower part. So I'm going to copy the position, paste it into the range parts position, so they're both aligned correctly. And then what I want to do is make this part anchored as well, but we can turn can collide, we can turn can touch off, but we need to keep can query on so that our raycast can collide with this part. And here we have our range part. Now our range part can be almost any shape as long as it doesn't have any like indents in them. It should be fine. So a block, a ball, a cylinder, even a wedge is all fine for a range part. We can even use a mesh for the range part. So let's go into the toolbox. And under meshes, I'm going to search for cylinder tube. And what I'm going to do is I'm going to take this mesh from SHOT02. And this mesh, we can check it by checking out the wireframe. So if we go to view, wireframe, we can see that this mesh looks like this. So it looks quite fine. One thing we can notice is that we can't see the outside of the mesh. We can only see the inside. But that's fine for our use case, because what I'm going to do is I'm going to select double-sided. So now we can see the inside and the outside of this mesh. And now we can use this for our range part. So I'm now going to turn off wireframe, and I'm going to rename this mesh to be called range. I'm going to delete this other range part that we created. I'm going to place this into the tower model. And I'm going to set this to a size of something like, let's do 24, 8, 24. And let's align it with the part to see what it looks like. So it looks like this. This looks pretty decent. So what I'm going to do now is I'm going to change this to force field. And I think I'm going to give it a red color. And I think I'm going to turn shadows off. And what I'm going to do is I'm going to set can collide to false, can touch to false, can query can stay on. For the collision fidelity, even though we've set collisions to false, I'm still going to change it to hull, and collision groups can stay the same, and I'm going to set anchored to true. So what I'm going to do now, next to characters, I'm going to add a new folder, and I'm going to call this folder Towers. And then I'm going to name this tower model Tower 1, and I'm going to move this into the Towers folder. Okay, so now that we have our tower model, let's create our tower class. So I'm going to duplicate the class template, and I'm going to name it Tower. And this tower class is going to work a lot like characters. So here we take in a name, and we're going to do the same over here. We're going to take in the name of the tower we want to create. Okay, so another thing we want to take is the C frame that we want to place this tower. So over here, I'm going to say C frame, like so. And then I want to get the model, just like we did over here. So let's just copy and paste this over here. But instead of getting it from the characters folder. We're going to get it from the towers folder. So I'm going to copy and paste and replace this table with model get attributes. And that way, any attributes we add to this model is going to automatically be added into self. And then what I want to do is create a folder where we're going to place all these towers in. So I'm going to copy and paste this to the top of our class. And I'm going to rename the folder from characters to towers. And then now I'm going to clone this model and place it into self. So over here, I'm going to say self.model equals model clone. And then I'm going to say self.model, and we can use pivot2 to pivot the model to the C frame that we passed into the new function. And finally, I'm going to parent this model into the towers folder. So I'm going to say self.model.parent workspace towers. Okay, so now that we have our basic tower class, let's go into game and let's spawn a tower. So over here at the bottom, I'm going to say share.tower.new, and I'm going to spawn tower 1, which is this tower over here. And I'm going to set the C frame to 0, 0, -25. So now if I play the game, we should see the tower gets placed over here at -25. And we can see that the range part overlaps the path from over here and over here. And it also has an entry point over here and an exit point over here. So the first thing we're going to need is raycast perims, because we only want the raycast to collide with the model's range part and no other part. So at the top of the tower class, I'm going to create a raycast perims. And then I'm going to set this raycast perims filter type to include. So it only includes the range part. And then over here, after we've created the model, I'm going to set the raycast perims to only filter this model's range part. So I'm going to say raycast perims filter descendants instances equals self.model.range, which is this range part over here. The next thing I want to do is shoot a ray from position 1 to position 2, from position 2 to position 3 to detect the range part. But instead of calculating the direction vectors every time we create a new tower, what I'm going to do is pre-calculate the directions inside of the path object. So over here, when we calculate the positions, I'm now going to create a new array, and I'm going to call this array self.directions, and I'm going to create a table the same length of the amount of positions we have, -1, because there's going to be one less direction than positions, because there's only going to be one direction going from position 1 to position 2, and one direction going from position 2 to position 3. So that's a total of 2 directions, but we have a total of 3 positions. And then what I'm going to do is I'm going to loop through the positions, but I'm going to start at the second index. So I'm going to say for index equals 2 up to the amount of positions we have. And then I'm going to insert into the directions array, and I'm going to get the vector between the current index from the previous index. Okay, so let's go back to our tower class, and we want to loop through the directions and shoot a ray in the directions that we've calculated. So over here, I'm going to say for index direction in shared path directions. And then the next thing I'm going to know is what direction do I need to shoot, forward or backwards? If we have an entry waypoint, we're going to shoot backwards. If we don't have an entry waypoint, we're going to shoot forward. So over here under the raycast perims, I'm going to say local enter waypoint equals nil. So we start with no enter waypoint. We currently don't have a entry waypoint. And over here inside of the loop, I'm going to say if enter waypoint equals nil, that means we're searching for the enter waypoint. We need to shoot a ray forward in this direction. And we're also going to use the position to say where the ray needs to start from. So we're going to say local result equals workspace raycast, and we're going to use the position that was stored inside of this positions array, and we're going to use the same index that we got from over here when we loop through the directions, And then we're going to shoot the ray in the same direction that we got over here, that we got from this directions array. And we're going to use our raycast perims that we created up here. Okay, so now that we've done our raycast, we need to check if the ray collided with the range part. So over here, I'm going to say, if result is not equal to nil, that means we did collide with this range part. So what we need to do now is get the enter waypoint. So in order to work out the enter waypoint, we need to know the distance at where this raycast collided. And then to work out the distance, we must add all the magnitudes of the previous distances plus the distance of this raycast. Now we could do that inside of this loop every time we create a new tower, but it would be better just to pre-calculate the distances within the path object. So over here, after directions, what I'm going to do is I'm going to create a new array, and I'm going to call it distances. And this array is going to have a length of the same amount of positions we have. So we have 3 positions, and we're going to have 3 distances. Then what I'm going to do is say self.distance equals 0. So this path currently has a distance of 0. And then we're going to loop through the directions and add the magnitude onto this distance value. So over here, I'm going to say table insert distances, and I'm going to insert the 0 value that we just added. So this part over here starts at a distance of 0. And then over here, I'm going to say for index direction in self directions. So we're going to loop through the directions array, and we're going to add this directions magnitude onto this distance value. So I'm going to say self.distance plus equals direction.magnitude. And then I'm going to insert this new distance into the table. So over here, I'm going to say table.insert self.distances self.distance. Okay, and so if we can just see what this looks like, I'm going to print self.distances, and that way we can see the distances for these three parts. And I'm going to play the game. I'm going to press stop, and here we can see the first part has a distance of 0, the second part has a distance of 28, and the third part has a distance of 56. Okay, so now that we know the distances, what we need to do is a way to convert a distance into a waypoint index. Because remember, we have a waypoint that is added every 2 studs. So for instance, let's say I wanted to know which index the waypoint is that is at a distance of 6 studs. So what we could do is say 6 divided by 2 equals 3. So we know the third index waypoint is at 6 studs. Or if we wanted to get the waypoint that's at 100 studs, we do 100 divided by 2 equals 50. So we just divide the distance by step studs to get the index. But one thing we need to be careful of, if we have a weird value like 101 divided by 2, then it's going to give us a floating point number, and we're going to need to round this value to the closest index number. So what we're going to do is, over here we have this function that converts a C-frame index to a waypoint index, but let's make another function now, and I'm going to call this getWaypoint, and it's going to receive a distance in studs, and then we're going to return a waypoint from the waypoints array. And to work out the index, all we're going to do is say mathround distance divided by the step studs, which is this 2 value up here. Now another thing I want to do is clamp the value just like we did up here, so it never goes out of the bounds of this waypoint array. So I'm going to say math.clamp, and I'm going to clamp between 1 and the length of the waypoints. Okay, so let's now use this getWaypoint function inside of our tower class over here to get the waypoint where this raycast result was hit. So to do that, I'm going to say enter waypoint equals shared.path. We're going to use the get waypoint function, and then we're going to get the distance that we stored in this distances array with the index that we used over here, plus the distance from the raycast results. And this is going to give us the enter waypoint. Now what I'm going to do for now is just to test to see we've got the correct waypoint. I'm going to connect to the waypoints. If we look at our waypoint class, I'm going to connect to the character added event. So I'm going to say dot character added connect, and I'm going to pass it in a function, and this function is going to get a parameter 1 and then a character, and all I'm going to do is say print character. And now let's play the game. So we should see that when this character touches this waypoint, it printed. When this character touches this waypoint, it printed. When this character touches this waypoint, it didn't print. And the reason it didn't print is because we're only doing raycast if enter waypoint is equal to nil. But we've now set the enter waypoint, so now we need to search for the exit waypoint and then set the enter waypoint back to nil once we've found the exit waypoint. Okay, so what I'm going to do is over here, I'm going to say if enter waypoint is not equal to nil, that means we do have a enter waypoint. Now I'm not going to use else, I'm not going to do else if, I'm just going to do if, because it can happen on the same iteration. So I'm going to say if enter waypoint is not equal to nil, that means we currently need to search for the exit waypoint. So just like we did over here, we're going to do a raycast, but slightly differently. Instead of using the current index, we're going to go one index forward. So we're one position ahead, and we're going to shoot a ray backwards in the opposite direction. So I'm going to say negative direction. And then if we do have a result, so I'm going to say if result is not equal to nil, then I'm going to create a exit waypoint. So I'm going to say local exit waypoint equals, now we want to use this get waypoint function again. So let's just copy and paste this over here. But what we want to do is we want to use the distance of the index plus 1, and we want to subtract the distance of the ray, not add the distance. And just like we did over here, I want to test to see that this exit waypoint is the correct waypoint. So I'm going to copy and paste this over here, but instead of using the enter waypoint, I'm going to use the exit waypoint. And we could put a enter here and a exit here. Now, once we've found the exit waypoint, it's important that we set the enter waypoint back to nil so that on the next loop, we can start searching for the next enter waypoint. So over here, I'm going to say enter waypoint equals nil. Okay, so let's now test to see if this is working. So let's play the game, and we should see that when this character enters, it prints enter. When this one enters, it prints enter. When they exit, it printed exit. Over here, it should enter again. We can see 2 more enters. And when they get here, we get 2 more exits. So that we can visualize which waypoints are being selected better, let's make some debugging functions inside of our path object. So what I'm going to do is at the bottom of our path object, after these 2 functions we've created here, I'm going to create 3 more functions. One function is going to be called get waypoint cframe. So it's going to work a lot like the get waypoint, but instead of returning the waypoint, it's going to return the cframe that this waypoint is at. Then I'm going to have another function called get cframe, and this is going to get the closest cframe to the distance we pass in. And then I'm going to have another function called debug, and this function is going to create 2 parts and place it at the waypoint cframe and the cframe. Okay, let's first do the get cframe function. So it's going to work a lot like get waypoint. So if we could just copy and paste this into get C-frame, and we want to not get the waypoint, but get the C-frames. So I'm going to replace this to C-frames, and we don't want to clamp it between 1 and the length of waypoints, but we want to clamp it between 1 and the length of C-frames. And finally, instead of dividing it by step studs, which is 2, we want to divide it by sub-step studs. So let's replace this with this, and now we have completed our get C-frame function. Okay, so to get the waypoint C-frame, what we need to do is calculate the waypoint index using this distance. We've done this before over here. So this is how we calculate the waypoint index, but then we need to convert this index into a C-frame index, which we've done up here. We simply multiply the waypoints index by substeps, which is equal to 100. So what we need to do, if we copy and paste this into here and change it to C-frames, like so. So here we're getting the waypoint index. All we need to do is multiply this by this value here, which is 100. And this is going to tell us the C-frame index and return the C-frame over here like so. Okay, so let's now use these two new functions to create our debug function. So all we're going to do is, just like we did over here, is create a part and use these two functions to position these two parts. So all we need to do is create parts, and I'm going to use get waypoint C-frame to position this part and get C-frame to position this part. And let's now use this new debug function inside of our tower class. So over here, when we create the enter waypoint, let's use shared.path.colon debug, and we want to pass in the distance, and we've already calculated the distance here. So let's just pass in the same value to debug, and let's do the same again when we create the exit waypoint. So over here, I'm going to say index plus 1 negative the result distance. So it's the same over here. And if we now play the game, we should see that this waypoint was selected for the enter waypoint. And we can also see the C-frame that was selected, but it rounded to the closest waypoint. We can see that this C-frame was selected over here and it rounded to this waypoint as the exit waypoint. You can see that this was the enter C-frame, which was rounded to this waypoint, and this C-frame was rounded to this waypoint. Our raycast system seems to be working really well, but there are some edge cases where it fails. If we go back to the game object, and over here where we create the tower, if we change the position to -20 on the x-axis and play the game again, we should see that this tower no longer has a enter or exit waypoint, and that is because we're shooting a ray from here to this part, from this position to this position, and because the ray starts already inside of this mesh, it's not detecting this mesh part. So the first thing I'm going to do is create overlap perims, the same way we've created raycast perims. So over here, I'm going to say local overlap perims equals overlap perims.new, and then I'm going to set the filter type just like we did for the raycast. So I'm going to set filter type to include, and then what I want to do is the same what we did over here, but for the overlap perims. But the first thing I'm going to do is place this table into a variable. So I'm going to say local filter equals, and I'm going to set it to this table, and then set this to this. And then now I want to do the same. So I'm going to copy and paste this, but I'm going to change it to overlap perims. So now both overlap perims and raycast perims have the same filter table. Okay, so what I'm going to do now is I'm going to use get parts in part for this first part here and to see if this part is overlapping the mesh range part. So what I'm going to do is over here, I'm going to say if workspace get parts in part, and then I'm going to use the first part inside of the parts array inside of the path object. If you remember, we have a parts array over here, and then we're going to use that part with the overlap perims, and if it's overlapping at least more than 0 items, and because we've only filtered the range part, this will only be greater than 0 if it's overlapping this range part. So if it is overlapping the range part, then I'm going to set the enter waypoint. And to do that, I'm just going to say enter waypoint equals shared get waypoint, the same way we did over here. But for the distance, I'm just going to pass a value of 0, which is going to give us the first waypoint. And so that we can see that this waypoint is working, let's copy and paste the connection and the debug function. But for the debug function, we're going to pass in a distance of 0, the same way we did over here. And now if we playtest our game, we should see that this tower has a enter waypoint over here and a exit waypoint over here. Okay, let's go back to the game object and let's change this -20 to a +20 and see what happens if the tower's range part is overlapping the last part. So we can see that we have a enter waypoint, but we don't have a exit waypoint. So if we wait for these characters to touch this enter waypoint, we should see it prints enter for both of them. But we should also notice that it doesn't print exit for both of them. And to fix this problem, all we need to do is over here is if we get to this part after looping through all the directions and we still have a enter waypoint and it was not set to nil, that means that this exit waypoint was not found. So we should add a exit waypoint at the very end of the path. So over here, just like we did this if check, we're going to do another if check saying if enter waypoint is not equal to nil, that means we have not found the exit waypoint. Then I'm going to use this function over here to create our exit waypoint. But for the distance, I'm just going to use the value of math.huge. And if we remember from our get waypoint function, we clamp the value. So that means this is going to clamp this huge value to give us the last waypoint in the path. And just like we did over here, I want to create a connection and also set, well, this is kind of technically useless. We don't need to set it back to nil, so we could get rid of this. Now for this debug function, it's okay to use math.huge here, because remember, this is going to use the get waypoint C-frame and get C-frame, which is also going to clamp for both of these functions. So it's safe to use math.huge here. And now we can playtest the game again. And we should see that it now has a exit waypoint. But this method that we just used is actually a little bit exploitable. So let me show you why it's exploitable. If we select the tower model, and let's imagine that this tower was placed at a position something like this. So now we can see that this start part, the first part, is overlapping the range part. So this part here would create the enter waypoint. Then we would start raycasting, and it would raycast from this part back to here, but it won't hit this range part. Then we're going to raycast back from here to here, and it won't hit this range part. And then finally, we're going to say, do we have a enter waypoint? Which we do. And then it's going to create a exit waypoint all at the end over here. So this tower would have a enter waypoint over here and a exit waypoint over here, which would allow this tower to attack all characters along the entire path. Now, one thing we could do is reduce the size of this start part. So if we set the size to 0, we can see now it no longer overlaps this part, but we can see that the minimum size of a part is 0.01. So there's a very small window that this exploit could maybe still happen. So I'm not too happy with using the part to a size of 0 because there's a very small window where a exploiter could position this tower just right so that it overlaps the start part, but the raycast that goes backwards does not hit the range part. So instead of using get parts in part to work out if we need a enter waypoint at a distance of 0, I'm going to use a different way of working out if we need a enter waypoint at 0. So I'm going to comment out this entire part, and we no longer need overlap perims because we're no longer going to use get parts in part. So let's delete overlap perims, and we could just place this table directly into here. So we can just move this back over here and remove filter like so. And now over here, currently we're only raycasting in the opposite direction if we have a enter waypoint. But what I want to do is always shoot a ray backwards, even if we don't have a enter waypoint. So I'm going to remove this if check. And now if we shoot a ray backwards and find a exit waypoint, but we don't have a enter waypoint, so what I'm going to do is over here, before we create the exit waypoint, I'm going to say if exit waypoint equals nil, I'm going to do the same that we did over here. So let's copy and paste this over here. And so if there is no enter waypoint when we find a exit waypoint, I'm going to create a enter waypoint at a distance of 0. I'm going to connect to the character added event and create a debug part. So now we can delete this part over here. And so now this method of detecting the enter waypoint should not be exploitable. So let's go to game. So currently we have the position at 20 on the x-axis, and we should see that it's working correctly. We have the exit, the enter and exit waypoints correctly added. Let's go back to game and change this to -20 and press play. So now, even though we're not using get parts in part, we can see we still have the enter waypoint and it printed enter. And we also have the exit waypoint. So now we have a method of detecting this enter waypoint without using parts in part. There is another small problem that we have, and that is, let's say that this tower was positioned at a position something like this, where it was just skimming the edge of the path. And let's say we shoot a ray forward and it collides over here and it then rounds to this waypoint. So this waypoint was now selected as its enter waypoint. And then we shoot a ray backwards and it hits over here and it rounds to the same waypoint that the enter waypoint is. So now this tower has a enter and exit waypoint on the exact same waypoint, which is going to cause the character to be added and then instantly removed, which is kind of a waste of time. So let's check to see if the enter waypoint is equal to the exit waypoint. And if they are equal, let's just skip and not add any waypoints here. If we go back to this part here where we were creating our enter and exit waypoints. So over here, when we find the enter waypoint, we instantly connect to the character added event and we instantly create the debug part before we're even aware if it's equal or not equal to this exit waypoint that we find down here. So what I want to do is I don't want to connect to it and create a debug part instantly. So let's cut and move this down here. And now, so we're just going to save the enter waypoint in a variable, but we're not going to connect to it just yet. And I want to do the same over here. I don't want to connect to the character added and create a debug part just yet, because we're not too sure if we're still going to use or discard this enter waypoint. So let's remove this over here and make this like so. Okay, so now when we're down here, we know the exit and enter waypoint. So I first want to check before we connect to them if they're the same or not. So I'm going to say if enter waypoint is not equal to exit waypoint, then I'm going to connect to the enter waypoint and create the debug part. And I'm going to connect to the exit waypoint and create the exit points debug part. But if they are not, they are the same, I still want to set the enter waypoint back to nil so that we can start searching for the next enter waypoint. So I'm going to keep that outside of the if check. But we have a slight problem here, and that is when we create this debug part for the enter waypoint, this distance plus ray distance is incorrect because, well, this ray result is not the original result we used up here to get the enter waypoint. And also this index could be a different index from when we found the enter waypoint up here. So this debug part is going to be the incorrect part, but this debug part is going to be the correct part. Now we could save the C frame inside of the waypoint object or the distance inside of here to get it, but I'm not going to bother doing that. All I'm going to do is I'm going to blindly create the debug part for the exit waypoint over here, and I'm also going to blindly create the debug part for the enter waypoint over here. Okay, but if we create a enter waypoint at a distance of 0, I'm not even going to bother creating the debug part. We can just say that we know it started at the front. And finally, I also want to do the same down here. So instead of just blindly connecting to the character added and creating the debug part, I'm going to delete this. I'm going to copy this into here. So now when we create the exit waypoint at the end of the path, I'm not even going to bother creating the debug part. And I'm just going to say if the enter waypoint is not equal to the exit waypoint, connect to both the enter and exit waypoint. Okay, so now that we're able to correctly detect when a character goes in and out of range of a tower, let's create some new functions for our tower class. The first function is going to be called destroy, and we're going to call this function to destroy a tower object. Then I'm going to create another function called add character, and this function is going to be called when a character enters range of a tower. And then I'm going to create a function called remove character, and this is going to be called when a character exits the tower, or if a character dies while within range of a tower. So now, instead of having these functions over here, we want to use these functions down here. So to change these to use these functions, first thing I'm going to do is move these prints into these functions, like so. And over here, I'm going to pass in self.addCharacter. Now over here, we're going to, because we used a colon here, the first parameter is going to be self. So we need to pass in self over here so that we can receive the tower over here. Because if you remember from our event class, we have a parameter that we can set that gets passed in as the first parameter when we call the function. So that means when we pass in self over here, we're going to receive self over here. And we want to do the same for this event as well. So let's copy and paste this over here. But instead of character added, add character, we can use remove character. And we want to do the same down here. So let's copy and paste these two lines and replace these over here. And now we have done this. So if we play the game, we should still have the same result. This should print and this should also print. And we can see that enter was printed. And we can also see that exit was printed. Okay, so what I want to do now is all these connections that we've connected to when we create the tower, when we call the destroy function, I want to disconnect from these connections. So to do that, what I'm going to do is over here, I'm going to create a new variable within the object. I'm going to say self.connections is going to be equal to a table. Then when we connect to a connection, I'm going to insert that connection into this connections array. So over here, I'm going to say table.insert self.connections, and I'm going to insert the return connection into this connections array. I'm going to do the same for the other ones. So I'm going to copy, paste this over here, and close the bracket over here. I'm going to do the same over here, close the bracket, do the same over here, and close the bracket. Okay, so now all these connections that we've connected to are saved within the connections array. And now inside of the destroy function, I want to loop through these connections and disconnect them all. So over here, I'm going to say for index connection in self.connections, connection disconnect, which is going to call the disconnect function over here. And I also want to destroy this model that we cloned. So over here, I'm going to say self.model destroy, which is going to destroy that model. Okay, so what I want to do now is have a way to store all characters that are in range of this tower. So at the top over here, I'm going to create a new table called characters. And then when the character is added, I'm going to insert this character into this characters table. And when they are removed, I'm going to remove them from the table. But we have a problem here. Because we're using a dictionary, dictionaries have some limitations. The first limitation is the order that we can iterate through this dictionary is undefined. That means one player, one client playing this game may iterate through these characters in a different order from another client. And because we're making a deterministic game, this could cause the two clients to go out of sync. So let's imagine that we had another function here called attack. And inside of this function, what we're going to do is we're going to loop through the characters. So for index character in self.characters do, and let's say that we call the damage function for that character. Now, if we use a dictionary here, this is going to cause this loop to be different for each client, which could cause each client to go out of sync. Another problem with dictionaries are you cannot insert items into a dictionary while you're iterating through them. So if we called self and we called the add character function to add more characters into the character dictionary while we're iterating through them, for instance, let's say you had a boss character that when got destroyed, split into two more characters, that would not work if we're using a dictionary here. So this is why we cannot use a dictionary to store the characters. Okay, so instead of using a dictionary here, what would happen if we use an array here? So let's just change this to table.insert, and we're going to insert into the characters array, no longer being a dictionary. We're going to insert this character. And over here, what we're going to do is say table.remove from the characters array. And we're going to use a table.find to find the character from the characters array, like so. But using an array to store the characters also has problems. So using the add character function is fine in the case for arrays, but the damage is not fine for arrays. For instance, if we damage a character and then that character dies and it calls the remove function, while we're iterating through the characters, it's going to cause some problems with this iteration. And to demonstrate this, we can show you this piece of code. So here we have an array with the values A, B, C, D, E. And when we get to value C, I'm going to remove value C and print the values. So if we now play the game and stop the game, we can see it prints A, B, C, but it never print D. But D was not removed, C was removed. Why is D not printing? Now I cover this in my linked list video. So if you haven't watched my linked list video yet, you should watch that because it covers why arrays have problems and dictionaries have problems. So that's why we cannot use an array to store the characters, because it may be that when we iterate through the characters, we may need to remove a character, and that's going to cause this iteration to not work correctly. So once again, we're going to be saved by linked lists. So let's use a linked list, because linked list doesn't have any of the problems that dictionaries or arrays have. So let's remove this attack function. And just like we did inside of our task object, where we created a new link, let's do the same inside of our tower to create a linked list for our characters. And then over here, we want to insert the character. And if we look at the linked list object class, we can see we can use the insert back to insert the character to the back of the linked list. We no longer need this. And to remove the character, all we need to do is call the remove function, which is this function down here. Okay, so this almost works, but it has some problems. So if we go back up to insert back, we can see that whatever value we pass into insert back is converted to a link and has its meta table set to the link class. But if we look at our character class, we can see that our character has a meta table set to this class. So we're overwriting this character's meta table to now point to this link class, where it used to point to this class over here. So we're kind of breaking our character object. Another problem is when we set this character to be a link can only be inside of one list at a time. But in the future, we're going to store this character in multiple links, because here we have a next and previous value. And if we have more than one link, there's not going to be more than one next and previous value for it to work. So even if we didn't have the problem of the meta table being changed, we also have the problem that because there's only one next and one previous value, it's not going to allow us to have a character be in multiple lists. So to solve this problem, what we need to do is not make this character be a link in the list, but to have a separate link that points to this character. So to do this, all we need to do is wrap this character in a table, and now this table will be converted to a link, but the character that's stored inside will not. And we can give it a key. For instance, we can say value equals character, and over here we can see it returns the link that was passed in back, so we can get this table back over here. So I'm going to say local character link equals. Now, one problem we have is we've inserted this character into the linked list, and we now have the link, but where are we going to save this link? How are we going to get access to this link? Over here inside of the remove character function. Now to do this, all we need to do is create another dictionary, and I'm going to call it character links equals dictionary. And then all I'm going to do is store this link inside of the dictionary, and I'm going to use the character as the key, like so. Now you may be wondering, is it not safe to use a dictionary? it is safe to use a dictionary as long as we don't iterate through it. So using a dictionary here is fine as long as we don't iterate through it, because remember, if we iterate through this dictionary, the order is going to be different from one client to the next. So now we've saved this character link inside of this dictionary, we can get the character link. So I can say local character link equals, and I can extract it from this dictionary. And finally, I can remove the character link, and also I have to remove the link from the dictionary. So I'm going to set this back to nil. But the thing is, having to handle a linked list and a dictionary together can get kind of annoying, because every time we add a item to the linked list, we must also add it to the dictionary. And every time we remove a item from the linked list, we must also remove it from the dictionary. What if there was a module that did this for us? Well, there is. If we go to the toolbox and inside of models, if you search for Soupy, here we'll find a module called Soupy's Hybrid Linked List. And you're going to make sure it's from Soupy 5UPHI. If we click on this module and press OK. Now inside of this module, there's going to be some examples. We can delete these examples. And what I'm going to do is I'm going to place this module into classes. And what I'm going to do now is I'm going to rename this list class to be called linked list. And I'm going to rename this hybrid linked list to be called hybrid list. Okay, so now that we've renamed the list class to be called linked list, we also need to make sure we make this change inside of all our modules. Now, the easy way to do this, if we click on this find button and find all, I'm going to search for shared.list, like so, and press enter. And it's going to show us every time we used shared.list. Now, if we go into our task module, we can see we used it twice over here. I'm going to rename these to be called shared.linkedList. And finally, we have this one over here, but this one's quite different. So currently we have a list for the characters and a dictionary for the links. But if we use a hybrid list, if we open this hybrid list and place it to the side, and if we open this linked list, and place them side by side, we can see that the linked list creates a list like this, where a hybrid list creates a list like this. They're very similar, but slightly different. Here we can see we have a dictionary that stores all the links, which is the same what we was doing over here inside of our towers. We had a dictionary that stored all the links. And another thing we should notice is when we insert to the back in a linked list, it asks for a link that gets converted. But on the hybrid list, when we insert to the back, it doesn't ask for a link, it asks for a value, and it will create a link for us and return that link back to whoever I called this function. So we can see they're very close to one another, but slightly different. So what I'm going to do here is I no longer need a dictionary of links because it's going to be stored inside of the hybrid list. And I'm going to delete this. And over here, instead of using shared.list, I'm going to use shared.hybridList. And then over here, we no longer need to get the link because the link is going to be automatically added to the links over here. Because if we look at insert back, we can see the link is added over here. So over inside of our tower class, we can just insert, and we don't have to create a table for the character. We can just pass the character directly, and we don't need this anymore. So all we need to do is just this. It's going to pass the value. It's going to create a new link for us. It's going to add it to the dictionary, and then it's going to return the link, but we're not even going to take that link because we're just going to access it directly from this links dictionary. Then over here, what we're going to do is we can say self.characters. Now if we look, there's a function here called remove, and we can pass in the value we want to remove, and it's going to use the link dictionary to find the link for us. So over here, I'm just going to say remove, and I'm going to pass in the character, and this is going to do the same as all of this, so we can remove all of this now. Okay, so what I want to do now is have the towers do a action, and what I want is there to be different types of towers. So some towers will do one type of action, and another tower may do another type of action. So instead of having all the actions inside of the tower class, I'm going to create a new module inside of data, and I'm going to name this module tower functions. And inside of this tower functions module, all I'm going to do is return a table, and inside of this table I'm going to create tower types. So I'm going to create the first tower type, and I'm going to name this type damage aura. And inside of this tower type, I'm going to create a new function which is going to be called action, and this action function is going to receive the tower that called this action function. And now what I'm going to do is copy the type of the tower, and I'm going to select the tower model that we have, and I'm going to give it a new attribute called type, and it's going to be a string, and then I'm going to set the type to damage aura, so it's going to be this type that we created over here. For now, all I'm going to do is just print action with the tower object, and then what I'm going to do is over here I'm going to create a new local function called action. This action function is going to receive the tower object, so I'm just going to pass in the value of self here so we can get the tower object. What I want to do now is load these tower functions into our tower object. So at the top, when we create the tower, over here, after I've created the characters, what I'm going to do is say self.functions equals shared.towerfunctions, and I'm going to pass in the type. Remember, we are getting the attributes over here. So this type attribute that we saved here should be inside of the tower already. So we can just use self type here to get this string, and that's going to select this table over here, and we're going to point to that table with this functions property. So now if we want to call this action function, all we need to do is go self.functions.action, and we need to pass in the tower. So we need to pass in self like this. But another option is, instead of having a functions property that points to all these functions, what if we looped through this table and saved each function directly into the object? So let's do it that way as well. So over here, I'm going to comment out these two. What we can do is say for index func in shared tower functions, we can use the towers type to get the correct table, and then we're going to loop through this table and add this action function, which is the index action equals func. So now what we can do is call this action function like this. And because we can use a colon here, it's going to automatically pass the tower of self into the function. I want to use this method and not this method, but you're free to use any method you like. I just personally prefer doing it this way. And I'm going to delete this and delete these. So now we're storing the functions inside of self. Okay, so now let's go down to our action function. That is the local action function, not this action function over here. And in this function, what I'm going to do is I'm going to check if there's at least one character inside of the characters list. Now, if we look at the hybrid list, we can see that there is a next function, and this will tell us the next linked in the list. this is one method of checking if there are any characters. Another method is we can check the length. So what I'm going to do is say if self.characters.length is equal to 0, then, and I'm also going to have a else. So if there are no characters, we're going to do this. If there are characters, what I'm going to do is I'm going to call this action function over here. And to call this action function, I'm going to say self::action. After we've called this action function, I want to schedule for this action, the local action function, to get called again after a delay. So I'm going to use the task delay function, and we're going to pass in the amount of ticks we want to wait, the function we want it to call, and any properties we want to pass into that function. So over here, I'm going to say, now remember that this delay function returns the action. So we're going to save that action inside of the tower object. So to do this, I'm going to say self.actionTask equals shared.task. We're going to use the delay function, and we're going to use the action delay property. Now we currently don't have this, and we're going to call the action function, this one over here, and we're also going to pass in the self object to this function. Let's now make this action delay property for the tower, but I'm not going to create it up here because I want different towers to have different action delays. So what I'm going to do is copy this, go to the tower model, I'm going to go to attributes, and I'm going to add a new number attribute, and I'm going to call it action delay. Press save. Now this is going to be based on ticks. So if I wanted the tower to have an action every second, I would set this to 48 because we have 48 ticks a second. And remember, because we're using get attributes over here, this property is going to be automatically added into self. Now, one thing we need to be careful of is because we have this action function above this scheduled delay, if we had a shared wait over here, this will cause problems. So we don't have that problem, if we do use a wait over here inside of the action function, what I'm going to do is place this above the action call. That way, this is going to be set instantly as soon as the action function is called. And even if we have a delay in this action function, it's not going to place a delay on this being set. Okay, so once this delay ends, it's going to call this function again. And when this function is going to be called again, it's going to check if there are any characters. If there is a character, it's going to create a new action delay. But if there is no characters, I want to remove this action task. So I'm going to say self.actionTask equals nil. And remember that this action that we're saving is from being inserted into the task list, which is a linked list. And if we look at the linked list, we can see that this task has a remove function that allows us to remove it from the list. So what I want to do is, if there is a action scheduled to be run in the future and we call the destroy function, I want to cancel this action, and to do that we're going to call the removed function. So over here, after I have disconnected all the waypoints, I'm going to also check to see if there is a action that is scheduled to run, and if there is a action, I'm going to say if self.actionTask, then self.actionTask remove. So we're going to remove it from the linked list. All that's left to do now is when a character is added to the tower, if there's not a scheduled action to take place in the future, to start the action loop. So over here, what I'm going to do is say if self.action and self.actionTask is equal to nil, then call the local action function and pass in the tower into this function. So the reason why I'm checking action here is because some tower types may not have this action function within it. If they don't have an action function, we're not going to start the action loop. But if they do have an action function and their current action task is set to nil, meaning they don't have a scheduled action to take place in the future, then we're going to start the action loop. Okay, so if we now go to our game object, and what I'm going to do is I'm going to move this tower back to the center. So I'm going to change the X position to 0. And I'm also going to add another character. And I'm going to have this character spawn after 20 seconds. And I'm going to use character 3. And if we now play our game, let's see if the action gets printed. So we can see action gets printed every second. And when there are no towers inside of range, it should stop printing. So you can see after both the characters exited, it stopped printing action. As soon as this one enters, it should start printing action again. When he exits, it stops printing action. And once he enters, it starts printing action again. Okay, so let's now give our characters health. But in order to display how much health a character has, I want to create a billboard and place it on its head so we can see how much health it has. But instead of having the billboard be created inside of the character class, I'm going to create a separate bar class. So what I'm going to do is I'm going to duplicate the class template, and I'm going to name this duplicate to bar. And inside of here, I'm going to create a bar class, which looks like this. So it's pretty simple. We first are taking the parent, which we're going to parent the billboard to. We can take in the current value and the max value of the bar. And we're also going to take in a color free value. So here we can see we store the value and max value into the self object. Then we create a billboard. We set the size, we set the extents and the stud offsets to these. We're going to set the parent to the parent we passed in. We can create a frame. We can set the frame size, background color, border color, and we can set the border size to 2. We're going to parent this into the billboard. We're going to set the inner frame. We're going to use the color that we set over here. For the size, we can use the value divided by the max value, and border size pixel is equal to 0. And we're going to parent this to the outer frame. So we have 2 frames, the outer and inner frame. And then we're going to have a set function, which allows us to set the value and the max value. We can also pass in nil for these values. It's only going to set the ones that we pass in. If we pass in a value, it's going to update the value. If we pass in the max value, it's going to update the max value. And then it's going to update the size of the inner frame to reflect these 2 values. And we also have an increment value, and this increments the value based on the amount, and we update the size. And finally, we have a destroy function that destroys the billboard. Okay, so now that we have our bar class, let's put this to the side. And what I want to do now is give the characters a health property, but I'm not going to place that inside of here. I'm going to store it as an attribute so that we can give each character a different amount of health. So to do this, I'm going to select all the characters, and over here for the attributes, I'm going to add a new attribute. It's going to be a number, and it's going to be called health. And I'm going to give all characters a health of 10. Then this second character, I'm going to give it a health of 20, a health of 30, 40, and finally 50. Okay, so here are all our characters with their health attributes. So now this is going to be automatically added into the self object because we're using get attributes. And now I want to create a new function for our characters. And I'm going to place this after the destroy function. And I'm going to say function increment health, and I'm going to pass in the amount I want to increment this character's health by. And then I'm going to say self.health plus equals amount. And what I'm going to do now is once we've incremented the health value, I'm going to check if the health value is greater than 0. Then I'm going to check if the character has a bar. So I'm going to say if self.bar, then I'm just going to use the set function for this bar. So I'm going to say self.bar set self.health. Else, if we don't have a bar, I'm going to create a new bar. So what I'm going to do is say self.bar equals share.bar.new. So we're going to call the new function. Then we're going to pass the head as the parent. So this billboard is going to be placed into the character's head. Then I'm going to pass the health for the value. And for the max value, I'm going to pass in health negative amount. So we're kind of undoing what we did here to get the max health again. And then I'm going to pass in a red color. But if the health value is not greater than 0, what I'm going to do is say else, and I'm going to call this destroy function. So I'm going to say self.destroy. Okay, so now that we have this increment health function, let's use it inside of the damage or towers action function. So what I'm going to do is over here, I'm going to remove this print. And the first thing I want to do is to loop through the characters linked list, which is a hybrid list. And to do this, I'm going to say local character link equals tower dot characters dot next, and that's going to get the first character link in the linked list. Then I'm going to loop through the links. So I'm going to say while character link is not equal to tower.characters do character linked equals character linked dot next. And what I want to do now is I want to call the increment health function for all these characters. Now if we look at the hybrid list, we can see that the character is saved under the value key. So to get the character, we do character link dot value, and then we're going to call the increment health function. And to determine how much health we want to increment, what I'm going to do is select the tower, and I'm going to give it a new attribute, which is a number, and I'm going to name it damage, and I'm going to have it set to 3 damage. So here I'm going to say negative tower dot damage. Now you may not like iterating through characters like this in linked lists, and I do have a other method of iterating through linked lists inside of our linked list module. So if you look over here, we can see there's a function called iterate forward. So let me show you how we can use this function instead of iterating like this. So all you need to do is say for link character in tower.characters, and we're going to call this iterate forward function do, and now we can just call the increment health value for this character. So I'm going to say character increment health, and so now this and this work in the same way, but the thing is, doing it this way has slightly better performance. So if you care more about performance, you can do it this way. But if you care more about how pretty your code is and how simple the code looks, you can do it this way. Now I'm going to do it this way because I want to have the best performance possible. So let's delete this. Okay, so if we now play our game, we should see that when the character enters within range of the tower, it starts losing health. We saw the one character got destroyed, and here we can see the other character, and he just about makes it out before he dies. But we have a problem. The problem is when we call the destroy function for a character, it does not remove the character from the characters list on this tower. And because of that, the tower is going to continue to attack the character, calling the increment health function, and that's going to continue to call the destroy function. So this destroy function is going to get called over and over and over again forever for all characters that get destroyed. And we can see this if we say print, and if I print destroy, I'm going to do it before we do this if check, because if we do it over here, it's just going to return and not print. But if we do it at the top and press play, we should see that when this character gets destroyed, it's going to continue to print destroy over and over again every second. So here it got destroyed, but we can see it continues to destroy that same character over and over forever. Okay, so what I want to do is I want to keep a list of towers inside of the character object, and when we destroy that character, I want to loop through the towers and call the remove character function so it gets removed from the characters list. So to do this, over here, I'm going to create a new list, and we're not going to use a dictionary or a array because of the problems I listed before. We're going to use a hybrid list again. So over here, I'm going to say self.towers equals shared.hybridlist.new, and I'm also going to make a comment saying that this list is going to be populated by the tower class. So this class is going to be responsible for inserting the tower into this list. And so now I'm going to go back into the tower class, and over here, when we add a character, so after I've added the character to the characters list, I'm also going to add this tower into the characters tower list. So to do that, I'm going to say character.towers, and I'm going to insert to the back self, which is the tower. And then over here, when we remove the character from the characters list, I'm going to say characters.tower remove self. Okay, so now that we're keeping track of the towers that a character is in within the towers list, over here, when we destroy a character, what I'm going to do is I'm going to loop through the towers. So I'm going to do the fast way, not the slow way. So I'm going to say tower link equals self.towers.next. Then I'm going to say while tower link is not equal to self.towers. And then I'm going to call the remove character function. So I'm going to say tower link.value remove character self. And finally, I'm going to iterate to the next tower in the link. And if we now play test the game again, we should notice that instead of print and destroy every second, it should only print destroy once when the character dies. So let's play the game and let's wait for this character to die. We should see it prints destroy. Here's the destroy print, but we can see that it doesn't print destroy every second like it did before. Okay, so let's now remove this print now that we know that it's working correctly. And let's make another tower type. So what I'm going to do is I'm going to duplicate tower 1, and I'm going to rename the duplicated version to tower 2. Then I'm going to move tower 1 to the left and move this one to the right. And what I'm going to do is set tower 1 to be a blue color and set tower 2 to have a red color. And I'm also going to change some attributes. So for the type, I'm going to have it to be called slow aura. There isn't going to be any action, so we can get rid of the action delay. And for damage, I'm going to rename it to be slow. Okay, so now let's move these towers back into the towers folder. Okay, so what I want to do now is go back to the character class, and I want to give the ability for this character object to be slowed. So what I'm going to do is, if we remember, each character has a speed attribute, But I don't want the speed attribute to go lower than a value of 0 because I have not had the ability for the step to go backwards. So I'm going to restrict the speed and only allow it to go down to 0 and not any less. So what I'm going to do is over here is I'm going to say self.unrestricted speed equals self.speed. So whatever speed we set over here, we're going to set unrestricted speed to be the same value. And then after increment health, I'm going to create a new function and I'm going to call it increment speed. And we're going to pass in the amount that we want to increment the character speed by. And then what I'm going to do is add the amount to unrestricted speed. And then I'm going to use the unrestricted speed's value and I'm going to set it to the speed value, but I'm going to use max. That way, if unrestricted speed is less than 0, it's going to clamp it up to a value of 0. And then finally, once we update the speed, I also want to update the animation that's playing. So to do this, I'm going to say self.animation adjust speed, and I'm going to use the speed multiplied by the animation speed. Okay, so now that we have the increment speed function, what I'm going to do is go into tower functions, and I want to add the new tower type that we created. Remember, tower 2 is a type of slow aura. So what I'm going to do is copy and paste this like so, and this is going to be called slow aura. Now, unlike damage aura, we're not going to have a action, but we are going to have two other functions. One function is going to be called enter, and this is going to tell us when a character is entered into a tower. So we're going to receive the character that enters this tower. And we're also going to have another function called exit, and this is going to tell us when a character exits this tower. Now, all we're going to do inside of here is we're going to use the increment speed function. So I'm going to say character increment speed. And if we remember, we have a speed attribute, a slow attribute over here. So I'm going to say tower dot slow, but we want to subtract this value. And then when the character exits the tower, we're going to add this value. Okay, so now all we need to do is make sure we call these two functions when a character enters or exits a tower. So let's move this tower functions module to the side and let's go back to the tower class. And all we need to do is when the character is added, now I'm going to do this before we call action. So over here, I'm going to say if self.enter, call the enter function and pass the character that got entered. Now, because we're using a colon here, it's going to pass the tower automatically for us. And because we're passing the character here, it's going to pass the character over here. And we want to do the same when the character is removed. So over here, I'm going to say if self.exit, we're going to call the exit function. Okay, so we should have a working tower 2 now. So let's go back to the game object. And over here where we spawn tower 1, I'm going to slightly shift it to the right. So I'm going to set the X value to 5. And then I'm going to copy and paste this and create tower 2. But I'm going to set this to a -5. So it's on the left side. And then I'm going to play the game. So what we should see is when this character enters the slow tower, it gets slowed from 3 down to 0. So we can see it's now stuck, but this NPC has a speed of 4, so it only goes down to a speed of 1. So it continues to walk through. This character gets stuck because that also has a speed of 3. And once it exits, its speed goes back to normal. And once it enters the damage aura tower, it gets damaged and then it finished which is the path, where these stay here forever. Now, if you wanted to, you could go into the character class, and over here, when we set the speed, you could change this to 1. That way the speed will never go down to 0, so characters will never get stuck. Or if you don't mind them getting stuck, you can keep it at 0. I'm going to keep it at 0. But if you like, we can go to Tower 2 and change the slow amount to 2, and that will cause the other characters to not get stuck. So now we should see that all characters are able to walk through. Okay, so let's now add projectiles to our game. So I'm going to close all these modules, and first thing I'm going to do is create a brand new folder, and I'm going to name this folder projectiles. Then I'm going to create a part, and I'm going to name this part projectile 1. Then what I'm going to do is I'm going to set this to a color of institutional white. I'm going to set the material to neon, and then I'm going to set the size to 0.5, 0.5, 0.5, and I'm going to adjust the position. And what I'm going to do now is I'm going to set the can collide to false, can query to false, can touch to false, anchored to true, and I'm going to set the shape to a ball. And what I'm going to do now is inside of this projectile, I'm going to add a attachment, and I'm going to duplicate this attachment. Now this top attachment, I'm going to set the position to be half the size of the part. So the part is 0.5. So this attachment is going to have a position of 0.25. And this other attachment is going to be negative 0.25. And then I'm going to create a trail, and I'm going to set the attachment 0 to this attachment and attach 1 to the other attachment. And then I'm going to set face camera to true. I'm going to set light emission to 1. And what I'm going to do is set transparency, and I'm going to press these 3 dots, and I'm going to make it fade out to go all the way to transparent. And then what I'm going to do is set the lifetime to 0.1, and I'm going to set the width scale. So I'm going to make it scale all the way down to 0. And what I'm going to do now is move this projectile into the projectiles folder. And what I want to do now is create a new projectile class. So I'm going to duplicate the class template, and I'm going to name it projectile. Okay, so this projectile class is going to work a lot like how our characters work. So let's also open the character class, and let's put this to the side. And we're going to copy a lot of what we've done here. Okay, so just like we did over here, we're going to create a folder to place all our projectiles in. So at the top of this class, I'm going to say instance.new folder workspace, and I'm going to give it the name of projectiles. Then we're also going to have bulk move work in here. So just like we did over here, create these 3 arrays for bulk move. We're also going to create these 3 arrays over here. So we can have bulk move over here. We can have one called projectiles, one called parts, and one called C-frames. And we also want to connect to the post ticks event on the projectiles class. So let's copy and paste this over here, but we don't have a bulk move function. So let's go down and copy this bulk move function into here. And let's go back to the new function and complete the new function over here. So over here, we'll just receive a name, but for projectiles, we're going to receive the name, position, target, and ticks. So the name is going to tell us which projectile we want to clone from the projectiles folder. The position is going to tell us where we want the projectile to start. The target is going to be a part that the projectile is going to go to. And the ticks is going to tell us how many ticks we want this projectile to reach the target. Now, just like we did over here, we want to get the index value. So at the top, I'm going to say local index, and we're going to use the projectiles array to get the index +1. And then we're going to get, well, unlike the characters, we're not going to get the model, we're going to get the part because we're not using models for projectiles. So I'm going to say local part equals game replicated storage projectiles and use the name. And then I'm going to store the index inside of the object. So over here, I'm going to say self.index equals index. Then I'm going to store this position inside of the object. So I'm going to say self.position equals position. And then we're going to store the target part. So I'm going to say self.target equals target. And the amount of ticks, we're going to say self.ticks equals ticks. And then I'm going to clone this part the same way we did for the model over here. I can say self.part, part clone. And then I'm going to set the C-frame of this part. So I'm going to say part.cframe equals C-frame. And I'm going to use the lookAt, and we're going to start at the position that we passed in. And we're going to look towards the target part's position. And that's going to be our start C-frame. And finally, I want to parent this part into this folder we created up here. So I'm going to say self.part.parent equals workspace projectiles. And what I want to do now is connect to the onTick event, just like we did over here. So over here, I'm going to say self.tickConnection equals shared.task onTick, and we're going to pass in the step function. We currently don't have the step function. So let's bring in the step function like we did over here. And what I want to do now is add these values into these arrays, just like we did over here. So I'm going to say projectiles index equals self, parts index equals self.part, and finally C-frames index equals self.part.cframe. Okay, so let's now create the destroy function. So over here, just like we did for the character, we're going to have a destroy function. And then what I'm going to do is over here, we disconnect from the ticks connection. Here's our tick connection. We want to disconnect from it. So over here, I'm going to say self.tickConnection disconnect. And then just like we did over here, we destroyed the model, but over here, we want to destroy the part. So I'm going to say self.part destroy. And then over here, we did this to remove the character from the arrays that we have up here. So we're going to do the same thing. So this part over here, we're going to do this now. So first, we want to get the last projectile. And then we're going to check if self is the last projectile. If it is the last projectile, we just want to remove the last part and C-frame. So I'm going to say table remove parts, table remove C-frame. Else, if it's not the last part, we're going to do this. So we're going to say projectile self-index equals last projectile. Parts self.index equals table remove parts. C-frames.index equals table remove C-frames. And finally, we want to update the index. Last projectiles.index is now equal to the removed objects index. Okay, so let's now work on our step function. The way our step function is going to work is we're going to reduce the tick amount by 1. So I'm going to say self.ticks negative equals 1. And then I'm going to check to see if ticks is now equal to 0. So if it goes all the way down to 0, then what I'm going to do is call this destroy function. So we're going to say destroy self. I'm going to pass the self object into here. But if ticks is not equal to 0, then what I'm going to do is I'm going to update the position. So I'm going to say self.position equals self.position, and I'm going to use the lerp function. and I'm going to lerp towards the target position, and I'm going to use the value of 1 divided by ticks. So let me try to explain how this 1 divided by ticks and the lerp function works. So let's say that this red circle is the projectile and this green square is the target. So let's say that this projectile has 4 ticks it needs to get to the green part. So currently we're at 4 ticks. We're going to subtract 1 from the ticks amount. So now we have 3 ticks remaining. So we're going to do 1 divided by 3. So if we do 1 divided by 3 equals 0.333. So that means we're going to move 33% closer towards the target part. So if we move forward 33%, we should be around here now. Now 1 tick later, we're going to subtract 1 more tick. So now from 3, it's going to go down to 2. So 1 divided by 2 equals 0.5. So that means we're going to move 50% closer from this position towards the target part. So we move 50% closer, and now the projectile is going to be here. So this is 50% closer from this position, not this position. And then when we go to the next one, we're going to subtract 1 from the tick amount. So now we have 1 tick remaining. So 1 divided by 1 equals 1. That means we're going to move 100% closer towards the target. So now the projectile is going to be on top of the target. And finally, when we go to the next step, it's going to remove 1. Now the tick amount is going to be equal to 0. So we're going to destroy. Okay, so let's now work on the bulk move function. So in this function, we're going to loop through the projectiles and we're going to update their C-frame based on their position. So first, I'm going to loop through the projectiles. And then I'm going to use the bulk move function the same way we did inside of the characters. Bulk move. So here we can see that we just created a C-frame by passing in the projectile's position. So this is not actually going to rotate the projectile. Now this doesn't really matter in my case because my projectiles are a shape of a ball. But if you had projectiles that had meshes that need to point towards the target, instead of creating the C-frame like this, you would create the C-frame like this. So if you want the projectile to look towards the target, you can use this to create the C-frame. But if you don't care the direction that the projectile is looking, we can just use this more simpler version. And you can also see that we used look at over here. So if you wanted the projectile to start with a C-frame where it looks towards the target, you would use this. But if you don't care about the rotation, you could use the more simpler version of C-frame.new. And just pass in the position. Okay, so now that we've finished our projectiles, let's create a new tower and make it use the projectile class to attack the characters. So first thing I'm going to do is I'm going to duplicate tower 1, place it into workspace, and I'm going to rename it to tower 3. And then I'm going to change the color of this part. So I'm going to select a yellow color and I'm going to change some attributes. So for action delay, I'm going to keep it at 48, so it attacks once every second. I'm also going to keep the damage property. And for type, I'm going to change this to be called damage projectile. So over here, I'm going to rename this to be damage projectile. And then I'm also going to add some new attributes. So let's add a new attribute and I'm going to call this projectile and it's going to be a string. And I'm also going to set this projectile to projectile 1. So this is going to tell us which projectile we want to use for this tower. So if we go back to tower, I'm going to set projectile to projectile 1. And now I'm also going to set how fast I want this projectile to move towards its target. So I'm going to create a new attribute. It's going to be a number. And I'm going to name this projectile ticks. And I want the projectile to take half a second to reach its target. So I'm going to do half of 48, which is 24. Okay, so finally, inside of the primary part of the tower, I'm going to add an attachment, and I'm going to place this attachment to the top, and this is going to indicate where I want the projectile to spawn from. And now I'm going to move tower 3 back into the towers folder. And now I'm going to open tower functions, and I'm going to create a new tower type. So if we remember, tower 3 has a type of damage projectile. So I'm going to create a new type, and it's going to be called damage projectile. And then inside of this type, we're going to use the action function like we did for damage aura. So I'm going to copy and paste this function over here. Now the first thing I want to do is get the first character from the characters list. Now if we go back to the tower class, we can see that the action function only gets called if there is at least one character inside of the characters list. So we don't even need to check if there is a character inside of this list. We know that when this action function gets called, there's going to be at least one character in the characters list. Another thing we can do is we can use the get next function to get the next link to extract the value of the this value from the link. But another way we can do that, to get the character, what we could do is say local character equals tower.characters. Then we can use the next value, and then we can extract the value, which is this value over here, which is going to tell us the character. Okay, so now that we have the character, we want to use the projectile class to create a new projectile. And to create a projectile, I'm going to say share.projectile.new, and I'm going to pass in the towers projectile property. If we remember, we have a projectile property that is called projectile 1. So we're going to pass in projectile 1 here. Then I'm going to use the towers attachment, and I'm going to use its world position to tell where to start the projectile. And then I'm going to pass the model's torso of the character. And finally, I'm going to pass in the projectile ticks. If we look at the tower 3, we can see we have an attribute called projectile ticks, which is set to 24. And now what I want to do is use a task weight, but not Roblox's task weight. We're going to be using our own task weight, which we created over here. So I'm going to say share.task wait, and I'm going to wait for the projectile ticks. And finally, I want to increment the health of the character, just like we did up there. I'm going to say character increment health, and I'm going to subtract the tower damage. Okay, so let's now go back into the tower class, and I'm going to remove these prints because these character objects are getting quite large now, so it takes quite a while to print these. So these prints may cause stuttering for the game. So if we remove these, the performance should be greatly improved. And the next thing I want to do is I want to go into the game object, and I want to now spawn our new tower into the world. So over here, I'm going to copy tower 2. I'm going to rename this to tower 3, and I'm going to set it at a position on the x-axis at 0. And now I'm going to play the game. So we should see that when the character enters the red part, they slow down. And when they enter the yellow part will start attacking the NPC. Okay, so let's also make a slow projectile type. So it's going to be almost the same as damage projectile. I'm going to copy and paste this down here, and I'm going to rename it to slow projectile. We're going to get the first character in the list. We're going to create a projectile using the projectile attribute at the attributes world position. We're going to fire it towards the torso, and we're going to use projectile ticks. Then we're going to wait. Then instead of incrementing the health, we want to use increment speed. So let's move this over here. But instead of using the damage attribute, we're going to use a slow attribute. So let's change this to slow. Then what I want to do is I want to wait for a while. So let's do another task wait. But instead of the projectile ticks, we're going to use slow ticks. So we're going to add another attribute to the tower called slow ticks. And this is going to tell the function how long we want the characters to be slowed for. And then once this delay has finished, we want to bring the character back to its original speed. So I'm going to add the slow value back onto the character. Okay, so let's now improve our game object. So instead of manually having to spawn these characters in, let's make a kind of a basic round system that's going to continually spawn new characters into the path. So what I'm going to do is I'm going to create some new functions. I'm first going to remove this function over here, and I'm going to create a new start function. And this function is going to receive a round value, a difficulty, and a seed value. And then I'm also going to create a stop function. So what I want to do now is, instead of just starting the task manager over here, I want to start the task manager when the game starts. So I'm going to move that down to here. So when we call the start function for the game object, it's going to call the start function for the task object. Now, if we look at the task object, when we call the start function, it's going to return false if it fails to start the task scheduler, or it's going to return true if it succeeds in starting the task scheduler. So what I'm going to do is say if, and I'm going to place a then here. So that means we're only going to start the game if the task scheduler started. And I'm going to do the same over here. So here we can see we have a stop function and it returns false or true. So I'm going to say if shared.task, I'm going to call the stop function, then we're going to stop the game. Okay, so when the game starts, I'm going to check this round value, and if it's not set, I'm going to default the value to 1. So over here, I'm going to say round equals round. So if we set the value, it's just going to equal itself. But if this value is equal to 0, it's going to default to the value of 1. I'm going to do the same for difficulty. I'm going to say difficulty equals difficulty or 1. And I'm also going to do the same for seed, but slightly different. I'm going to say seed equals seed, or I'm going to select a random number between 1 and this value over here. And what I'm going to do now is use this seed value to create a random object, but I'm going to save that random object into the game object. I don't want it to be a local variable. I want it to be accessible from the other modules. So I'm going to say self.random equals random.new, and I'm going to pass in the seed into here. And now I can start a infinite loop. So I'm going to say while true do. So inside of this loop, the first thing I'm going to do is I'm going to loop based on which round we're on. So I'm going to say for index equals 1 to round, multiply it by 4. So for every round, we're going to spawn 4 characters. So for round 1, we're going to spawn 4 characters. Round 2 is going to have 8 characters, and it's going to keep incrementing in 4s. Okay, now what I want to do is spawn a character. For now, I'm just going to spawn character 1. So I'm going to say share.character.new, and we're going to spawn character 1. And then what I want to do is I want to wait but I'm going to use this random object to wait for a random amount of time. So I'm going to say share.task wait, and we're going to use the random object, and we're going to use next integer, and I'm going to wait between half a second and 1 second. What I want to do now is once the round has finished, I'm going to wait for 480 ticks, and then I'm going to increment the round value by 1. So I'm going to say round plus equals 1, and then what I'm going to do is say if round modulus 5, so every 5 rounds, I'm going to increment difficulty by 1. And now, instead of creating the characters over here, I'm going to delete this part. I'm still going to create the towers for here, over here for now. But what I'm going to do is I'm going to call this start function. And for the round, I'm going to just pass in nil. So it uses the default value of 1. For difficulty, I'm going to pass in nil. So it uses the default value of 1. And for seed, I'm just going to use this random number. And if you use the same random number as me, then you should have the exact same outcome as me if you followed everything in my project exactly the same. So we should see that 4 characters get spawned, and then we should see 8 characters get spawned, and after this we should see 12 characters get spawned, and it should keep increasing higher and higher every round. Okay, so what I'm going to do now is make a few changes. So instead of being between half and 1 second, I'm going to have it between 1 second and 2 seconds. So 2 seconds should be 96 ticks. And instead of using a fixed value of 4 here, what I'm going to do is I'm going to use this random object to pick a number between 2 and 4. And another thing I want to do is tower 3. I don't want it to slow actually it was tower 2. I don't want it to slow by 2. I want it to slow just by 1. And another thing I want to do is I'm going to change the speeds and health of all these characters. So instead of having a speed of 3, I'm going to have a speed of 4, 5, and then 4 again. And actually, I think this should be a 4 as well. And finally, I'm going to set this to a speed of, I think, probably a 4 as well. And I'm also going to update the health. So set this one to 20, 40, 60, 80, and 100. Okay, so if we wanted to test to see if our game is really deterministic, what we could do is, if we minimize these, I'm going to copy the module loader and I'm going to paste it into server storage, and then I'm going to change the run context from client to server. And now, because we're using the same seed for the server and client, all this randomness should be the same. And because our game is deterministic, the outcome should also be the same. So if we press play, we'll see that there is now 2 characters, one being the server side and one being the client side. But because the start time is not exactly the same, they're slightly delayed between each one. But that doesn't really matter because the outcome of the 2 should be exactly the same. So we can see that this time 1, 2, 3, 4 characters were spawned on both the server and the client. And this was done without any remote events between the server and client. And we can also see that the outcome of the game should be exactly the same. We see these two characters survived on both the client and the server. Okay, let's now delete this module from the server side because we don't want to see the server side anymore now that we know that they both work in sync. So what we want to do now is inside of the game object, instead of just always spawning character 1, I want to select the character based on the difficulty value. And the way I want this to work is if the difficulty is set to 3, I want a kind of bell curve to select the characters. So character 3 will have the highest chance of being selected, while character 2 will have a slightly less chance of being selected, and character 1 will have an even less chance of being selected. And if the difficulty changes to 4, then this bell curve will shift to the right, and now character 4 is going to have the highest chance of being selected. Easiest way to make a bell curve is to simply add two randoms together. So let me demonstrate how this is going to work. So over here, let's just make a little demo to see how it's going to work. First thing I'm going to do is create a variable called difficulty range, and I'm going to set this to 10. Then I'm going to make a dictionary and I'm going to call it selected. And then I'm going to loop from 1 to 1,000. And inside of this loop, I'm going to use this random object to pick a random number. So I'm going to say local random equals self.random, and I'm going to add two randoms together. So remember, this random number can pick a value between 0 and 1, and this can also pick a value between 0 and 1. So that means when we add them together, it can go from 0 all the way up to a value of 2. But the value of 1 is going to have the highest chance of being selected. Okay, so now what I'm going to do is I'm going to select a index based on this random value. So to do that, I'm going to say index equals math.round, and I'm going to multiply this random number by the difficulty range, which we set to 10. And then I'm going to use this index to add a value to this table. So over here, I'm going to say selected.index equals selected.index. If this index doesn't have a value just yet, we're going to default to the value of 0, and then we're going to add 1. And finally, when we get down here, I'm going to print the selected table. And if we now play and stop the game, we should see that the selected table, we can see that the index of 10 has the highest chance, while the index of 1 and 20 has the lowest chance. So we can see index 1 got selected 6 times, index 2 got selected 21 times, index 3 got selected 28 times, and we can see that index 10 got selected 98 times. Now index 10 should have a higher chance than index 9, but because they're quite close, we can see that index 9 got selected more than index 10, but this is out of the ordinary. Now if we wanted to, we could increase this 1,000 value so we can get better results. And another thing we could do is if we subtract the difficulty range over here, instead of being 10 having the highest chance, it would cause value 0 to have the highest chance. So let's play the game again. And let's stop the game. And now we should see that value 0, index 0, has the highest chance. And then negative 10 only got selected 7 times, and positive 10 got selected 12 times. So these negative 10 and positive 10 should have the same chance of being selected, while a value index of 0 should have the highest chance. So all we need to do now is, because it's going to be around the value of 0, the index of 0 is going to have the highest chance. We want to have the chance be based on the difficulty value. So all I need to do is add difficulty over here. And now, because difficulty is set to 1, index 1 should have the highest chance. So we can see index 1 got selected the most. And if we change the difficulty value, so if I passed in a value of 52 and press play, we should see that the index of 52 got selected the most. Okay, so what I'm going to do now is change this back to nil. So the difficulty starts at a value of 1. And now what we need to do is use this index to select the character from over here. But if we use get children, the order of get children is undefined, meaning that it's not based on the difficulty of each character. So what we want to do is create an array of characters based on their difficulty. So what I'm going to do inside of the data, I'm going to create a new module script, and I'm going to name this module script characters. Now what we want to do in here is we want to return an array of characters, and it's just going to be an array of strings, and it's going to be in order from easiest to most difficult. So it's going to be something like this. Now we could manually write this out, but if we have hundreds of characters, we don't want to have to manually enter the characters in from easiest to most difficult. So it would be good if we could automate this array to generate on its own. Okay, so the way we're going to do this is first we're going to get all the children from the characters folder. So to do this, I'm going to say local characters equals game.replicated storage characters get children. Then I'm going to sort this array of characters based on the characters attributes. So I'm going to create a custom sort function. And what I'm going to do is I'm going to add the health and speed together to get its difficulty value. So I'm going to first get the difficulty value of character A. So to do that, I'm going to say local A value equals A get attribute health plus A get attribute speed. Now, I'm just going to have a equal weight between these two attributes, but if you wanted health to have a more higher weight in its difficulty value, you could multiply this by 2, for instance, but I'm going to have them have a balanced weight between these two attributes. And then I'm going to do the same to get character B's difficulty value. So I'm going to say b.value equals get attribute health plus get attribute speed. Okay, so now what I want to do is I'm going to check to see the difference between these two values. Now, if character A and character B have the same difficulty value, then I'm going to sort them based on their name. And that's very important because get children is undefined. And if we did not sort the values, if the values are the same and we don't sort them by name, then one client may select a different character over another character, and it's going to cause the two clients to go out of sync. So what I'm going to do is I'm going to say, if value A is equal to value B, then we're going to sort based on their name. But if value A is not equal to value B, then we're going to sort based on their value. So as long as we have a unique name for each character, then all clients should have a character array that's in the same order. Okay, so currently this character array is an array of these models, but we want to use strings. So we're going to convert this array from models to strings. So to do that, it's pretty simple. We just loop through the characters and then we update the value to be the child's name instead. So instead of pointing to these models, it's going to point to the name of the model instead. And then finally, we just want to return this character array back. Okay, so now if we go back to the game object, if we wanted to, we could just print shared.characters. And if we press play and stop the game, we should see that the second array is character 1, 2, 3, 4, 5. But if we, for instance, updated character 1 to have a health of 200 and then play the game again, we should see that character 1 now goes to the end of the list instead of being at the front of the list because it's now the most difficult character in the game. So let's change character 1 back to a health of 20. And so now we want to use this index value to select the character from this characters array. So let's now move this demo code into the actual round loop to select the character. So the first thing I'm going to do is I'm going to move this difficulty range to be at the top of the module. And instead of being a distance of 10, because we only have 5 characters, it's kind of wide. So I'm just going to change this to 3. And now let's move this demo code into the actual game loop. So before we create character 1, what I'm going to do is I'm going to move these 2 lines over here. So we're going to select a random number. We're going to select the random index based on the difficulty value. And then we're going to use this index to select a character from this characters array and pass that character string into the new function. So I'm going to copy this over here and we're going to select the character using this index that we picked over here. And then I'm going to pass this string into the new function like so. And now we can delete this code up here. And now we're selecting a character based on the difficulty. But we have one problem. This index can go out of bounds of this character array because it can go down to a negative number and it can go to a value higher than 5, which is our max character amount of characters. So what we want to do, we want to clamp this index to stay within bounds of this characters array. So over here, I'm going to say index equals math.clamp, and we're going to clamp the index value between a value of 1 and the length of characters. So now we should not select a character out of the bounds of this array. And if we now copy this modules script and paste it into server storage and change this to a run context of server and play the game once again, we should see that both the server and client should select the same models. Now we can see character 1 got selected 3 times because it has the highest chance of being selected. Character 1 got selected again, character 1 got selected again, character 1 got selected again. Keep selecting character 1. Here we can see another character got selected. I'm not too sure what character that is. If we check over here, see it's character 3. Okay, so now that we know that everything is working, let's delete the server side again. Okay, so let's now go about solving another problem that we have. If I comment out these tower news, and if I create a new tower but use the delay function to spawn a tower, so over here I'm going to say share.task delay, and I'm going to delay it for 150 ticks. I'm going to spawn a new tower. I'm going to spawn tower 2 and at a position of 0, 0, -25. Now another thing I'm going to do is I'm going to change tower 2 to have a slow speed of 3, and then I'm going to play the game. Now let's take a look at this first character. When the tower spawns in, this character is not slowed, but when it gets to the exit waypoint, it's sped up. So we can see it speeds up, where these characters do slow down, where that character never. Now the reason this happened was when we spawned this tower, the character was already inside of the tower's range. So the enter waypoint was not called, but the exit waypoint was called. And if we look at the exit function for tower 2, which is a slow aura type, so we go into tower functions, we can see that when we exit, we increment the character speed by the slow amount. So this function was not called for the character, but this function was called when it exited, and that's why the character sped up. So in order to solve this problem, what I'm going to do is when we spawn a tower, I'm going to loop through every waypoint along the tower from the enter to the exit, and inside of these waypoints, I'm going to store which character is currently at this waypoint. And then for every character in these waypoints, I'm going to insert them into the tower. So to do this, what I'm going to do is let's open our waypoint class, and let's also open the tower class and put the tower class to the side. Now, it's going to work a lot like how we have this hybrid list over here for characters. So I'm going to copy and paste this into the Waypoint class. So we now have a hybrid list of characters, and just like we did over here, we insert the character to the back of the list. When we add the character over here, we're going to also insert the character to the back of the list. And I'm also going to have a remove character function. So let's copy this remove character function. And we're going to remove the character from the list. And then if we want to, we can also have a separate event for when a character is removed. So we can create a new event, call it character removed, and we can fire this after we have removed the character. Okay, so what I'm going to do now, I'm just going to move this to the top because I prefer it at the top. Okay, so if we now go back to the characters class, let's place this to the side. And inside of the characters class, we can see we add in the character to the waypoint. We're calling this function over here, which adds it to the list. And we can also see that we're using add character over here, which adds it to the list, but we're never removing it from the list. So this list is going to get bigger and bigger and bigger, and it's never going to get smaller. It's going to have a memory leak. So what we need to do is, before we update the waypoint to this new waypoint, that where we add the character, we want to remove it from the old waypoint. So all we need to do is say self.waypoint. We're going to call the remove character function and pass in self, which is the character. And another place we need to add remove character is inside of the destroy function. So up here at the top, before I remove myself from the towers, I'm going to also remove myself from the waypoint. And there we have it. So now we should not have a memory leak anymore. Another change I'm going to make is I'm going to go back into towers. And over here, instead of using the character added event for the exit waypoint, I'm going to change it to be the character removed event. Now this doesn't have a big difference. It's only a very small difference. It's just going to cause the character to be removed slightly later on in the path. But I think this makes more logical sense. So I'm going to change these to be character removed. And if we just want to make sure that everything is still working correctly, what I'm going to do is I'm going to play the game. Now the character should still get boosted because we haven't looped through the waypoints and added this character into the tower yet. But we should see that the exit waypoint, even though we're using character removed, should still work. So once these characters exit this waypoint, so before these would have sped up by now, but you can see they sped up slightly later on because it waits till they exit this waypoint before they speed up. Okay, so what we need to do now is when we connect to the character added and character removed connection events for these enter and exit waypoints, we need to loop through every waypoint starting from the enter waypoint up to this exit waypoint and call character added, meaning add character, for all the characters within these waypoints. But the problem is we don't know the indexes for these waypoints to loop through them. We could calculate it using the distance, but that's going to be kind of complicated. So the easiest way to do this would be to save the index of a waypoint inside of the waypoint object. So over here, I'm going to receive the index, and then I'm going to save the index inside of the waypoint. So now, if we go back to the path object, and over here where we create the waypoint, I want to use the length of this waypoint. So I'm going to copy and paste this, put the hash in front so it gives us the length, but this is the length before it was inserted into the waypoint. So what we need to do, we need to add 1 so it tells us the length after this waypoint was inserted. So this should be the correct index that this waypoint that we create is in this waypoints array. So now we can access this index value over here within the tower to loop from the enter waypoint up to the exit waypoint. Okay, so now over here, I'm going to loop from the enter to the exit waypoint. To do this, I'm going to say for index equals enter waypoint dot index, and we're going to loop all the way up to the exit waypoint dot index. But the thing is, because we're looping from front to back, what's going to happen is we're going to call add character, and the characters at the front of the path are going to be inserted first, and the characters at the back of the path are going to be inserted last. And if we look at the tower functions, we can see that here we get the character from the front of the list. So that means if we insert them from front to back, it's going to attack them from front to back. But I want the tower to first attack the last character, then go backwards to the first character. So what I'm going to do is I'm going to reverse this. So instead of starting at the enter waypoint, we're going to start from the exit waypoint, and we're going to iterate downwards. So to iterate backwards, we need to place a -1 here. So now we're going to iterate backwards and place the characters into the characters list in the reverse order. Okay, so now we can use this index value to get the waypoints characters list, which is a hybrid list. So over here, I'm going to say local characters equals shared.path.waypoints. I'm going to use this index value to get the characters list. And then I'm going to get the first link in the list. So I'm going to say characters link equals characters.next. And then I'm going to say while character link is not equal to characters do, and then I'm going to add the character from this character link using the add character function. So to do that, I'm going to say self add character link dot value, and finally I want to iterate to the next character link. So I'm going to say character link equals character link dot next, and I also want to make sure I do this over here as well. So I'm going to copy and paste this over here. So now if we add a new waypoint over here, we also insert the characters over here. And if we now playtest the game, we should see that that first character that used to not get slowed down now does get slowed down. So even though he was already inside of the this waypoint over here, he still got added to the tower. And now when he leaves, he doesn't speed up faster than he should go. He goes up to his original speed. Now everything seems to be working correctly, but we do have a slight problem. If I go back to the game object, and if I change tower 2 to tower 3, and if we look at tower 3, we can see it's the damage projectile type. So what's going to happen is when we loop through the waypoints and we find a character, we're going to call the add character function. So let's go down here to the add character function. So we insert the character into the list, hybrid list, and we then check if there is a enter function. And if we check the tower functions, we can see that damage projectile does not have a enter function, so that's going to be skipped. Then we're going to check if there's a action function. Well, there is a action function. And we're going to check if there's a action task, which there's not, so it's going to call action. So it's going to call this function down here. We're going to check if length is greater than 0, which it is because we've already just inserted a character. So it's going to go down here. It's going to schedule another action to take place after the action delay. And then finally over here, it's going to call the action function, which is this function over here. Now, when we call this action function, within this function, we have a wait. So what's going to happen is this action function is going to wait, and it's not going to prevent this function not to return, which is going to block this add character function from continuing. So what's going to happen is this loop is going to be delayed until this task wait ends. And that's going to cause problems because it's going to delay the connections from being connected. So what we need to do is, instead of having this wait block the loop, we need to somehow create another thread for this action to be called on so it does not block this loop over here. So we can do that by using this threads object that we used before. We can use this spawn function. So what I'm going to do is I'm going to come down here, and when we call the action function, instead of just calling it directly like this, I'm going to say shared dot threads, and I'm going to use the spawn function, and then I'm going to tell it to spawn what function and which parameters it needs to pass. So I'm going to say spawn the self dot action function, and you want to pass in self as a parameter, because remember, we'll receive the tower over here as a parameter. And now I can remove this. So now, because we're spawning a new thread, it's not going to block this loop over here. Now currently, inside of our enter and exit functions, we don't have any waits, so we don't really need to spawn a thread for enter and exit. But just to be safe for in the future, if we ever do decide to add a wait within the enter or exit functions, I'm also going to spawn for this enter function and for this exit function. So just like we did over here, I'm going to replace this with self.enter, but we also need to pass in the character to the function, like so. And now I can delete this. And also, when we call the exit function, I'm going to do it again. So I'm going to pass in the exit function, and now we can replace this with this. So now add character and remove character should never be a blocking function. Okay, so now that we're saving the characters within each waypoint, we can use this information to create a tower that does AOE damage. So let's close all these modules and let's create a new tower. So I'm going to duplicate tower 3, and I'm going to name this tower tower 4. And then I'm going to change the color to a green color. And then I'm going to set some attributes. So I'm going to call it, have a type of damage, AOE. And I'm also going to add a new attribute, which is a number. And I'm going to name it area. And this value is going to tell us how many waypoints to the left and right of the current waypoint are we going to search for characters. So I'm just going to set this to 8. So we have a large area of effect, just so that we can see it working correctly. And now I'm going to go back into tower functions, and I'm going to add a new tower type. So remember, this one's called damage projectile AOE, which is going to work a lot like damage projectile. So let's copy and paste this one so we can use it as a template and add AOE to the end. Once we've waited for the projectile to reach the model's torso, I'm going to spawn a explosion at the torso's position. So what I'm going to do is over here, I'm going to say local explosion equals instance.new explosion. I'm going to position this explosion at the model's torso position. I'm going to set the blast radius to the tower's area, which was set to 8, multiplied by the step studs. So if we look at the path object, we can see that step studs is set to 2. So that's the distance between each waypoint. And that's what we're going to use to calculate how large this explosion needs to be. And then we're going to set destroyed joints radius percent to 0, blast pressure to 0, explosion type no craters, and I'm going to parent this explosion to workspace. Okay, so in order to work out which indexes the waypoints we want to use to get the waypoints characters list so that we can loop through these characters and damage them all, what we're going to use is inside of the character, there is a waypoint index value, and this is going to tell us which index this character is at. And then we're going to use that index to calculate all the indexes we will need to loop through. So to get the star index, I'm going to say math.max character waypoint index subtract the tower's area, which is a value of 8. And we're going to clamp this value down so it doesn't go lower than 1. So we don't go outside of the bounds of the waypoints. And then to get the end index, we're going to use the character waypoint index again, but instead of minusing the area, we're going to add the area. And we're also going to limit this value to not go higher than the amount of waypoints that we have. And now that we have the indexes, let's loop through these indexes. So to do this, I'm going to say for index equals star index, and we're going to loop up to the end index. And then we're going to use this index value to get the waypoint from the path object, which should be inside of this waypoints array. So I'm going to say local character link equals, so it's almost the same as how we did it up here. We want to get the waypoints characters, not the towers characters. So we're going to say shared path.waypoints. We're going to use the index to get the waypoint. Then we're going to get the character list. And then we're going to say .next to get the first link in the list. And then we're going to loop through the same way we did over here. We can just copy and paste this over here, but this needs to be changed to this character over here. So what I'm going to do is I'm going to say local characters equals, and I'm going to move this into this and replace this with characters. And then over here, we can just check it with characters like so. And yeah, I think that's about it. So we can now remove this because we're doing this over here now. So this should work correctly now. Okay, so what I want to do now is I'm going to close these modules and I'm going to open the game object, and I'm going to change tower 3 to tower 4 so that we can test our new AOE projectile. And let's press play. And we should see the AOE projectile get spawned, which does an explosion, which damages all these characters in an area of effect. Okay, so what I want to do now is, remember at the start of the video, I said that when we send an event from the server to the clients, telling them to build a tower, we're going to tell them to build a tower in sometime in the future. That way, all clients, even ones with higher amounts of ping, should get the message before the tower is built so that they can all stay in sync. So what I want to do now is I want to have a build and deconstruct delay for towers. So what I'm going to do is I'm going to select all the tower models, and for the attributes, I'm going to add a new attribute. It's going to be a number, and the first attribute is going to be called construct delay. And I'm going to add another attribute, which is also a number, and it's going to be called deconstruct delay. So the construct and deconstruct delay is going to be based on ticks. So if we have 48 ticks a second, if I want to construct and deconstruct in 5 seconds, that would be 48 multiplied by 5. So it would be 240 ticks to have a construct and deconstruct amount of 5 seconds. So what this means is, if we have a construct and deconstruct delay of 5 seconds, now if we convert this to milliseconds by multiplying it by 1000, so there's 5000 milliseconds to construct and deconstruct. Now remember that when we measure ping for a player, it's the time it takes to go from the client to the server then from the server to go back to the client. But when we send a remote event from the server to the client, it's only going one way, so it's only going to be half the time of their ping. So what we can do is multiply this by 2, and that means this construct and deconstruct properties are going to support a ping of up to 10,000. So that means if a player has a ping less than 10,000, they're not going to go out of sync. But if they have a ping higher than 10,000, then they are going to go out of sync. So if you wanted to support players with higher ping than 10,000, you would need a higher construct and deconstruct delay value. So let's, for instance, say 10 seconds. So if we did 48 times 10, this would tell us how many ticks we would have to wait to wait for 10 seconds. So we'd change this construct and deconstruct value to 480 to be 10 seconds. And then let's convert 10 seconds to milliseconds by multiplying it by 1000. And then we need to multiply by 2. So this would support a player ping of 20,000. So we support a player ping of 10,000, but if we change it to 480, it would support double the amount of ping. But I feel that most players are going to be under 10,000 ping, so I'm happy to use a value of 5 seconds for the construct and deconstruct delay. But if you're not happy with 10,000 ping and you want to support a higher amount of ping, it would require you to use a higher construct and deconstruct value. Okay, so now that we have these two attributes, let's go back into the tower class. And now I'm going to use the tower's construct delay to calculate which tick we need to construct this tower. Now in the future, this tick value is going to be sent from the server, but just for now, I'm going to calculate it locally. So what I'm going to do is over here at the bottom, after we've calculated the waypoints, I'm going to say local construct tick equals shared.task.tick. This is going to tell us the current tick that we're at. Remember, inside of our task object, we have this tick value that keeps incrementing every tick. And so we're going to say the current tick plus the construct delay. So now what we want to do is use this construct tick to work out how many ticks we must wait before we need to build this tower. So to do this, I'm going to say local construct ticks equals construct tick negative the current tick. Now this is confusing because this value is always going to be equal to this value, but in the future, this construct tick value is going to be sent to us from the server, and we're not going to calculate it locally like this. So this construct tick, the construct ticks, is not going to be the same as construct delay in the future when this value is sent to us by the server, because if the remote event takes a long time to get to us, it's going to be a smaller value than construct delay. But for now, because we're calculating it locally, this value and this value are both going to be the exact same number. And what I'm going to do now is I'm going to check this construct ticks value, and I'm going to say if construct ticks is less or equal to 0, I'm going to print a warning saying that tower event received too late, you may experience desyncs. Now you may want to place a notification on the screen for the client to see so that they know they have too much ping and that they may experience desyncs in their game. Okay, so now we know how many ticks we need to wait before we build this tower. What I'm going to do is create a new private function. So I'm going to place this above action, and I'm going to call this function construct. And then over here, after we've sent this warning, now this warning should never really happen, but if someone has more than 10,000 ping, then they're most likely going to see this warning. And over here, what I'm going to do is I'm going to use task delay, the one that we created in our task object. So I'm going to use self.construct task equals share.task delay, and I'm going to pass in the construct ticks. I'm going to call the construct function, and I'm going to pass the self object as a perimeter. Okay, so let's now create the deconstruct function. So over here, I'm going to create another private function called deconstruct. And this function is going to work almost the same as how we did it over here, but we're going to be calling this deconstruct function from the destroy function. So first thing I'm going to do is I'm going to move all of this into the deconstruct function because I only want the connections to be disconnected and the action to be stopped when it's fully deconstructed. And then over here, I'm going to say, I'm going to use this same thing we did over here, but I'm going to say deconstruct tick is equal to the current tick plus the tower's deconstruct delay. Okay, now in the future, this is going to be sent to us from the server, but currently we're just going to work it out locally. And then the same we did over here, I'm going to say deconstruct ticks is equal to deconstruct tick negative the current tick. And then I'm going to also have a warning if the deconstruct tick is below or equal to 0. And then I'm going to create a delay, and I'm going to call this deconstruct task, and we're going to call the deconstruct function, and it's going to be based on how many the deconstruct ticks. Okay, so when the server tells us to destroy a tower, we're going to receive which tick we need to destroy the tower on. We're going to wait for that delay, and then we're going to destroy the tower over here. But we also need to do the same over here for new. So when the server tells us we need to build a tower, instead of connecting to these waypoint events over here and adding the characters over here, we need to do this part of the code down here inside of the construct function. So the way I'm going to do this is the server is going to tell us an array of waypoint indexes. So up here, I'm going to say local waypoint indices equals an empty array. And then over here, instead of doing this, I'm going to comment this out. And over here, I'm going to say table.insert, and we're going to insert into the waypoint indices. And I'm going to pass in the enter waypoints index. Remember, the index is stored inside of the waypoint object, so we can get the index like this. And then I'm going to also insert the exit waypoints index. And I also want to do the same down here. So I'm going to comment out this part of the code and copy and paste this over here. Okay, so this is what the server is going to do, and it's going to send the client this array of indices. And then we're going to receive these indices, and we're going to use them inside of construct to do this part that we've commented out. So in order to receive the indices inside of the construct function, all we need to do is pass the indices into the delay function. So after we pass in self, we're going to pass in the waypoint indices, and then over here we can receive the waypoint indices. Okay, so the first thing I want to do inside of this construct function is to iterate through the waypoint indices. Now, if you remember, these indices are inserted in pairs of 2. So whenever there's a enter waypoint added, there's always a matching exit waypoint added after that enter waypoint. So the way I'm going to do this is I'm going to say for index equals 1 to the length of waypoint indices, and I'm going to increment in 2s. And now I can get the enter and exit waypoints by doing local enter waypoint equals shared.path.waypoints. Then I'm going to get the index of that waypoint from the waypoint indices array using the index that we got over here. And then to get the exit waypoint, it's almost the same, but we just add 1 to the index. Remember, we're going in 2s, so we can add 1 here. And then all we need to do is this part of the code, but down there. So let's cut and paste this down here and uncomment it. So this part should work correctly. Once we have our enter and exit, we loop through the waypoints, we add any characters, and we also connect to their character added and character removed events. So now we can delete this, and we can also delete this. So in the future, this part is going to be done by the server, and it's going to send us this array, and we're going to use this array to add the characters and connect to their events. And if we now playtest the game and count for 5 seconds, we should see that the tower should start attacking after the 5-second delay. So 1, 2, 3, 4, 5, and we can see it starts attacking. So we can see the construct delay worked correctly. And if we want to check to make sure our deconstruct delay is working correctly, I'm going to go back into tower. And when we call the destroy function, I'm going to print destroy. And then I'm going to go back into our game object. I'm going to comment out this delay to spawn tower 4. And over here, I'm just going to instantly spawn tower 4. So I'm going to say share tower.new, tower 4, pass in the C frame. And then I'm going to use task delay to destroy this tower. So over here, I'm going to say shared.task delay, and I'm going to call the destroy function for this tower and pass in the tower object into the destroy function because there's a colon here. And I'm going to do this after 300 ticks. So if we now play the game, we should first see it prints, and after 5 seconds, it should get destroyed. 1, 2, 3, 4, 5, and it gets destroyed. Okay, let's remove this delayed destroy and bring back the tower 4. And let's also remove this print over here now that we know that the deconstruct function is working correctly. Okay, so what I want to do now is have it so that the client is able to see that a tower is constructing or deconstructing. Now you guys may want to have a cool animation that allows your towers to construct and deconstruct, but I'm just going to keep it simple and use a bar from our bar class. So what I'm going to do is over here, I'm going to create a bar. I'm going to say self.bar, and I'm going to use share.bar.new, and then I'm going to pass in the model's primary part, which is this part of the tower. And then I'm going to set the value to 0 and the max value to the construct ticks. And then I'm going to pass in a color, which is a blue color. Now, one thing we need to be careful of is when we set the max value to construct ticks, if we look at the bar class, we see the max value gets stored here, and then we divide by the max value. Now, if construct ticks is equal to 0, it's going to cause an error because we're going to be dividing by 0 here. So what I want to do is, over here, when we give the warning, I'm going to say construct ticks equals 1, and that way we shouldn't get an error over here if construct ticks was less than or equal to 0. And what I want to do now is update this bar every tick. So I'm going to create a brand new function. I'm going to place it above construct, and I'm going to call it construct tick. And then over here, after I've created the bar, I'm going to connect to the onTick event inside of the task object, this event over here. So over here, I'm going to say self.constructConnection equals share.task onTick connect, and I'm going to connect the construct tick function, and I'm going to pass in self so we can receive self over here. And now inside of this construct tick, all I want to do is increment the value of the bar. If we remember, inside of the bar, we have a increment function where we can pass in a amount to increment. So over here, inside of the construct tick, all I'm going to say is self.bar increment, and I'm going to increment it by 1. And another thing I want to do is once we've completed the construction, I want to cancel disconnect from this tick event. So over here, I'm going to say self.construct connection disconnect. So here we're connecting to the onTick event, and when we've constructed, we disconnect from the tick event, which is going to stop this increment from happening. Another thing I want to do is I want to destroy this bar because I no longer want to see it once the tower has been constructed. So all I'm going to say is self.bar destroy. So if we look inside of the bar class, we can see there's a destroy function. And if we now play the game, we should now see that the tower has a bar. The bar increments. Once it gets to the top, it gets destroyed and the tower starts attacking. Okay, so let's now have a bar when a tower is deconstructing as well. We could have two separate bars, but I'm going to share the same bar for constructing and deconstructing. So the way I'm going to do this is over here, when we call the destroy function, I'm going to check to see if this construct connection exists or if it doesn't exist. So the first thing I need to do is make sure I set this back to nil when we disconnect, so that when we call the destroy function, I can check this value to see if we currently have a building bar or not. And then over here, I'm going to say if self.construction connection is equal to nil, then that means this bar was destroyed. So we need a new bar. So I'm going to say self.bar equals this. Then I'm going to have a else. If this does exist, that means we're currently ticking the bar. We want to cancel this connection. So I'm going to disconnect from it like this. And when we disconnect from it, I also want to set to nil. That way, because this construct function is still going to get called even after we call the destroy function. So what I want to do is I want to set this to nil over here. And then over here, I want to check to make sure that it's not nil. So I'm going to say if self.construct connection is not equal to nil, then I want to do all this. So either the construct function gets called first, which disconnects and destroys the bar, or the destroy function gets called first, which disconnects and sets construct to nil, but it doesn't destroy the bar because we're going to recycle the bar to be used for deconstructing. Now, when we create the bar, instead of having it from 0 up to this value here, we're going to set it to deconstruct ticks, and I want it to start at the max value, and I want it to increment downwards. So it's going to increment in the opposite direction. Now, just like we did here, if this value is equal to 0 or less, then I'm going to set to 1 so that we don't get an error, because we're going to be dividing by 0 if this deconstruct ticks is equal to 0. So I'm going to say if deconstruct ticks is less than or equal to 0, then deconstruct ticks equals 1. And over here, if we recycle the bar instead of creating a new one, I'm going to use the set function to set the value and max value. So let's go back to tower, and I'm going to say self.bar, and I'm going to use the set function, and I'm going to pass in the deconstruct ticks for the value and max value. Okay, another change I want to make is over here, we're saving the deconstruct task, but this deconstruct task is never going to get cancelled. So we're saving it for no reason. We could just get rid of this and not save it at all. And now I want to do the same, which I did over here, is I want to connect to the not construct ticks, but deconstruct ticks. So over here, I'm going to copy and paste this function over here, but I'm going to rename this to be called deconstruct ticks. And instead of incrementing the bar by 1, I'm going to subtract 1 from the bar. So it goes downwards. And then over here, I want to connect to the onTick event. So I'm going to say self and I'm going to name this one deconstruct connection equals shared task on tick connect, and I want to connect the deconstruct tick function. When we deconstruct, just like we did over here, I want to disconnect, but I don't want to disconnect the construct connection. I want to disconnect the deconstruct connection. And it's always safe to deconstruct this and always safe to destroy the bar, because the bar is always going to exist when we're deconstructing, and the connection is always going to exist when we're deconstructing. Now, another thing we need to be careful of is this deconstruct function can get called before this construct function. For instance, let's say our tower had a very long construct delay, but a very short deconstruct delay. Now, if we call construct to be called after 2,400 ticks, and then after a few ticks, the client decides to destroy that tower, we can call the deconstruct to happen after 240, which is going to take place before this construct delay had a chance to finish. So what we need to do is see over here, when we create the delay, we save the task. What I'm going to do is when we construct, I'm going to set this task back to nil, and that's going to indicate to the deconstruct function if this task is still active or not. If it is active, what I'm going to say is if self.construct.task, then, because remember this task is a link in the list, we're going to call the remove function. So if we look at our linked list, we can see there's a remove function here. So I'm going to say remove end. So that's going to prevent this construct function from being called when we call the deconstruct function. Okay, so let's slightly clean some things up. I think I'm going to move this delay down here. Doesn't have no difference, but I just feel it looks better down there. And I'm going to do the same down here. I'm going to move this down here, like so. Another thing you might be wondering is, should we not be removing this construct task when we call the destroy function? And the answer is no, because this destroy function can happen on different ticks. Remember, it's not been scheduled to happen in sync between all clients. So if we removed this task over here, it could cause the clients to go out of sync, because maybe one client may not remove it quick enough, and this task would finish, which would cause the tower to attack, while another player could remove it earlier if they received this destroy function earlier on, and it would prevent the tower from attacking. So that's why we cannot place this into the destroy function. Okay, so let's now test to make sure that the bar works correctly when we call the destroy function. So I'm going to go back into game. I'm going to comment this one out once again. And then I'm going to say local t equals shared tower.new. I'm going to create tower 4 at this C frame. And then I'm going to schedule for the tower to be destroyed after 400 ticks. And if we now play the game, we can see that the bar loads up. Once it's constructed, the bar is destroyed. And then once we call the destroy function, the bar goes down, it continues to attack. And then once it reaches 0, the tower is destroyed. Okay, let's now see what would happen if we call the destroy function before the tower has had a chance to construct. So if we look at tower 4, the construct delay is 240. So instead of using 400 over here, I'm going to use a value of 200. So it should call the destroy function when there's still 40 ticks remaining to be constructed. So let's play the game again. And we should see that before the bar gets to the end, it should jump to the end and then start deconstructing. We can see it still got this constructed and started attacking. And then once it got deconstructed, it stopped attacking. Okay, and let's finally just test the final scenario that can happen. And let's say that the construct delay was set to 540. So now this the deconstruct should complete before the construct even gets completed. So if we now play the game, we could see it's constructing. Now it starts deconstructing. Now before the tower even gets a chance to attack any of the NPCs, it gets removed. Okay, so everything seems to be working fine. Let's change construct delay back down to 240. Let's remove this and let's bring back this one over here. What I'm going to do now is close these modules, and then what I want to do is work on the path object. So what I want to happen is currently when an NPC gets to this center part 2, it instantly rotates round and faces towards this part. But I want to have a curvy path. So instead of instantly turning in a 90-degree angle, I want it to smoothly rotate round to this part over here. Okay, so in order to test this, I'm going to add some more points so we can test multiple different angles for our path. So I'm going to create a duplicate of part 3, and I'm going to give this bend a very sharp bend, something like this. And then I'm going to make another part, and I'm going to give this a small bend, so it's not very sharp, to something like this. And then I'm going to rename these parts so they have the correct numbers. So this is going to be number 04 and 05. And if we now test the game, we should see that these new points have been added and our path has been extended to be longer. And we should also see that when a character reaches a point, it instantly turns to face towards the next point. Okay, so let's now go back into the path object, and near the top, I'm going to create 2 new variables. The first variable is going to be called turn per stud, and this is going to describe how many radii the character can turn per stud. The next value I'm going to do is going to be called turn per step, and this is going to describe how much we can rotate every C-frame step. So over here, I'm going to say turn per step equals turn per stud multiplied by the sub-step studs. And this is going to tell us how much we can turn in radii for every C-frame that we step forward. Okay, so now instead of using look along to work out the C-frame, we're going to do it slightly differently. So let's comment out this line over here. And the first thing I want to do is I want to get the angle between this C-frame's look vector and the direction of this vector over here. So to do that, I'm going to say local angle equals C-frame.look vector. We're going to use the angle function, and we're going to pass in the direction, and we're going to use the y-axis. So it rotates, it gives us the angle around the y-axis. The next thing I want to do is I want to clamp this angle so it's not greater than this turn per step value. So over here, I'm going to say angle equals math.clamp, and I'm going to clamp the angle value between negative turn per step and positive turn per step. Okay, so now that we've worked out what we need to rotate this C-frame by, let's rotate the C-frame using this angle. So to do that, I'm going to say C-frame multiplied equal to C-frame from axis angle. We're going to rotate around the y-axis, and we're going to pass in the angle that we calculated over here. And then I'm going to move this C-frame forward once we've rotated it. So I'm going to say C-frame plus equals C-frame.look vector, and we're going to move forward based on this sub-step studs value. If we wanted to, we could pass this angle that we calculate over here directly into the clamp. So I'm going to cut and paste this into here, and now I can remove this, and now we've reduced this to a single line of code. And if we now play test the game, we should see that once we reach the point, it slowly rotates towards the next point, and then it slowly rotates towards the next point, and over here it slowly rotates to the next. Now the first thing you may notice is that these waypoints that we previously calculated are now incorrect, because we're slowly rotating, it's not entering this tower, but the raycast that we shoot from over here to over here still collides with this mesh part, causing these waypoints to be selected as enter and exit waypoints. But we're going to ignore that for now, and we're going to fix that later on. But for now, we can see that we are curving round towards the next waypoint. And if you play around with the turn per stud value, for instance, let's change this to 0.8 and play again. We will see that the NPCs turn very quickly this time. Okay, so I'm going to change this back to 0.2. So the way it's currently working is the C frame that constantly gets updated. Once it reaches a certain magnitude of the next target position, the target position is updated to point to the next part, and then the C frame will slowly rotate and go towards the next target position. But this is not how I want it to work. I want the C frame to start rotating before it reaches this target position. So I want it to look uniform, something like this. And if the turn speed is slower, we could have it start even earlier, so it can slowly rotate towards the next point, like so. So what we need to do is work out the distance from the point all the way back to where we want to start turning. So we need to get the distance of this purple line. So in order to work out the distance of the purple line, the first piece of information we need is the angle of these turns in our path. So we need to know this angle over here. Okay, so to work out the angles of each point in our path, what I'm going to do is, after we've calculated the directions, I'm going to create a new array, and I'm going to name this angles. And I'm going to give it the same length of the amount of positions we have, the amount of parts we have. And then what I'm going to do is I'm going to set the first part to have an angle of 0. So to do this, I'm going to say table.insert self.angles, and I'm going to insert the value of 0. And then I'm going to loop through the directions, and I'm going to start at the second direction. Remember, directions has one less than positions. So I'm going to say for index 2 equals the length of directions, do, and then I'm going to do a table insert, and I'm going to insert into the angles array, and I'm going to insert the angle between the previous direction and the current direction. Now, one thing you may have noticed is down here, when we use the angle function, I'm passing in the y-axis, but over here, when we use the angle function, I'm not passing in the y-axis. And the reason for this is, if we pass in the y-axis, this angle is going to be a negative or positive number, depending on which direction it rotates. But if we don't pass in the y-axis over here, then this angle value is always going to be a positive value. Okay, so now finally I want to set the angle for the last part in the path. So to do that, we're going to do it the same how we did over here. I'm just going to say table insert self.angles 0. And there we have it. We've now calculated all the angles along our path. The next information we need is the turning radius. So let's imagine that a character keeps turning right. They would keep going round and round and round in a circle. And the turning radius is the distance from the center of the circle to the end. So if a NPC turns like this, this is their turning radius. But if a NPC has a larger turning circle, something like this, then their radius will be longer. So it'll be a distance from here to here. And in order to work out their turning radius, all we need to do is say local turn radius equals sub-step studs, which is this value up here, divided by the turn per step value. Or another way to work it out would be to simply divide the value of 1 by the turn per stud value. Okay, so let's imagine that the NPC, the character, has a turning circle of something like this. And let's place this over here like so. So what we should notice is the radius, which is this value from here to here, if the angle is 90 degrees, should be the same from here to here. But if the angle is greater than 90 degrees, so let's take a look at this one over here, and let's have a little indicator showing the angle. So the angle is something like this, which is greater than 90 degrees. So if the NPC's turning circle is something like this, and we place this here, and here we can see the radius of the turning circle, we should see that the distance is now longer than the radius. And if the angle is less than 90 degrees, let's add an indicator for this one over here. So we can see that this has an angle that is less than 90 degrees. And let's create a turning circle for the NPC and place it over here and indicate the radius. We can now see that this distance is smaller than the radius. And another thing we should notice is when this angle gets closer and closer to 180 degrees, the distance will get closer and closer to infinite. So here we can see an angle that's very close to 180 degrees. That's going to cause this circle to be even further down. So this distance will get closer and closer to an infinite number as this angle gets closer and closer to 180 degrees. So if we go and take a look at the tan function, we should see that it starts at 0 and slowly goes up and up and up until it reaches an infinite value. And if we take a look at when it reaches the infinite value, we can see it reaches it roughly around 1.5. And if we look at 90 degrees, we can see that 90 degrees is equal to 1.57 radii. So that means that when tan reaches infinite, it's at 90 degrees. But we want it to reach infinite when we're at 180 degrees. So what I'm going to do is I'm going to divide x by 2. So now if we look at what the value of 180 degrees is in radii, it's pi 3.14. So we should see that it goes up and up and up. And once we reach close to infinite, it gets close to the value of 3.1. And if we kept going up, it should go all the way up to 1.4. So it will go all the way up to pi. So now we can use this function to work out the distance from here to here. So the way that's going to work is this angle that we have here in radii, we're going to place in the x position, and then it's going to give us a ratio between this distance of the turning circle to this distance over here. So what that means is if this angle is 90 degrees, it should give us a value of 1 because it has a ratio of 1 to 1. So let's go back over here and change this to 90. We can see that 90 is 157. So over here, if I find 157, it should return the value of 1. So here we can see 157 and it's equal to 0.999, which is essentially 1. Okay, so over here, before we start the loop, what I want to do is I want to calculate the magnitude this direction needs to be before we break out of this loop and move on to the next target position. So over here, I'm going to say local magnitude equals math.tan. I'm going to pass in the angle that we calculated over here, and then I'm going to divide it by 2. And then finally, I'm going to multiply it by the turn radius that we worked out over here. And now, the next thing I want to do is this magnitude has a chance to be a value of 0 if the angle is 0. And I don't want that to happen, because then this loop is going to loop forever, because this magnitude value will never be less equal to 0. So what I'm going to do is I'm going to clamp the magnitude value. I'm going to say magnitude equals math.max magnitude, and I'm going to clamp it so it doesn't go any lower than sub-step studs. And finally, instead of using sub-step studs over here, I'm going to pass in the magnitude like so. And we no longer need this C-frame look along function over here. So let's just remove this altogether. And let's now play the game and see what happens. Okay, so we should now see that unlike before, the C-frames don't go over here and turn around up here, but they turn around before we reach this point, and it turns around from inside, takes the inside lane, and then comes down here. And because this has a sharper turn, it starts even earlier and turns around and takes the inside lane. Okay, so let's now move on to fixing the waypoints. So let's go back into game, and I'm going to spawn another tower, and I'm going to spawn this slightly at a different position. So if we now play the game with this new tower, we should see that this first waypoint gets created correctly. This second one over here seems to be pretty decent. This one over here has slightly offsetted a bit, but it's not that far out. This one here has slightly offsetted as well. This one over here has an even greater offset. And this one over here has an even greater offset than before. So the reason why our waypoints are no longer correct is if we go back to the tower class, we can see that we're using the path's distance value plus the distance of the raycast to calculate which waypoint to use. But this distance value that we stored in the path is no longer correct. So over here, we can see the distances that we're calculating. These distances are no longer correct. So if we take a look over here, we are using the distance from here to here as the distance to the next waypoint, but that is no longer correct. What we want to do is we want to subtract this part of the distance where we start to turn, and then we want to add this half of the distance of this circle onto from this position of the distance. So we want to remove this part and add this new part onto the distance. Okay, so the first thing I'm going to do is I'm going to move this part of the code into this loop instead, so we get access to this magnitude value. So I'm going to comment out this for loop, and then over here, after we've calculated the magnitude, I want to do this. So to do this, we need to get the direction magnitude, but we're going to use this index value. Now remember that this index value starts at 2, but we want to start at 1. So I'm going to subtract 1 from this index, so it starts at a value of 1. So over here, I'm going to say self.distance plus equals self.directions index -1 dot magnitude. So this and this are now the exact same. And then I want to insert the distance into the distances array. So I'm going to copy and paste this down here. So now we have the exact same thing that we had here, but now we've moved it down to here. Okay, so now let's remove this purple line from the distance. And that's very simple because we've already worked out the distance of that purple line over here. So let's use this magnitude value and subtract it from the distance value. Okay, so how would we go about working out this part of the path? To work out this part of the path, the first thing we need is the whole circumference of the circle. So we need to know the distance for the entire length of the outer of the circle. So to do this, what we can do is use the diameter of the circle multiplied by pi. Now currently we know the radius of the circle. So if we multiply this radius by 2, it will give us the diameter. And then we multiply this diameter by pi, and that should give us the length of this outer circumference of the circle. So over here, where we work out the radius of the turning circle, let's now work out the circumference. So to work out the circumference, I'm going to say turning circumference equals turning radius. I'm going to multiply it by 2 to get the diameter of the circle. And then I'm going to finally multiply it by pi to get the circumference. Okay, so now that we know the circumference of this circle, we now need to know the angle of this green part that we want to take. So we want the angle from here up to here. Now, one thing you may have noticed is this angle over here that we calculated for the path is actually the same angle as it is from here to this point over here. So this angle is the same as this angle. And to demonstrate that this is the case in all cases, here we can see a path with a 90-degree angle. So this angle from this point to this point is also a 90-degree angle. And if we look over here, this point from this point is also the same as this angle over here. And because we've already calculated this angle, all we need to do is take this angle from the paths angles array and divide it into 2. So if we divide this angle into 2, it will give us this part that we're looking for. And if we divide this by 2, it will give us this part that we're looking for. And the same is true over here. If we divide this angle by 2, it will give us this part that we're looking for over here. So over here, after I've calculated the magnitude, to calculate the angle that we're looking for, all I'm going to do is say local angle equals self.angles, which is the angle of the path, and then I'm going to divide it by 2. The next thing I want to do is normalize this angle so that the angle goes from 0 up to 1. 0 being 0 degrees and 1 being 360 degrees. And an angle of 180 degrees should be a value of 0.5. And all we need to do to normalize the angle is divide it by the maximum angle it can be. So for instance, if I had an angle of 90 degrees and I divide it by 360, this is going to give us a value of 0.25. If I divide 180 by 360, this is going to give us a value of 0.5. And if I divide it by 360, this is going to give us a value of 1. So we can see we can normalize the value by simply dividing it by the maximum value. But the thing is, this is in degrees, but our angle is in radii. So 360 degrees in radii is 6.2831, which is pi times 2. So we need to divide the angle by 2 pi. So in order to normalize this angle, all I need to do is divide it by 2 pi. So over here, I'm going to say local normalized angle equals angle divided by pi times 2. Okay, and finally, all we need to do is multiply this normalized angle by the circumference. So for instance, if we're at 180 degrees, the normalized angle is going to be 0.5. So 0.5 by the circumference is going to give us half of the circumference. So over here, I'm going to say local turn magnitude equals turn circumference multiplied by normalized angle. And now all I need to do is add this turn magnitude which if we remember is this distance here, is add this onto the end of our distance. Okay, so we've subtracted this part and added this part to get the distance to this point over here. But what we need to do now is also subtract this part and add this part when we calculate towards the next point. So in order to do that, what I need to do is over here, I'm going to say self.distance is equal to self.distance negative magnitude plus turn magnitude. So that's going to do the other side of this turn. Another way we could write this line over here would be to have self.distance equals self.distance negative, and then we could place these in brackets like this, and then this would change from a positive to a negative. So this and this are the exact same. And another way we could write this is to say self.distance negative equals magnitude negative turn magnitude. So this is the same as this. So all these three lines are the exact same as one another, but I'm going to use this method down here. So I'm going to delete these two comments and have it like this. Another thing we could do is simplify these three lines of code here. So instead of calculating the angle and placing it into the angle variable and then passing it over here, I can move this directly down here like so and remove the angle variable. And then another thing I can do is remove these brackets, and that would cause this multiplier to change to a divide. So if I remove these brackets, this will change to a divide. And now what I can do is merge this divide 2 together, these two divide 2's together. So I can remove one of them and change the other one to a divide 4 to get the same result. And finally, if I wanted to, I could get rid of this normalized angle variable and just pass these values directly over here, like so. And now I can calculate the turn magnitude in a single line of code like this. Okay, so if we now play the game again, we should notice that our distances are getting calculated correctly, but the waypoints are still not 100% correct. So we can see that this one over here is 100% correct. Now we can see that these two have been shifted inwards ever so slightly. This one has been shifted even more than these ones. And this one over here has the same shift as this one over here. And this one over here is perfect. And the reason for this is if we look at the tower class, we can see that the distance value that we're now using is correct, but this result, the raycast result distance, is not correct, because when we shoot a ray from this part down and it collides with the tower's range part, which is say over here, it's using this full distance. But what we want to do is we want to subtract this part and add this part onto the ray distance, so we get the correct distance to the tower's range part. Okay, so in order to work out the correct distance, what I'm going to do inside of the path object, I'm going to store an array of offsets. So over here, below distances, I'm going to create another array, which is also going to have the length of positions. So each part is going to have a offset value, which is going to describe how much we need to offset the ray to correct it. And then, just like we did over here, I want to insert the first offset for the first part, which is going to be 0. So I'm going to say table insert self.offset, and I'm going to insert the value of 0 because this part has no offset. And then over here, just like we did for distances, I want to copy and paste this, but I want to insert into the offsets array. And I'm going to insert this value here, which is the delta between these two distances that we calculated. So let's copy and paste this into here. And that's going to tell us how much we need to offset the ray to make it correct. Okay, so what's going to happen is we're going to shoot a ray from here all the way down to this part down here, and it's going to collide with the tower's range part, and this distance is not going to be correct, so we're going to subtract the offset from this blue line's distance, which is the difference between this purple line and the green line, and that's going to give us the correct distance from here all the way down to the tower's range part. But there is a edge case we need to be careful of, and that is, what if the tower is placed in a position like this? Now what's going to happen is, let's say the tower is placed like so, then what we're going to do is we're going to shoot a ray from this part all the way down to this part, and it's going to collide over here. Then we're going to subtract the offset. Now if we're very close to this point, when we subtract the offset, this ray distance could become a negative value, which would place the waypoint on this side of the path. And on the other side, when we shoot a ray coming down from here to find this exit waypoint, that would also cause this distance to have a negative value, which gets added onto the path, which will cause the waypoint being placed over this side. So now these two waypoints have been flipped. This is a exit waypoint and this is a enter waypoint. So what we need to make sure to do is that when we subtract the offset from this ray, that we don't allow it to go lower than 0, so it doesn't go back onto this side. Okay, so let's now go back to the tower class, and over here where we use the ray distance, let's calculate the correct ray distance. So I'm going to say local ray distance equals, and I'm going to use the distance that we calculated from the ray, but I'm going to subtract the offset that we calculated over here. So I'm going to say share.path.offsets, and I'm going to use the same index that we used over here. But one thing I want to make sure is that this value doesn't go less than 0. So I'm going to say math.max, and I'm going to make sure it doesn't go below the value of 0. And then I'm going to use this ray distance variable instead of using result.distance. So I'm going to replace this over here. So I'm going to also pass that ray distance over here. Okay, so our enter waypoints should now be calculated correctly, but our exit waypoints are still using the incorrect distance. So let's just play to see if it really works. And if we go and check out, we can see the enter waypoint is correct. This exit waypoint is not correct because we haven't done the exit waypoint yet. But this enter waypoint we can see is perfectly correct now. And if we look over here, this exit waypoint is not correct, but this enter waypoint is perfectly correct. And this exit waypoint, even though it should not be correct, but because it's only a straight line, it's not got an offset, it is correct. Okay, so let's now fix the exit waypoints as well. So I'm going to copy and paste this ray distance, and I'm going to paste it down here. But a difference I want to make is, see how we're using index +1 here? We want to do the same over here, index +1. And then I want to subtract. So over here we added, over here we're going to subtract this ray distance. So subtract ray distance. And I also want to make sure I do the same for the debug function, so we can see the parts in the correct location. Okay, so if we now playtest the game, we should now see that both the enter and exit waypoints are calculated perfectly. So we can see perfect over here, perfect over here, perfect, 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 and perfect. And if I change the turn per studs to 0.8 and play it again, so now the characters should turn very quickly, and we can see that even though they have a different turn radius, the waypoints are being calculated perfectly. Okay, so we've now finished our curvy path. So I'm going to change this back to 0.2, and another thing I'm going to do is we no longer need this, so we can delete this over here. And I think this looks a little better being at the top over here. And so that these two lines match, I'm also going to set this to 0 like so. So the next thing I want to do is give each character a small offset so they don't walk in a perfect line, one behind each other. So I'm going to be using the game random object to generate the offset, but this is only a visual change, so we could get away without using this random object, but by using this random object, we cause all clients to give the characters the exact same offset. So there are two ways we can give a character an offset. We could generate another array of C-frames and have like lanes and select a random lane for each character. Or another way would be to simply have a offset C-frame. So over here where we create the C-frame, let's also create a offset. So I'm going to say cframe.new. I'm going to use the game's random object and generate a number between -3 and 3, but I'm not going to offset on the y-axis and the z-axis. And now all I need to do is multiply this C-frame with the offset to generate their C-frame. So over here I'm going to say multiplied by offset, and I'm also going to do the same down here when we create the C-frames for the C-frame array for the bulk move to. So over here, I'm going to say multiplied by offset, but we're going to be using the character instead of self over here. And if we playtest our game, we should see that some characters are offset to the left and some characters are offset to the right side. Okay, so let's now start working on the server side. So the first thing I'm going to do is just simply copy and paste this modules into server storage, and then I'm going to change the run context to server. And before we make any changes to these modules, I'm going to just double check to make sure that the client and server are still in sync. So let's play the game once again, and let's just make sure that the server and client stay in sync. So if one character dies on the server, it should also die on the client. And we should notice that both the characters on the server and client have the same amount of health when they reach the end. Okay, so the first thing I want to do is I'm going to remove these templates that we created at the beginning of the project. So I'm going to delete this class template and also the class template on the server side and also the object template that we created. So let's delete this object template and the one on the client side. Now, some of these modules are not going to be changed and are going to stay the same as they are on the client side. So instead of having two copies of the same module, what I want to do is have a shortcut system where we can link to a module from the client side over here, so we can just keep one copy of a module. So the way I'm going to do this is I'm going to create a object value, and this object value is going to link to the event module over here on the client side. So I'm going to rename this object value to event, and then I'm going to set this object value's value to point to this event module over here. So this is going to be a shortcut that points to this module over here. So now I can delete this event module from over here, and let's now change our module loader to load these object values correctly. So in order to load this object value, all we need to do is say if descendant.className equals object value, then I'm going to use the object value's name as the key for the shared table, and then I'm going to require not the object value but the object value's value property. And just to keep things consistent, even though we're not going to use any object values on the client side, I'm just going to copy and paste this into the client side's module loader as well. That way, if we ever wanted to, we could also use object values on the client side. Okay, let's close these module loaders and let's convert more of our modules into object values. So I'm going to create a object value, and then I'm going to press Ctrl-DDD to make a few duplicates. Now, This hybrid list can be an object value. So I'm going to rename one of these object values to hybrid list and point it towards hybrid list. Then I can delete hybrid list. Then linked list can also be an object value. So I'm going to rename this linked list, point towards linked list, and delete the original linked list module. And waypoint can also be an object value. So let's rename one of them to be waypoint and point this to waypoint. Now we can delete waypoint. Now bar and projectile are both going to be deleted in the future because we don't need them on the server side, but I'm going to keep them for now because our character and tower modules require these two modules. So they're just going to be here for temporary. This is a extra object value that we don't need, but I'm going to move this into data because we don't need the characters data type. We can just link to this one over here. So I'm going to rename this to characters, and then I'm going to point to the characters module over here and delete this one over here. And we can create two more object values over here. And the first one we can convert is task. So let's change this to task and point towards task over here and delete this task over here. And the next one we don't need is threads. And this one can point towards threads over here. We can delete threads. Now for path, at this current time, I'm not too sure if we can share the same path object. So I'm going to keep them separate, but later on, if I feel that we don't need two path object modules, I'm going to merge them into one. Okay, so what I want now is to have some remote events. So I'm going to create a new folder inside of replicated storage. And I'm going to name this folder events. And then inside of this folder, I'm going to create remote events. I'm going to create 4 remote events. The first remote event I'm going to call game start, then game stop, then tower despawn, and tower spawn. Okay, so let's now open the game object on the server side and the game object on the client side. I'm going to put the client side to the right. So the first thing I'm going to do is remove these commented out lines. And then I'm going to change the start and stop function on the client side to be private functions because I only want these functions to ever be called when the game start and game stop remote event are fired. So to change these to private functions, all we need to do is remove this self from the front. I'm now going to delete this start function that we call over here, and I'm going to connect the events to this start and stop function. So I'm going to say game.replicatestorage.events game start on client event, and I'm going to connect the start function. And then I'm going to do the same, but for the stop function. So I'm going to connect the game stop remote event to the stop function. And instead of using workspace get server time now, I want the server to send the time to the client. So we're going to receive the start time over here. And then we're going to use this start time for the task manager. So let's pass the start time. Okay, so now that we've connected these events, on the server side, I want to fire the event when we start the round, start the game. So over here, after we've calculated the seed value from this random value, I'm going to fire this game start remote event. So to do that, I'm going to say game.replicatestorage.events game start fire all clients. I'm going to pass in the round value, the difficulty value, the seed, and over here when we start the task manager, remember we pass in the current server time, and if we look at the task manager, when we start, this is saved in self.startTime. So we can get this value by saying share.task startTime, and that's going to get this value here, which we passed into the start function. So whatever value we passed over here, we're going to get access to it over here. And because the round, difficulty and seed value are never going to be nil when we fire this remote event, doing these 3 lines over here are kind of useless. So we can remove these 3 lines like so. And now when we call the stop function, I want to fire the stop remote event. So over here, I'm going to say game replicated storage.events game.stop file clients. And that's going to fire this event, which is going to call this stop function. And so that this client doesn't miss the game start remote event, before we start the game, I'm going to add a task wait for 5 seconds. And that should give enough time for this client to enter the game. And if I now playtest the game, we should see that the server and client are now perfectly in sync. So if we look at the characters folder, we can see that there are 6 characters here where we can only see 3. And that's because the characters are perfectly overlapped with one another. And this is because we're now using the start time, which is in sync between a server and client. And the same is true for the projectile. Because the server and client are perfectly in sync, the projectile looks like there's only a single projectile, where in fact there are 2 projectiles. But if we don't want the server and client to run perfectly in sync, all we need to do is add a value or subtract a value from the start time. So if I say negative 0.2, so it's going to be start 0.2 seconds before, that's going to cause the client to run ahead of the server. So now we should see that the client characters are slightly in front of the server's characters. Or instead of subtracting, if we add to the start time, then that's going to cause the clients to run behind the server. So now we should see that the client is half a second behind the server. But the thing is, it doesn't really matter if the client runs slightly behind or slightly ahead of the server, because the game is deterministic. So the outcome on both the server and client should end up the same, no matter if the client is behind or ahead of it. But the thing is, sometimes if I like to add prints to debug, and if I add this print on both the server and client, if we have no delta here, no difference for the start time, this print may sometimes first print on the client and print on the server second, or sometimes it might print first on the server and then print second on the client. So I like the client to always print second. So what I like to do is add a very small delay over here, like so. And that way, if we have a print on both the server and client, so that the client always prints after the server, we have this very small delay between the two. Okay, so let's now work on the character class. So I'm going to first open the character class on the server side, and then the character class on the client side, and I'm going to move the client side to the right side. So what I want to do is on the server side, I want to remove these models because they're kind of useless. They're only there for decoration and they have no purpose for the system to work. So to remove these models, there's a lot of things we can remove. First thing we can remove is the post-ticks bulk move function, because this updates the position of all the models. But if we don't have no models, we don't need to update their position. That's going to greatly improve the performance on the server side. So we can remove this as well. And because we've removed bulk move, we no longer need these arrays. So I can remove these arrays up here. And because we're not going to have any models, we don't need this characters folder. So I can remove that as well. We can also remove this index because this index is used for these arrays, but we don't have these arrays anymore. So we can remove that as well. We can also remove this index property over here. And we can also remove this part over here because we don't have them. And we can now remove the model property. We can also remove the animation because there's no model to animate. We can also remove this C-frame because we don't need to position the model at this C-frame. And we can also remove this offset, but there's a problem here. If we remove this offset, it's going to cause the server and client to go out of sync Now, why is that the case? Because on the client side, we're using the random object to generate a new number, and that's going to cause this random object to move to the next random number, where on the client server side, we're not using this random object, so it's going to stay one number behind. So this random object is going to go out of sync between the server and client. So what we need to do is we need to keep this random over here, but we're just going to discard the value that we get from it. So we can just move this to the top, and I can say share.game next integer, and we don't even need to pass these numbers here. We could just pass 0 and 0, and it will have the same effect. So now it's safe to remove the offset, because when the server creates a new character, it's going to move on to the next number on the random object, and the client is also going to move on to the next number on the random object. Okay, so now we can remove this part of the destroy function, because this was for the bulk move arrays, which we no longer have. And we also can remove this because we no longer have a model to destroy. And because we no longer have a model, we no longer need a bar. So over here, I'm going to remove this part. And instead of having an else here, I'm just going to change this to below or equal to 0, then we're going to destroy. And when we increment the speed of the character, there's no need to adjust the speed of the animation, so we can delete this as well. And we no longer store the C frame for the character. So what we can do is I can just pass this directly over here and remove this over here. And while I was here, I just noticed a small problem. If we remember, for our waypoints, we added the character removed event, and if a character is destroyed within this event, I don't want this function to continue. So just like we did here, if the character has been destroyed after we call the remove character function, I'm going to return and exit out of this step function. And I also want to do the same on the client side. So over here, after we call the remove character function, if the character has been destroyed, I want to return and exit out of this step function. Okay, so we've now finished the character class on the server side, but this is now going to cause some problems, because if we remember, inside of tower functions, when we spawn the projectile, we pass the character's model torso as where the projectile needs to go to. But on the server side, we don't actually need projectiles anymore. So what we can do is just delete these projectiles altogether. So I'm going to delete this projectile, and this projectile over here. And now that we're no longer using this projectile class, we can just delete the projectile class altogether. And we can also see that we use the character's model to spawn this explosion, but we don't need an explosion on the server side. So we can remove this entire part on the server side. And if we now playtest the game, we should notice that we don't get any errors in the output window. We should also notice that there's only one characters folders now, and there's only the client-sided characters, no server-sided characters. But we still have the server-sided towers. So we can see there's only 2 towers, but we have 4 towers because 2 of them are from the server side and 2 of them are the client side. Okay, so let's now work on the towers class. So I'm going to open the tower on the server side and on the client side, and I'm going to move the client-sided tower to the right side of the screen. So currently, when we create a new tower, we clone the model from the towers folder, which is over here. And then we pivot this model based on this C-frame, and we parent it to workspace. And then we use this model in order to calculate the enter and exit waypoints. But the thing is, I don't want the towers to have models on the server side, only the client side. So instead of cloning these models, what I want to do is I want to have another model and pivot it to a C-frame in order to do the raycast. and then use that model over and over again to calculate the enter and exit waypoints. Now we could use these models, but if we make any changes to these models, it's going to replicate to the client, causing there to be more network data usage. So instead of using these towers, what I'm going to do is I'm going to create a clone of all these towers and use the clones to calculate the enter and exit waypoints. So at the top of this class, I'm going to clone the towers folder. So I'm going to say local towers equals game.replicated storage towers and clone. So every model inside of this towers folder is going to be cloned into this cloned folder. Okay, so I no longer need this folder to be created anymore because we're not going to create any models to place within a folder. So I can delete this. And over here, when we get the model, instead of getting the model from this folder, I'm going to get the model from the cloned folder. So I'm going to replace this with this. And instead of cloning this model into this model property, I no longer want to do that. So I'm going to remove this. And instead of pivoting this, which is now equal to nil, I want to pivot this model. So I'm going to cut and paste this over here and replace this with model. So we get the model from the cloned folder and we pivot it at the C frame that we pass in. And finally, we need to parent it, but we're not going to parent it to workspace. So I'm just going to comment this out for now. So the reason why I don't want to parent this model into workspace is because if we parent it into workspace, it's going to replicate to all clients. So all the parts within the model and the properties are going to replicate to all the clients on the game. So what I'm going to do is I'm going to use a world model and place the model within the world model. And the reason we're going to use a world model is because we can use the world model to raycast to find out the enter and exit waypoints. So over here, I'm going to say local world model equals instance.new world model. And for this world model to work, we must parent it. But I'm not going to parent it into workspace because I don't want it to replicate to the clients. I'm going to parent it into server storage, and that way it should not replicate. But if we want to, we can pass this as a second parameter to instance.new, so it will parent it directly for us. And now that we have a world model, I want to parent this model into the world model. So I'm going to say model.parent equals world model. But the thing is, when we create a new tower after this tower, it's going to search for the model inside of the towers folder that we cloned, and it's not going to be able to find it. So what we need to do is once we've finished raycasting on this model, we need to place it back into the towers folder so it can be used again when we call the new function in the future. So I'm going to say model.parent, and over here, after I've worked out the exit and enter waypoints, I'm going to set this parent back to this folder so it can be used again. And now, instead of raycasting from the workspace, we want to raycast with the world model. So I'm going to replace workspace with world model, and the same over here. So now we're raycasting with only items that are inside of this world model. Okay, so if we now scroll down, we can see that here we're working out how many ticks it's going to take to build this tower. And here we're making a check to see if this tick is less or equal to 0. But this is never going to be the case on the server side because we're not using remote events over here. Only the client can receive this event late, causing it to cause this error. So we could just remove this entire line. We also don't need a bar anymore because we no longer have a model. So let's remove the bar. And we also don't need this construct connection, which happens every tick, because if we look down to the construct tick function, it's this function here, and all this function does is increment the bar, but we don't have a bar no more, so we can comment out this function. And we also don't need this deconstruct tick function anymore because this just decreases the bar. So we can comment out this function as well. And if we really wanted to, we don't actually need this variable because this variable is going to be the same as this value. So I can just remove this altogether as well. And over here, when it asks for this value, we can just pass the value in directly like so. Over here, when we destroy, we no longer need to work out this value here because it's going to be the same as this value. So we can just comment out this value altogether. This error, this warning can never happen. So we can delete this as well. And this entire part here is not needed because we don't have a bar to recycle or create a new one. So we could comment out all this over here. And over here, when we create the delay, instead of using this value, just like we did over here when creating this delay, we can pass the value in directly. So we can just copy and paste this over here. And this over here, this is for this function here that we removed. We no longer need this, so I can also comment out this as well. Okay, let's continue to scroll down. Everything inside of add character and remove character is going to stay the same. And inside of construct, we still need to set the task back to nil because remember over here we set it, and then when we deconstruct we check and remove it if we still find it. So this needs to stay, but this over here that we used to make over here is no longer created and we no longer have a bar. So we can remove all this part from the construct part. And if we continue to scroll down, we need all this to stay. But over here, when we deconstruct, this can stay here because we might need to cancel it if they're constructing. And we don't need this anymore because we're no longer creating it. So we can comment out this. And we no longer have a bar, so we can comment out this as well. And we no longer have a model, so we can get rid of this as well. And one other thing I forgot to do is if we go back up, over here when we create the filter for the raycast perims, here we're using self.model, but this model value no longer exists. We want to use this model now, so let's replace this self.model with model. Okay, so I've just tested and everything seems to be working fine. So I now feel confident in deleting these lines of code that we've commented out. So we should be able to safely remove all this that we commented out just before. We can remove this, we can remove this, remove this. Now, because the server side is no longer visible, it's kind of hard to tell if the server and client are in sync. So what I'm going to do is I'm going to go back to the character class, and over here when we destroy a character, I'm going to say warn and say destroy character. And I'm going to do the same on the client side. So over here, but I'm going to change the warn to a print so we can easily tell which one is the server side and which one is the client side. Another thing we can do now is delete the bar class on the server side because we're no longer creating a bar for the towers. So we can safely remove that. And if we now test our game, we should hopefully see that everything works correctly. We should not get any errors. And every time a character dies, the server and client should both print to the output. Here we can see both the server and client printed. Okay, so let me now close all these modules that we've opened. And I'm going to create a new object for the client side, and this is going to handle input. So I'm going to create a new module script, and I'm going to name this module script input, and I'm going to rename this to self. And I'm also going to create another object on the client side. So I'm going to duplicate input, and I'm going to rename one of them to be called tower handler. So the way it's going to work is the tower handler is going to use the input object to tell the server where it wants to spawn a tower. So the first thing I'm going to do inside of the input object is I'm going to get the user input service. So at the top of the script, I'm going to say local user input service equals game get service user input service. And then remember that our module loader calls the start function. So I want to use this start function to know when the game has started. So over here, I'm going to say function self.start and this function is going to be called by the module loader. And then what I want to do is create a new function, a private function, which cannot be accessed outside of this module. And it's going to be called input begin. And then I'm going to connect this function to the input begin event from this user input service. So inside of the start function, I'm going to say use input service, input begin, connect. I'm going to pass this function that we created down here. This is going to receive the input object and whether or not this input was processed by something else. So what I want to do now is I want to have an event for any key that's pressed that we want to know when it's pressed. So at the top, I'm going to create a new table called events. And then I'm going to create a new function. Now this is going to be a global function inside of the input object, so anyone can access it. So I'm going to say function self get key event, and we're going to take in a key code, and we're going to use this key code to find the event inside of this table. So I'm going to say local event equals events, and I'm going to use the key code as a key to find the event. Now if this event does not exist, we need to create a event. So I'm going to say if event equals nil, then I'm going to create a new event using this event class. So I'm going to say event equals shared event.new. And then I'm going to add this event to the events table. So I'm going to say events key code equals event. And then finally, I'm going to return this event back to whoever requested the event for this key code. Okay, so now that we have a way to create events, let's now fire these events when the input begin function is called from the user input service. So the first thing I want to do is check to make sure that this event is not processed somewhere else. So I'm going to say if processed equals true, then I'm just going to return and not continue the function. And then I'm going to check the input to see what the user input type is. And if it's a keyboard, so I'm going to say if input user input type equals keyboard, then I'm going to use the key code from this input object to find the event inside of this table. So I'm going to say local event equals events input.keycode. And then if this event exists, then I'm going to say if event, then I'm going to fire the event. And I'm also going to pass the input object to this event, so anyone who's connected to it can receive this input object. Okay, so let's now put this input class object to the side, and inside of our tower handler, let's make a dictionary of keys. So what I'm going to do is I'm going to say local tower keys equals, and I'm going to set key code 1, 2, 3, and 4 for tower 1, tower 2, tower 3, and finally tower 4. Okay, so now I also want the module loader to call the start function inside of the tower handler. So I'm going to copy and paste this over here. So we have a start function, and I also want a private function called spawn tower. So I'm going to create a new function called spawn tower, and it's going to receive self and the input object. And then I'm going to use the get key event to connect to these events. So over here, I'm going to loop through these tower keys. So I'm going to say for key code tower in tower keys do. Then I'm going to use the shared input object, this object over here. Then I'm going to use the get key event, this function over here. I'm going to pass the key code, which we saved inside the keys, into this function. And then I'm going to connect to this function event that's returned. And I'm going to pass the spawn tower function. And for the first parameter, I'm just going to pass in self. So we receive self over here as well. And over here, we'll receive the input because we passed the input over here. Okay, so now I should be able to use this input object's key code to work out which tower I want to spawn. So over here, I'm going to say print, and I'm going to print the tower keys using the input code to get the key, and it's going to return one of these strings. So let's now play the game. And if I press key 1, we can see it prints tower 1. If I press key 2, 3, and 4, if I press key 5, 6, 7, or any other key, nothing prints. Okay, so now that we know which tower we want to spawn, now we need to work out where we want to spawn it. So we need to work out the C-frame that we want to place this tower. Now to do this, we're going to use a raycast and raycast in the direction of the mouse, but we could put the raycast logic inside of this function, but I'm going to place it inside of the input object so that we can reuse the raycast function multiple times in different scenarios. So over here, I'm going to create a public function and I'm going to name it raycast. And then I'm going to get the mouse location. So I'm going to say local mouse location equals user input service. I'm going to use the get mouse location function. And then I'm going to calculate a ray. So I'm going to say local ray equals workspace, current camera, viewport to ray. I'm going to pass in the mouse locations X and Y coordinates. And then I'm going to use this ray to raycast. So I'm going to say workspace, raycast, and I'm going to use the ray's origin location and the ray's direction. But I'm going to multiply this by 1,000. And I'm also going to return the ray object back to whoever called this function if they ever need to use this object. Okay, so let's now use this raycast function over here when we want to spawn a tower. So first thing I'm going to do is let's remove this print. I'm just going to comment it out for now. And the first thing I want to do is call this raycast function. So I'm going to say local raycast ray equals shared.input raycast. Remember, it returns two values. It returns both the raycast results and it returns the ray. The next thing I'm going to do is check to make sure that the ray collided with something. So if this raycast result is equal to 0, I'm just going to return and do nothing. But if the ray does collide with something, then I'm going to use these two values to calculate a C-frame. So I'm going to say local C-frame equals C-frame from matrix. And then I'm going to use the raycast results position to be the position of the C-frame. And then for the right vector, I'm going to use the ray direction, which is the direction that we shot the ray in from the mouse. So ray direction, which is the direction of the mouse. And then I'm going to cross it with the ray results normal. That's going to give us the right vector. And then for the up vector, I'm going to use the normal of the raycast results. And then for the Z vector, I'm just going to keep it empty, 0, and Roblox is going to cross these two values for us together to calculate the C-frame. And finally, I want to fire this tower spawn event. So let's now say game.replicated storage events tower spawn fire server, and just like we did over here to get the tower name, I'm going to pass the tower name that we want to spawn, and I'm going to pass the C-frame where we want to spawn it. And now I can delete this print, and we've now finished our spawn tower function. Okay, so now that we're sending this tower spawn event, the server needs to receive this event. So inside of objects, I'm going to create a new object, and I'm going to name this object player events. And this is where we're going to receive player events. And I'm going to rename this to self. So inside of our player events object, I'm going to connect to the tower spawn event. So first thing I'm going to need is to add the start function from the module loader. So let's create this function. And then I'm going to create a private function called spawn tower. And this is going to receive the player that wants to spawn the tower name that they want to spawn, and the C-frame that they want to spawn this tower at. And then inside of this start function, I'm going to connect to the tower spawn event. So over here, I'm going to say game.replicatedStorage.events.towerspawn.onServerEvent connect, and I'm going to pass in the function that we created down here. So the first thing I'm going to do inside of this function is you want to check to make sure if the player is allowed to spawn a tower. So if you have a inventory system, or if you have like coins and you want to check to make sure the player has enough coins to spawn this tower, you would do that all over here, but I'm not going to do that. So I'm just going to place a comment saying to do, make sure player is allowed to place tower. And this is something for you guys to do in your own time. And now what we want to do is, just like we did inside of game, we want to call the tower new function, pass in the tower name and the C frame. So over here, I'm going to say share.tower.new. I'm going to pass in the tower that they want to spawn and the C frame that they want to spawn it at. And another thing I'm going to do is now I'm going to remove this from game because I no longer want to spawn the towers as soon as the game starts. And I'm also going to open game on the client side and remove these towers from the client side as well. And if we now playtest the game, and if I press key 1, we can see the enter and exit waypoint. And we should see that these characters don't get destroyed on the client side, but they do get destroyed on the server side. Okay, so if we now open the tower class on the server side and on the client side and place the client side to the right, let's now fix this so that the towers replicate to the client. Okay, so this is going to work a lot like how we did the game object. So the first thing I'm going to do is I'm going to change this new function and this destroy function to private functions, so they're not part of the class object. So I'm going to change this by removing class to be called new like this. And I'm going to remove class from here to make it like this. And then I'm going to use the start function from the module loader. So over here, I'm going to say class.start to call the start function when the modules after they have initialized. And then I'm going to connect these two events to the new function and destroy function. So over here, I'm going to say game replicated storage.events tower spawn. And when this event is called, we're going to call the new function over here. And the same for the destroy function. I'm going to connect the tower despawn event to the destroy function. Okay, so now what I want to do is when we call the new function on the server side, I want to call this tower spawn remote event and pass this name and C frame to this new function. So down here, I'm going to say game.replicatestorage.events tower spawn via all clients. Now the first value we need to pass is the name. We already know the name from over here, so I can just pass this name value into here. Then we need to know the C frame. We could just pass this C frame value directly to the client. Now another thing I want to pass to the client is this construct tick value. So this is going to tell the client which tick they need to construct this tower on. So down here we can see we work out construct tick, but this is incorrect. We want to use the one that the server tells us now. So we can remove this over here and use this one that the server tells us. So now what I want to do is I could pass this construct tick value over here, but I'm just going to do it directly by copying and pasting this part over here. And now I can delete this over here. So it should look something like this. Now currently we have some errors inside of the destroy function, but we're going to ignore them for now because we're not going to destroy towers just yet. But we're going to fix this problem later on in the video. And if we now play test the game, and if I press key 1, we should see that the tower spawns on the server and the client now. And we should see that the prints are back in sync again. So server, client, server, client. Now, one thing you may have noticed is when you spawn a tower and try to spawn another one next to it, it spawns floating above. And that's because our raycast is colliding with this range part. So if I keep spawning more towers, we can see it goes up and up and up. So to solve this problem, inside of our tower class on the client side, not the server side, after we've worked out the enter and exit waypoints, I'm going to set the range parts can query value to false. Because if we look at the tower and the range part, we can see it has a can query set to true. So I'm going to set that to false. So over here, I'm going to say self.model.range can query equals false. And if we now play test the game again, we should see that I can place a tower here and place a tower right next to it, and it doesn't go above. There is also another edge case where we can get errors. If I place a tower over here, we can see it creates a enter waypoint, then it creates a exit waypoint, then it creates another enter waypoint at the exact same waypoint, and then it creates a exit waypoint over here. And if we look at the output, when a character passes this enter and exit waypoint over here, it causes an error. And that is because the enter is called first and then the exit is called second. And that causes the add character function to be fired twice in a row because it adds the character when it reaches here, then it adds the character when it reaches here again, and then it removes it, and then it's going to remove it a second time over here. And if we click on this error, we can see that the error is happening from this insert back function inside of the hybrid list, because the hybrid list can only store one value once. We cannot store the same value twice. This is a limitation of hybrid lists, and it's going to assert over here, which is telling us that we're trying to save the same value twice. And then if we go over here, we can see that the tower class on line 83 for replicated storage. So if we click over here, we can see it takes us to this insert back over here, which is where we're getting the error. And if we scroll up, we can see we get another one over here for tower, both on the client side. If we scroll up, we can see we get one for the server side as well, which is this one over here. And if we scroll up again, we should get another one for the server side over here. So we can see that both the client and server are both receiving the exact same errors. And this is good because it's telling us that both the server and client are still working in sync. So if we scroll up to the new function, we should see that over here, when we create the enter and exit waypoints, we check if the enter waypoint is not equal to the exit waypoint before we insert them. But we're not doing this check when we find the enter waypoint over here to make sure that this enter waypoint is not equal to the previous exit waypoint. And that's where we're getting the problem. When we find this enter waypoint, because we're not checking the previous exit waypoint to see if they're the same, we're still creating a enter and exit waypoint on top of one another, which is causing the character add function to be called twice in a row. Now, if we continue to use this enter waypoint variable and the exit waypoint variable, this code is going to get very complex. So what I'm going to do is I'm going to get rid of this enter waypoint and exit waypoint variables, and I'm going to work with this waypoint indices array directly to calculate if we should create the enter or exit waypoints. So what I'm going to do is, instead of creating this enter waypoint variable over here, I'm going to delete this. And now what we need to know is if we should create search for the enter waypoint. Now previously we were using this variable, and if it was equal to nil, we would search for the enter waypoint. But now what I'm going to do is I'm going to check if this waypoint indices is either odd or even. And if it's even, we're going to search for the enter waypoint. But if it's odd, we're not going to search for the enter waypoint. And in order to work out if this int array is either odd or even, what we're going to do is we're going to use the modulus operator. So if we open the command bar and I type in print, and I type in any number, for instance 1, and I do it with a modulus 2, and we press enter, we can see it prints 1. So the value of 1 is odd. Then if I change this 1 to a 2 and press enter, we can see it prints 0. 0 means it's even. If I change this to a 3, press enter, we can see it says 1, which means it's odd. And then 4 should be 0, which means it's even. So if we do modulus 2, it will return either 0 or 1, 0 meaning it's even, 1 meaning it's odd. Okay, so now what I'm going to do is over here, I'm going to replace this if check, and I'm going to say if waypoint indices, and I'm going to use a hash here, so we get the length of this array, and use modulus 2 is equal to 0, which means it's even, then we're going to search for the enter waypoint. Okay, so now that we no longer have the enter waypoint variable that we create up here, I'm just going to save it locally within this if check. So I'm going to say local, and I'm just going to name it waypoint. And then I'm going to check if this waypoint's index is equal to the last index that we added into this waypoints array. So to do this, I'm going to say if waypoint.index is equal to waypoint indices, and I'm going to get the last item inside of the array. Then what we want to do is I want to remove this last item if they're the same. So I'm going to say table remove waypoint indices. That's going to remove the last item in this array. And then I'm going to say else, if the indexes are not the same, that means they're not overlapping, then what I'm going to do is I'm going to insert this waypoints index into the indices array. So over here, I'm going to say table insert waypoint indices, and I'm going to insert this waypoints index. Okay, so now over here, before we blindly shoot an array backwards, because we're using the waypoint indices array now, we can do the same that we did over here to check if it's a good time to shoot an array backwards or if we don't need to. So just like we did over here, instead of checking if the indices length is even, we're going to check if it's odd, but at the same time, we're going to check if there are any items within the array. And if there are no items, we're still going to check for a exit waypoint so that we can find this enter waypoint that could be at the start of the path. So over here, I'm going to say if waypoint indices modulus 2 is equal to 1, unlike over here where we check for 0. So if it's 1, that means it's odd. And then I'm also going to say if indices is equal to a 0 length. So either if there's 0 length or if it's odd, we're going to do this part. So let's add a tab and place a end over here. So over here, if we find a exit waypoint and we currently have no waypoints, so let's copy and paste this into here. So if there is a exit waypoint, but we currently have no enter waypoint, there are currently no waypoints before this waypoint, this means that the tower is overlapping the first part in this part over here. The range part is overlapping this part. So we want to create a waypoint at the start of the path. Now, a way we can do this is to simply just insert the index of 1. So I can say table.insert waypoint indices, and I'm just going to insert the value of 1, meaning the first waypoint in the path. And then all we want to do is the same thing that we did over here, we want to do over here. So instead of saying local exit waypoint, I'm going to name it waypoint like we did up here. And then I'm going to copy and paste this part of the code over here. So if the waypoints index is equal to the last waypoint we added to the waypoint indices, we're just going to remove that last waypoint. But if it's not equal to the last waypoint, we're going to insert this new waypoint into the waypoint indices. And now we can get rid of this part of the code. Okay, so let's now do the same over here. So if we get to the end of all the directions and we are in a odd state, so I'm going to say if waypoint indices modulus 2 is equal to 1, that means it's in an odd state. That means we have a enter waypoint, but we don't have a exit waypoint. So now we want to create our exit waypoint. I'm going to call this waypoint like we did above. And then all I'm going to do is I'm going to delete this part, and then I'm going to copy this part and paste it over here. Okay, so now we've done the server side, let's copy this code to the client side so it works the same as the server side. So I'm going to scroll up to the top, and over here where we do this, what I'm going to do is I'm going to delete all of this, and I'm going to copy and paste the server side code over here. But one change we need to make is over here we're using world model, where we don't have the world model on the client side. We want to change this to workspace and workspace. So now both the server and client should work the exact same. And before we test to see our code working, what I'm going to do is over here, I'm going to print the waypoint indices array. So I'm going to say print waypoint indices, and now I'm going to play the game. And if I now spawn a tower over here, we should see that even though the debug parts are being created over here, we should only have one index enter waypoint and one exit waypoint, and we're no longer seeing an error. And that is because even though we're creating the debug parts for this enter and exit waypoint, we can see we're creating the debug parts. Because we're removing them, they no longer end up within the array. And if we just create some other random towers, so if we create one over here, we can see it creates a index of 1, even though it's overlapping the start part, and a exit index of 9. And we can create one over here. We can see it creates 2 indexes. We can create one over here, and it should set the last item. And if we create one right over here, we see it's an empty array. If we make it slightly closer, we can see that even though this waypoint was selected, because the enter and exit are the same, we can see it returns a empty array for waypoints. And if we create one over here, we should see it has 4 indices. Once where it enters over here, then a exit, which is 23, then a enter, which is 28, and then finally a exit over here, which is 36. Okay, so I no longer want to see the waypoint indices array, so I'm going to remove this. Okay, so let's now start working towards fixing this self problem we have over here for the destroy function. So first, what I want to do is I want to update the client side's input object so that we can select towers and then press the delete key to tell the server using the tower despawn event to tell them to destroy a tower. Okay, so I'm going to place this input object to the right side, and what I want to do is when we initialize this input object, I want to create a event object, and we're going to fire this event every time the client clicks or taps on the screen of their mobile device. So first thing I need to do is create the initialize function. So I'm going to say function self.initialize, and that's going to be called when this module loader loads up the modules. And then over here, I'm going to use the event class to create a new event. I'm going to name this event Ray. And now inside the input begin function, if it's not a keyboard event, I'm going to check if it's a mouse event. So I'm going to say else if input user type equals mouse button 1, then, and then I'm going to use this raycast function to shoot a ray. So I'm going to say local raycast ray equals self.raycast. So we're going to get the raycast result and the ray. Then I'm going to check this raycast result if it exists. If it does exist, I'm going to fire this ray event. So I'm going to say if raycast result is not equal to nil, then self.ray fire. I'm going to pass the raycast results and the ray to this event. And if we want to add some rudimentary mobile support, I'm going to create another function called touch tap in world. And then over here where we connect input begin, I'm also going to connect this touch tap in world function. So I'm going to say use input service touch tapping world, connect touch tapping world. And in this function, we're going to do pretty much the same with what we did over here. First, I'm going to check if processed is equal to true, then return if it is. Then I'm going to do a raycast. Then I'm going to check if the raycast has a result, and if it does, I'm going to fire the event and pass the result and ray to this event. Okay, so now on the tower handler, I'm going to connect to this ray event. So the way I'm going to do this is first I'm going to create a private function, and I'm going to name this function input ray. And this function is going to receive self, the result, and the ray, which was passed over here and here. So let's now connect this input ray function. So I'm going to say share.input ray connect. I'm going to connect this function, and I'm going to pass the self parameter so that we'll receive it over here. And then I also want to connect the delete key, just like we did over here. So first let's create a function, and I'm going to call this function despawn tower, and it's going to work just like spawn tower. We're going to receive self and the input object, and then over here I'm going to say share.input get key event. I'm going to pass in the delete key, and I'm going to connect to this event, and I'm going to connect the despawn tower function. I'm going to pass in self, so we'll receive self over here. Okay, so when this raycast event is fired, what I want to do is use this raycast result to find out which model we clicked on. So to do this, I'm going to say local model equals raycast result.instance find first ancestor of class, and I'm going to search for a model class. And so that we can see that this is working, I'm going to say print model and play the game. And if we click on the base plate, we can see it prints nil because the base plate is not inside of a model. If I press the 1 key to spawn a tower and then click on the tower, we can see it prints tower 1 because this is the tower 1 model. If I press key 2 and click on this tower, we can see it says tower 2. Okay, so now that we have this model of the tower, we need a way to use this model to get the tower object. And the way I'm going to do this is inside of this tower class, I'm going to store a collection. So I'm going to close input, I'm going to open the tower class on the client side, and inside of this class object, I'm going to create a new table, and I'm going to name it collection. And then when we create a tower at the bottom, I'm going to insert this tower into this collection, and I'm going to use the tower's model as the key and save itself as the value. So now over here, we can use this model to access this table object using the model. Now, so we don't get a memory leak, when we deconstruct this tower, I want to remove it from the collection. So I'm going to copy, and I'm going to go down to deconstruct. And what I want to do is, I guess we can do this at the top. I'm going to say class collection, I'm going to use the model as the key, and I'm going to set this back to nil so we don't get a memory leak. Okay, so now inside of the tower handler, I'm going to use this model to access the tower object. So over here, I'm going to say local tower equals share.tower.collection, and then I'm going to pass the model as a key to get the self object. And because this model may not be a tower, then this tower object may be nil. So over here, I'm going to check to make sure that this tower object is not nil. So I'm going to say if tower equals nil, then return and do nothing. And for now, I'm just going to print the tower. So if I press key number 1, and if I click on this tower, we can see it prints a table, which is the tower object. We can see it has a action delay, bar. We can see the bar object within it, and we can see the characters and such and such. So here we can see that we was correctly able to find the tower object. And if we clicked on the base plate, we can see it prints nothing because tower is equal to nil. Okay, so now that we have this tower object, which is a table, we need to somehow tell the server which tower we want to destroy. Now we can't use this model to reference the tower because this model only exists on the client side and not the server side. So if we sent this model to the server would see this model as nil. And if we sent this tower table to the server, it would be a completely different table to the server's tower object. So we can't send the tower table to the server as well. So what we're going to need to do is use a ID system so we can tell the server which tower ID to use to destroy. So to create our ID system, I'm going to close these modules and I'm going to open the game object on the server and on the client and place the client side on the right side. And now when we initialize the game object, I'm going to create a new value called self.towerCounter equals 0. And I'm going to do the same on the client side. So I'm going to copy and paste this over here. And now that we have a tower counter, I'm going to open the tower class on the server side and the tower class on the client side and place the client side to the right. And what I want to do is I also want to have a collection on the server side, just like we do on the client side. So I'm going to copy and paste this over here. And what I want to do next is I want to increment this tower counter by 1 when we create a new tower. So at the top of this new function, I'm going to say share.game tower counter plus equals 1. And I want to do the same on the client side. So I'm going to copy and paste this to the client side like so. And then I'm going to use this tower counter as the ID for this tower. So over here, when we create self, I'm going to say self.id equals shared.game tower counter. So whatever value this is equal to is going to be the ID. And then I'm going to do the same on the client side. So I'm going to copy and paste this over here. And now when we add the tower to the collection using the model, but we don't add it over here on the server side, I'm going to add it to the collection using the ID as a key as well. So I'm going to say self.collection self.id equals self, and I'm going to copy and paste this over here. So now we have two ways to access the tower on the client side using either the ID number or by using the model number, the model. But on the server side, we only have one way of accessing the tower object, and that is only by using the ID number. And also, so we make sure we don't get a memory leak, we need to make sure we set this back to nil. So let's scroll down to deconstruct on both the server and client. So here we can see we deconstructing and we set in the model equals nil, but we also want to do the same for the ID equals nil. And we also want to do the same now on the server side for the ID equals nil. Okay, so now that our towers have ID numbers, let's make it so that our tower handler can select and deselect towers. And in order to indicate that a tower is selected, I'm going to make the range part either transparent or not transparent. So I'm going to scroll up, and over here where we set the range part can query to false, I'm also going to make the range part transparent. So I'm going to say self.model.range.transparency equals 1. And now I'm going to close all these objects and open the tower handler. And at the top of this object, I'm going to create a private variable called selected tower equals nil. And now instead of just printing the tower, when we get the tower object, I'm going to set the selected tower as this tower object over here. So I'm going to say selected tower equals tower. And then I'm going to set the range part transparency to 0. So I'm going to say selected tower.model.range.transparency equals 0. So when we create the tower, we set it to 1. And when we select the tower, we set it to 0. But the thing is, there's not really a point having a tower variable here. We could just use the selected tower directly. So what I'm going to do is I'm going to replace this with this and do the check over here. And now I can remove this. And now this works the exact same way. But one thing I need to add is if before we select this new tower, if we have a previously selected tower, I want to set the transparency back to 1 for that previous selected tower. So over here, I'm going to say if selected tower, then I'm going to set the selected tower's transparency back to 1. And if I now play the game and see if this works, so I'm going to spawn 1, 2, 3, 4 towers. And if I click on this tower over here, we see the range part. If I click away, the range part hides again. If I select on this one over here, select on this one over here, now we can see which tower I've selected by seeing which one has the ranged part. So now when we press the delete key, which calls the despawn tower function, what I'm going to do is check if we have a selected tower. So I'm going to say if selected tower equals nil, then return. But if we do have a selected tower, then I'm going to send this selected tower's ID to the server. So I'm going to say game.replicate storage events tower despawn selected tower ID. Let's now go back to this server-side player events object. And over here, let's now connect to the despawn event. So I'm going to first create a private function, and I'm going to call this function despawn tower. And we're going to receive the player who's told us to despawn this tower and the ID of the tower. Then I'm going to connect this function to the event. So I'm going to say events.tower_despawn on server event connect despawn tower. And then I'm going to use this ID, and with the collection inside of the tower, remember we have a collection here, which we store the ID number. So over here, I'm going to say local tower equals share.tower collection. I'm going to pass in the ID that the client told us. Now, if this ID number does not exist inside of the collection, this tower value is going to be equal to nil. So I'm going to say if tower equals nil, then return and do nothing. But if the tower does exist, I'm going to call the destroy function over here. So I'm going to say tower destroy. And now let's go back to the destroy function. And what I want to do is tell the client to destroy their tower. So over here, I'm going to say game.replicate storage events tower despawn fire all clients. I'm going to tell them the ID of the tower that we want to destroy. And then I'm going to tell them which this value over here, the deconstruct tick over here. So we don't actually need this variable anymore because we're just passing it in directly over here like so. So we can delete this like so. And now let's go to the tower class on the client side and move it to the right. So now this destroy function should receive two values, the ID and the deconstruct tick. So over here, I'm going to say ID, and I'm also going to receive deconstruct tick. And I'm going to now delete this because this is not the correct deconstruct tick. And now we need a way to get self using this ID number. And if we remember, we store it within the collection. So I can say local self equals class.collection and pass this ID number that the server told us into the collection to extract self. So if we now play the game, and what I should be able to do is press key 1, key 2, and if I select this tower, press delete, we can see it starts deconstructing, and once it deconstructs, it gets destroyed. If I select this tower over here, now we can see we got an error. Here we can see it says range is not a valid member of model. So over here, when we select another tower, because when we destroy this tower, this selected tower is now destroyed. So the ranged part within this selected tower no longer exists. So in order to solve this problem, I'm going to do the same thing that we did inside of the character class. If you remember, we have a destroyed value and we set it to false. And then when we destroy the character, we set it to true. So I'm going to copy this, and inside of the client side tower class at the top, I'm going to say self.destroyed equals false. And then I'm going to scroll down to the deconstruct function. And over here, I'm going to say destroyed equals true. And if we wanted to, we could also add this destroyed value on the server side. So let's just do it so the server and client stay reasonably the same. So I'm going to say destroyed equals false. And when we deconstruct, I'm going to set destroyed equals true. Over here, when we have the tower handler object, before we set the range part transparency back to 1, I'm also going to check to make sure that the tower is not destroyed. So I'm going to say and selected tower dot destroyed equals false. So if we have a selected tower and that selected tower is not destroyed, then we're going to set the transparency back to 1. And I'm also going to do the same over here. I'm going to say if select tower equals nil, or selected tower dot destroyed is equal to true, or we could just leave it without the equals. Then I'm going to return and do nothing. But if the tower, there is a selected tower and that tower is not destroyed, then we're going to send it to the server. But the problem is the way we've done this still has some problems. If we go back to player event, here we can see we destroyed a tower if we find the ID. So what would happen if a client told the server to destroy the same tower multiple times before this destroy value was set to true? Well, what's going to happen is this destroy function over here is going to get called multiple times, which means that this remote event is going to be called multiple times, which means that this destroy function over here is going to get called multiple times. And this task delay is going to be added multiple times, causing this deconstruct function to be called multiple times. It's going to cause a lot of problems by allowing this destroy function to be called multiple times by the client. So what we want to do is we want to prevent this destroy function being called more than once for the towers. So instead of only having a destroyed variable for towers, I'm going to create another variable property called deconstructed equals false. So now this is going to tell us if the tower was destroyed, and this is going to tell us if the tower was deconstructed. I also want to do the same on the client side. So I'm going to copy and paste this over here like so. And now when we destroy the tower, I'm going to set destroyed to true. So over here, I'm going to say, first I'm going to check to see if destroyed is already true. So I'm going to say if self-destroyed equals true, then return. And this is going to prevent the destroy function to be called multiple times. And if it's not equal to true, I'm going to say self.destroyed equals true. So it starts off as false. Once we call the destroy function, we check to make sure it's not already equal to true. If it's not, we say it's true, and that way this destroy function cannot be called multiple times. Let's now do the same on the client side. So over here, actually, we don't really need to do it on the client side because this destroy function is a private function which cannot be called by any other module. It can only be called by the server, and the server will only call it once. So there's actually no point having the check over here. We could just set destroyed to true like so. And now that we've done the destroyed property, let's now do the deconstruct property. So if we scroll down to deconstruct, instead of setting destroyed to true over here, we want to set deconstruct to true instead. Now we don't need to check this because this deconstruct function will only get called once, because it's only called by the destroy function over here. And this already has a check, so this deconstruct function should not be able to be called multiple times. So we don't actually need the if check over here. And let's do the same on the client side. So over here, instead of setting destroyed to true, we want to set deconstructed to true. Okay, so let's now go back to the tower handler. And when we despawn the tower, we do want to check if it's destroyed, because we don't want to despawn a tower that's already been destroyed. But over here, for selecting, we could use the deconstructed property instead of destroyed. So if deconstructed is equal to false, then we want to deselect the range part. And just so that we can see that this is working correctly, what I'm going to do is on the server side, when we destroy the tower, I'm going to make a print, and I'm going to say try destroy, and after the check, I'm going to say destroy. So we can see when we try to destroy and when we actually destroy. And then on the tower handler, over here, when we do this check, I'm not going to bother. I'm going to comment out this check, and I'm just going to blindly send the ID to the server and see if they listen to what I say. So I'm going to now play the game, and I'm going to press 1 to spawn a tower. Then I'm going to select the tower. I'm going to press delete, 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 delete. And if we check our output, we can see we tried to destroy it the first time and it was accepted, but these other tries were not accepted because it never printed destroy. So let's also test to see if that other error we had before has gone away. So I'm going to press 1 and then 2. Then I'm going to select tower 1. Then I'm going to press the delete key, and I'm going to wait for this tower to destroy. So the tower no longer exists, but my selected tower is still selected to that tower object. Then when I click on this tower over here, we see we no longer get the error because it no longer tried to set the transparency of the previous tower to 1. Okay, so let's go back into the tower handler. Let's bring this check back again, because even though it has no effect, it's just going to prevent unwanted events being sent to the server and wasting network data. And the next thing I want to do is go back to the tower. I'm going to remove these prints. Okay, so the next thing I'm going to add is the property of ownership. So currently a player can destroy any tower even if they never created it. So what I'm going to do is at the top, when we create a new tower, I'm going to create a new property over here called owner, and then I'm going to set this owner value into the tower's owner object. So I'm going to say self.owner equals owner, and I'm going to do the same on the client side. So I'm going to say name cframe owner, and I'm going to set the owner value inside like so. Now what we need to do is when we send a remote event to the client to tell them to create a new tower, we need to make sure that we send this owner value to them as well. So I'm going to scroll down, and over here when we tell the client to spawn a tower, we're going to send the name cframe, and then owner. So over here I'm going to squeeze in the owner property. Okay, so now if we go back to the player events, over here, before we destroy the tower, and we know there is a tower object, I'm going to say if tower.owner is not equal to player, then return. So we're not going to allow the player to destroy this tower if they're not set to this owner. Now, another thing we need to do is over here, when we create the tower, we need to make sure we pass in the owner value over here. So over here, I'm going to pass in the player as the tower owner. Also, even though this has no effect, I'm going to go to the tower handler. And over here, when we try to despawn a tower, I'm going to check to see if the owner of this tower is the player. So even though this check has no effect, it's just going to prevent us from firing events to the server for no reason and wasting network data. So I'm going to say if selected tower dot owner is not equal to game.players.localPlayer, then return. And just to make sure that this is working, I'm going to quickly play the game. I'm going to spawn a tower. I'm going to select this tower and press delete. And we can see that the server allowed me to destroy this tower because I'm the owner of it. Okay, so let's now talk about floating point errors. So to show you what floating point errors is, inside of replicate first, I'm going to create a local script and I'm going to add some code into this script like so. So I'm going to create a variable called value. Then I'm going to increment from 1 to 10 and I'm going to keep adding 0.1 onto this value and print the value. Now, if I play the game and then stop the game, we should see that instead of going 0.1, 0.2, 0.3, and so on, we can see that we get these weird numbers at the end of the numbers. And this is what is called floating point errors. So this should be 1, but here we can see it's 0.99999 instead of 1. Now, the problem with this is I'm not 100% certain if all clients will produce this exact same floating point error. So it may be that some clients, for instance, ones that are running on a x86 CPU, it will generate this floating point error, but maybe a client that's running on a Mac that's running a ARM-based CPU that's emulating x86 may produce a different floating point error. Now, I don't know this for certain, but I do worry that because our game is deterministic, and if two clients produce a different number, they could go out of sync. Now, one thing you may have noticed is throughout the game, I've did my best not to use decimal places like this and to always use whole numbers like this. So for instance, if we close this and if we look at our towers and look at the attributes, we can see that we have no decimal places. So damage is a integer number. It's not a value like 3.5. We've used a whole number like 3, and the same for all the other values. And if we look at our characters, we can see for health, we haven't used a value like 20.5. We've used whole numbers like so. Now, animation speed is only for decoration, so it doesn't really matter if they're slightly off on each client. The number here is not that important, but the health and speed is important. So we can see that they're integers and not floating point numbers. And throughout all of our code, you'll notice that we haven't really been using numbers with decimals, but there are only 2 cases where we have been using decimals. And that is when calculating the path C-frames and also to calculate the waypoints. And also when we do this part to get the waypoints from the tower. So we can see we're using the ray distance, and this distance is not a whole number, not an integer. So I'm not 100% certain if this distance will be exactly the same on all clients. And if this ray distance value is ever so slightly off from one client to the next, or if this distance value saved within the path is ever so slightly off from one client to the next, then when calculating this waypoint, let's go back to path and scroll down to get waypoint, we can see that we're rounding this distance value. So if one client has a distance value that is something like 0.499999999, and if another client has a distance value of 0.500000, so even though there's a very small difference between the two, this is going to round down for this client and it's going to round up for this client, causing the 2 clients to select a different waypoint. Now, the chance of something like this happening is probably very small, maybe 1 in a million. I can't really tell you because I don't actually know if clients can have a different floating point position error from one to the next. But just to be safe, let's make some changes so we can not have these problems. To solve this problem, what I'm going to do is I'm going to open the tower class on the server side, and the tower class on the client side. And instead of making the client work out the enter and exit waypoints, now currently this has been working fine. They have been working perfectly in sync, but just to be safe, I'm going to send this waypoint indices array to the client and have the client use this array instead of calculating their own array. This should be pretty simple to do. All I'm going to do is copy the waypoint indices array, and this just stores numbers, which is the index for each waypoint. And over here, when we fire to the client, after we send the owner, I'm also going to send the array. And then on the client side, over here, I'm going to receive waypoint indices. And so now that we're receiving this array, we no longer need to create our own one. So let's delete this. We also don't need to do all of this because the server is going to do it for us. So let's delete all of this. And we also don't need raycast perims because we're not going to be using that. So we can delete this. And we can also delete this up here because we don't need raycast perims. And I'm going to rearrange some of the stuff in here just to make it look a bit cleaner. So now we can move this to be over here before we parent the model. So I'm going to cut and paste this over here to have all this in one section. The other thing I'm going to do is, because we're now receiving the constructing tick over here, we can move this part to be near the top. So I'm going to cut and paste this to be above model, like so. And then I'm going to move this to go down here, like so. And I feel that this looks a lot more cleaner. Okay, so let's now test once again to see if our model towers work correctly, even though we're no longer calculating the enter and exit waypoint on the client side. So I'm going to create a tower number 3 over here, and I'm going to create a tower number 4 over here. And we should see that the destroy print gets called for both on the server and client. So when this character dies, we can see it destroyed on both the server and client. Okay, so now we no longer need to worry about floating point errors for towers. Let's now close the tower classes and let's open the server's path object and the client's path object and see what we can do to fix the floating point error problem over here. Now, one thing we could do is just send the C-frames from the server to the client, and then that way we know the client has the exact same C-frames as the server. But I'm going to do it slightly differently, but that is a good option. And even though there's going to be a lot of C-frames, because we're only going to do it once when they first enter the game, it shouldn't use too much network data. But the way I'm going to do it is I'm going to set an attribute on the path model that we have over here. So I'm going to say down here, say workspace dot path set attribute C-frames, and I'm going to set it to the amount of C-frames we've created. Now, because the position of the C-frames have no effect in our tower defense game, even if the C-frames that are calculated on the client side are slightly at different positions, it should have no effect on the way the game works. But as long as we have the same amount of C-frames, then we can be certain that they are going to stay in sync. And I'm also going to do the same for the waypoints array. So I'm going to copy and paste this. And I'm going to say waypoints equals self.waypoints. And now if we play the game and we select the path model, we can see there's two attributes for how many C-frames we have and how many waypoints we have. Okay, so now on the client side, after we've calculated the waypoints and C-frames, over here, I'm going to use the get attribute function. So I'm going to say, I'm going to copy these two over here. I'm going to change this to get, and I'm going to say local waypoints, and remove this over here, and do the same over here, local C-frames equals this, and remove this over here. Okay, so now the server sets the amount, and over here we get the amount. Now I'm going to make a while loop. So I'm going to say while self.waypoints is less than waypoints do, and I'm going to create another one and say while self.waypoints is more than waypoints. And I'm also going to do the same for C-frames. So I'm going to copy and paste these two while loops and change it to C-frames, and change this to C-frames as well. Okay, so if there are less waypoints than the amount the server has, all we're going to do is just insert more waypoints. So just like we did over here, I'm going to copy and paste this table insert to be over here. So we're going to insert a new waypoint using the waypoints index into the waypoints array. And if the client worked out more waypoints than the server, then all we need to do is remove waypoints. So I'm going to say table.remove, and I'm going to pass in the waypoints array, and we're just going to remove from the end of the list. It's going to pretty much work exactly the same for C-frame. If we have less C-frames than the server, we're just going to keep inserting the same C-frame at the very end. And if we have too many, we're just going to table remove the C-frames. Okay, and there we have it. So all I'm going to do now is just compress these down to a single line of code, just so they don't take up too much space in our script. Now, another thing you guys might want to do is merge these two path objects together on the server and client, because there's only a very small amount of difference between the two. The server only has this code extra, and the client only has this code extra, but everything else about these two modules are exactly the same. So what we could do if we really wanted to is at the top, I could get the run service. And then over here, I can say if run service is server, then else. And if it's the server, I'm going to do these two lines of code that we wrote over here. And if it's the client, I can do these lines of code that we did over here. And now, even though they are slightly different, we can share the same path module between the client and server. So what I can do is delete this path module on the server side, create a object value, give this the same name as this module over here as path, and then make it point towards path. So now if we play the game, we should see that everything seems to work correctly. We can see that the attributes are being set correctly. Okay, so let's now limit where the clients are allowed to place towers. So what I'm going to do is inside of Workspace, I'm going to create a new folder, and I'm going to name this folder Platforms. And inside of this folder, I'm going to create a new part, and I'm going to anchor this part, and I'm going to resize the part, and I'm going to move it over here and slightly rotate it like this. So now I'm going to make it so the client can only place towers on this part. But let's duplicate this and make another one over here. just to give them some extra options. Okay, so now I'm going to go into player events, and at the top of this object, I'm going to create raycast perims, and then I'm going to set the filter type to be include only, and then I'm going to set the filter to be the workspace platforms folder. So I'm going to say filter descendants indices, and I'm going to pass a table pointing to the platforms folder. And now when we create a new tower, before we create it, I'm going to do a raycast using the C frame that the client told us. So I'm going to say if workspace raycast, I'm going to use the start at the C frames position. I'm going to slightly offset it up by 0.1, just so that we give a little leeway to the client. And then I'm going to raycast downwards using the up vector, which is a negative up vector, so it goes down. And I'm going to use multiplied by 0.2. And then I'm going to pass in the raycast perims so that it can only collide with the parts inside of this platforms folder. Now, if the raycast result is equal to nil, I'm going to return and not allow them to create a tower. We should see if I press 1, 2, 3, 4 on the base plate or the spawn pad, doesn't work. Nothing over here works. But if I press number 1 over here, number 2, 3 or 4, it works. And if I press 1, 2, 3 and 4 over here, it works. And even though this has no effect, let's also go to the tower handler and do the check to make sure we're trying to place a tower on top of these parts, because this is going to prevent remote events being fired for no reason from the client to the server. So over here, when we spawn a tower, after we've checked if the raycast results exists, what I'm going to do is I'm going to say local folder equals raycast result.instance find first ancestor of class folder. So whichever part we raycast on, we're going to see which folder that part is within. And then I'm going to check to see if this folder is this folder over here. So I'm going to say if folder is not equal to workspace platforms, then return and do nothing. But if it is, we're going to calculate the C frame, and then we're going to send this to the server. Okay, so let's now talk about the game object. So if we go back to the game object on the server side and client side, we should notice that when we start the game, we fire an event to the clients, and then the clients start the game on their side. But the problem with this is if the client has not entered the server and the server starts the game before the client enters, then the client is going to miss this event and the client is never going to start the game. Now, an easy solution to this problem is to simply wait before you start the game. So make sure that all the players have entered the server before starting the game. That way all players should get the start game event. But what if you don't want to wait for players? What if you want players to be able to enter halfway through the game has started? Well, another alternative is instead of having a game start event, we could have a round start event. So what that means is every round, the server sends an event to the client telling them to start a single round. And every round is going to have its own seed value. So that means that if a client enters the game too late and misses the first round or the second round, once they get round to the third round, they will still get to see the third round because the server will send a new event for the third round, and so on and so on. And if they exit the game and then come back on round 100, they will skip round 100, and then once the server sends the event for around 101, they will receive that event, and then that player will get to see round 101. Another thing you're going to need to worry about if you allow clients to enter the server after the game has started is the towers. So the server may have some towers already in game, and this tower counter is going to be higher than 0, but when the client enters, their tower counter is going to be equal to 0, and they're not going to have any towers. So when a player enters, if you allow them to enter after the game has started, you're going to have to send all the towers as soon as they log in and give them the correct ID numbers for each tower. Okay, so let's now clean up our debugging parts so we can't see any debugging parts anymore. So the first thing I'm going to do is I'm going to hide these green parts for the path. So I'm going to go into the path object, and over here where we loop through the parts, I'm going to say path.transparency equals 1. So now if we play the game, we can see that these green parts have been hidden and we can no longer see them. The next thing I'm going to do is I want to hide all the waypoints. So I'm going to comment out this loop over here. And if I now play the game, we should no longer see the waypoints along the path. But we should still see the debug parts. So if I create a tower over here, we can see these parts over here and this part over here. And if I create some more towers over here, we can see the waypoints like so. So let's hide them as well. I'm going to open the tower class on the server side. And over here where we create the debug parts, I'm just going to comment this out and this one out over here as well. And now if I play the game, and if I create some towers, we can see that these waypoint parts are no longer created. And finally, I'm going to get rid of these destroy prints. So I'm going to open character on the server side, and I'm going to comment out this warning, and I'm going to open the character on the client side and get rid of this warning over here. And there we have it. We've removed all the debugging parts of our project. And while playtesting, I ran into another problem, and it's only a small little problem we made. So the problem is, what's happening is we're doing a wait here, and then after this wait, we're placing this explosion at the model's torso position of the character. But by the time this wait completes, it's possible that another tower destroys this character. And if this character is destroyed, it's no longer able to find this torso. So here we can see torso is not a valid member of model. So an easy way to fix this is if we look at our projectile class, we can see that when we set the target, we save this target as self.target. And if we go back to tower functions, so all we need to do is get the projectile object, instead of using the character model torso variable to get access to this torso, we can reference it through this target variable. So over here, I'm going to say local projectile equals, and then over here, instead of using torso.position, I'm going to use projectile.target position, and this should link to this torso that was destroyed, and that should also allow us to get the torso's position. And I think I'm going to end the video here, so hopefully this should be enough information to help you guys create your own efficient tower defense game. Thank you for watching the video, and if you have any questions, feel free to leave a comment down below.